Whiteboard animation A to Z. Welcome to A-Level Math P1 complete course. Okay, so let's start with the introduction. First of all, what we're going to cover is we're going to cover all the topics from topic 1 to topic 9, and then obviously the timeline is in the description for you guys to access it more easily. So make sure to give the comment, ask me anything, and ready your pen and notebook. Let's get started. And welcome back. This is A-Level Math P1, and today our topic is topic 1, Binomial Theorem. And then we're going to do some exam questions. So let's begin. What is binomial theorem? Let's start with this description. A polynomial of the sum or difference of two terms. It is a word used in algebra that roughly means two things added together. Now let's say that a plus b square is equals to a square plus 2ab plus b square. Okay, but what happens if we get a plus b cube? So a plus b square multiplied by a plus b, but what happens if we've been asked to define this of power 5? So it's going to be a very difficult, it's going to be time wasting. So right now we needed a formula that could easily expand any equation with bracket form, whatever the power of n. So thankfully we have the formula, and now we're going to discuss about what is the formula. So starting with part 1, starting with this one, the formula is a plus b bracket of power n, and the bracket of the n must be a positive integer for now in A-Level Math P1. But when we will move on in A-Level Math P3, then the power m can be both positive and negative. In A-Level Math P1, we're going to understand what happens if the n is a positive integer. Okay, is equals to nc0. N is the power, and nc0, c is a combination which comes in A-Level Math S1, but we're going to understand it later. For now we just need to understand what ncr is. So ncr, n is the power number, r is the range from 0 to n, nc0 matlab a, n of n minus 0 matlab b of power 0. So as we go along, the power of a decreases, and the power of b increases. So it just, the power of a decreases and the power of b increases, plus nc1 and then nc2, and the value of r changes from 0 to n. And part 2 is the same thing as part 1. The only difference is that the value of a is 1, and it's the same thing. This is a formula, and this topic is very small. Okay, now we're going to jump to questions. Question 1, find the coefficient of x cube in the expansion of this and this. Let's start with 1, and I'm going to and right now I'm going to try my best to do it as fast as possible. So just look what I'm doing. Let's start with part 1. Okay, 6c0 multiplied by 1, since this is a, multiplied by 2x of 0, then plus 6c1 multiplied by 1, 5. As you can see, the power is decreasing of a, and 2x 1, and the power b will increase, and we need to find the coefficient of x cube. So we're going to keep on moving. 6c2 multiplied by 1 of power 4 multiplied by 2x square, plus 6c3 multiplied by 1 of power 3 multiplied by 2x of power 3. So we're going to take this since there is a coefficient of cube whenever we take a power of 3 of x in order to find this value of 63. So I'm using my calculator, and it's need to be scientific. So 63 is 20, so I'm going to write 20. 20 multiplied by 1 multiplied by, 2 of power 3 is 8 multiplied by x of power cube. So 20 multiplied by 8 is equals to 160. This is the answer. This is the coefficient of x cube. This is what we need to find. Okay, now we're going to do part 2. So part 2 is, okay, since we have already expanded this, so we don't need to do any kind of work. Just write it down this, and then we already made an expansion. Okay, we also need to find the coefficient of x cube in part 2 as well. Okay, so first of all, let me make a simplification. 60 is 1 multiplied 1 multiplied 1, so it's going to be 1, plus 61 is 6 multiplied by 1 power 5. Okay, 6 multiplied 2 is equal to 12. Okay, then 62 is, I'm going to use a calculator. 62 is 15 multiplied by 2 of power 2 is equal to 4, so it's going to be 4 square. Okay, I'm going to write it down. 15 multiplied by 4, 60 x cube, and then we already know what is the coefficient of x cube. 60x squared plus 160x cube. Okay, write it down in here. We already know the we've already made an expansion. Okay, now we're going to multiply it just to find the coefficient of x cube. Okay, 160. We can multiply this to this. So it's going to be minus 3 multiplied by 60 is 180. So minus 180 cube. So the answer is minus 20x cube. This is the answer. So question 1 is done. Now we're going to move to question 2. Find the coefficient of x in the expansion of this 3x minus 2 upon x of power 5. Let's start. 5c0. 3x of power 5. Since we need to find the coefficient of x. So I can see that this will cancel out this x. So let me write it down. 5c2 is 10. So 10 multiplied by 3 of power 3 is 27. X cube multiplied by, okay, 2 to the 4 and minus will be eliminated. 2 to the 4. Minus 2 multiplied minus 2. So 4. 4 upon x square. Cancel out this to this, leaving only x. And then 10 multiplied by 27 multiplied by 4. It's going to be 1080. This is the answer. This is the coefficient we've been looking for. Question 3. Find the first three term in the expansion of 2 minus x of power 6 in the in ascending power of x. Part 2. Find the value of k for which there is no term in x when the expansion of 1 plus ks and 2 minus x. Let's start with part 1. We just need to find the first three terms. We need to find the first three term of this. 600. Find the first three term in the ascending power of x. So first three term is 64 minus 6 multiplied by 32, 192, plus 15 multiplied by 16, 240, minus 160. So this is part 1. Now we're going to do part 2. And part 2 is, okay, we only do the first three terms, and also find the value of k for which there is no term in x square. For which there is no term in x square. Okay. So there is no term in x square. No coefficient of x. The coefficient of x square is 0. Is equals to, okay, 1 multiplied by 240. So I'm going to write it down 240. Kx multiplied by minus 192. So minus 192 kx square. Okay. Okay. X square is cancelled out, leaving only the, okay, 192 k 240. Now I'm going to divide by 240 upon 192. So it's going to be 5 upon 4. So this is the answer. And I just checked with my marking scheme. I have it right there. So it is 5 upon 4. The first three term in the expansion of 2 plus ax of power n in ascending power of x are 32 minus 40x plus bx square. Okay, what we need to do is we need to find the value of n and a and b. They are already telling us that these are the first three terms, and we have to find the value of b, finding the value of a in here, and value of n. Let me write it down in here. As usual, let's expand it. And c 0 multiplied by 2 of power n multiplied by ax of power 0. Okay, the first term is 32, so I'm going to compare. I'm going to write this that nc0 is 1, 2 of power n remains. So 2 of power n. And also now we're going to use the logarithm. Obviously, you guys don't know that. It is in A-level math P3, but I think I'm going to write it down. And it's really easy. First of all, what I'm going to do, okay, let me make it simpler. 2n32. Okay, I'm going to write log. Okay, here's the log. 2 is the base, so I'm going to write 2 in here. 32 is the opposite number, so I'm going to write in bracket 32. And you need to use the calculator. And I'm going to write 2 is equals to 32. Okay, what is the value of n? I'm going to use the calculator. It's 5. We have find the value of n. It is 5. Now I'm going to see the second term. The second term is for minus 40x. So minus 40x. We know what is the value of n. N is 5. So 5c1 is 5. 5 multiplied by 2 of power 4 multiplied by ax. Okay, now we're going to find the value of a in here. Let me make it more simpler. 5 multiplied by 2 of power 4. It's 80. 80 x is cancelled out. Minus 40 upon 80 is minus 1 upon 2. Minus 1 upon 2 is the value of a. Part, okay, third term. Now we're going to compare the third term. The third term is bx square. Write it down. Bx square is equal to, okay, 5c2. What is 5c2? 5c2 is 10. 10 multiplied by 2 of power 3 multiplied by a square and x square. We already know what is the value of a. Okay, so I'm going to simplify it more. 10 multiplied by 2 of power 3 is 80. 80 multiplied by, okay, minus 1 upon 2 square multiplied by x square. Okay, I'm going to use a calculator. Minus 1 upon 2 square. So it's 20. Okay, I don't want you guys to think that there is minus. There is no minus. It's positive. Okay, 20. 20 x square bx square. So the value of b is 20. So this is the answer. Question 5. Find the first three terms. As always, first three terms in the expansion of 2 plus u in ascending power of u. Part 2, use the substitution. U is equal to x plus x square. New answer to part 1. Find the coefficient of x square in the expansion of 2 plus x square. Okay, starting with part 1, need to find the first three terms. Here you go. 2 plus u 5. Okay, 5 c 0. 2 power 5 0. Now let's simplify. 5 c 0 is 1. 2 to the power 5 is 32. 2 to the power 32. So your first term is 32. 5 c 1 is 5. 5 multiplied by 2 to the power 4. 80. 80 u. 5 c 2 is 10 multiplied by 2 to the power 3. 80. Can 80 u square. Part 1 is done. This is part 1. Part 2. Now we need to use the substitution. Okay, use the substitution this and you answer to part 1 to find the coefficient of x square. Okay. I've already done the x substitution. Okay, x plus x square 5. And it says that find the coefficient of x square. Find the coefficient of x square. Okay, already done the simplification. 80 multiplied by u. U is x plus x square. Okay, plus 80 multiplied by u. X plus x square power 2. Coefficient of x square. I'm going to multiply to this. 80 x square. I'm going to multiply it. Okay, first of all I need to explain this one. So it's going to be 80 multiplied by x plus, okay, x square. 2 x cube plus x 4. Okay, multiply 8 to x square plus 80 x square is equals to 160. Answer. Okay, so part 5 is done. Question 6, find the first term in the expansion of 2 minus x 6 in ascending power of x. Okay, the first term in the expansion of this. Okay, these are the first three terms, simplified. 60. Okay, so these are the first three terms. Part 2, given that the coefficient of x square in the expansion of this, 1 plus 2x plus ax square multiplied by 2 minus x is 48. Find the value of the constant a. Okay, let me just copy it. 1 plus 2x plus x square and same as above. Okay, maybe I should write it down in here. 2x, this is a. This is ax square multiplied by 64 minus 192. Okay, in here it is 192x. Forgot to mention that. Forgot to write it down. 240 x square. Okay, the coefficient of x square. Find the coefficient of x square first. 1 multiplied by 240. First one I'm going to write it down. 48. The coefficient of x square is 48. So 40x square is equals to 240. Okay, 2 is multiplied by minus 192. Minus 2 multiplied by 192x square. And ax square is multiplied by 64. Plus 64 ax square. Okay, let me just simplify these three and put it on the left. So 48 minus 240 plus 2 multiplied by 192. 1. Okay, so it's going to be 192 x square. 64 ax square. And 192 upon 64 is 3. So a is equals to 3. This is the value. Question 7, part 1. Find the finite term of the non-zero constant k. The first 4 terms. Non-zero constant k, the first 4 terms in the expansion of this k plus x. So let's start with part 1. So it's k plus x of power 8. And we need to expand it. Okay. 8c 0. 8 x 0. First 4 terms. Okay. Let's simplify it. 8c0 is 1. So remaining is 8 of k of power 8 plus 8c1 is 8. 8 k of power 7 x. 8c2, what is 8c2? 8c2 is 28, so 28 k of power 6 x square. What is 8c3? 8c3 is 56. 56 of power 5 x cube. Part 1 is done. Okay, part 2. Given that the coefficient of x square and x cube in this expansion are equal, find the value of k. Alright. Is equals to 56 8 of power. Okay, 28 of 6, 56 of k 5. Cancel out, remaining only k. So 56 upon 28 k. Using a calculator. 2. answer. This is the answer. Question 8. Find the term independent of x in the expansion of x minus 1 upon x square and the power of 9. X minus 1 upon x square with the power of 9. So 9, C, 0. This is 9. And this is 0. Okay, we will stop right here. I'm going to simplify it. 9, 9c3, 84, minus 84, x of power 6 multiplied by 1 upon x of power 6, 3 to the 6, so 6, 2 of only minus 84 as the answer. Question 9, the coefficient of x cube in the expansion of a plus 1 minus 2ax power, where a is positive is 90, find the value of a. So the coefficient of x cube in the expansion of this is 90, remember that, okay? So right now I need to make a I need to expand these, or the coefficient of x cube, okay. I will expand to first three term which each brackets. Okay, question 9, the coefficient of x cube in the expansion of a plus x plus 1 minus 2x is positive is 90, find the value of a. The coefficient of the coefficient of x cube is 90. Right now we have this equation in front of you, and I need to find the value of a. So what I'm going to do, I'm going to expand each of these into first 4 terms only. Let's start with first part, a plus x. Terms plus okay. Now let me simplify it. A of power 5 plus 5c1 is 5. 5c2 is 10. 10. And 5c3 is 10. Plus 6c0 is 1. So it's going to go complete 1. Actually 6 multiplied by minus 2x. Now 6c2 is 15. So 15 multiplied by minus 2x square, 20. So 20 multiplied by minus 2x power 3. Okay, so it's here, this one is here, this one is here, and this one is here. Okay, we know that the coefficient of x cube is 90. Okay, since we know that it is 90, we're going to make a multiplication, or maybe not, no multiplication, it's actually addition. So 10a square cube plus 20 multiply minus 2x power cube square, and when you make it under square, square root, when you take a square root, it's going to be 5. This is the answer. Question 10. The first three terms in the expansion of 1 minus 2x 1 plus ax in ascending power of x are 1 minus x plus bx square. Find the value of the constant a and b. Okay, I'm going to expand each of these to first three terms. Okay, so 1 minus 2x square multiplied by, okay, I just no need to write, I'll know that, 6. Expand it to c0 power 2 multiplied by minus 2x0. Okay, multiplied by 6c0 1 of power 6 0 plus, okay, done. Now let's simplify it. Okay, now 6c0 is 1 power 6 is 1. Okay, it's completely 1. 61 is 6. So okay, done. We have done it. Now we know that these are the first three terms, so we're going to make it equal. First term is 1 1 1. Okay, second term is minus x, so second term is minus x, so minus, okay, I'm going to make a multiplication, this to this multiplication, so it's going to be plus 6ax and minus 4 to 1, so minus 4x. Okay, so x is cancelled out, remaining only minus 1, 6a and minus 4. Okay, the third term is bx square, so bx square. Okay, so the third term is bx square, so 1 is multiplied by 15ax, so 15a square x square. Okay, and minus 4 is multiplied by 6ax, so minus 4 multiplied by 6 is 24, so minus 24, and we know what is the value of a, so 1 upon 2 and x. Okay, and 4x square is multiplied by 1, so plus 4x square. Write it down again, bx square, we know what is the value of, okay, a, so 15 upon 4 x square minus 24 upon 2 is 12 minus 12x plus 4x square. Okay, so this is actually x square. Forgot to write it down. This is the answer. So congratulations, we have ended the topic binomial theorem. So I hope that you guys have understood what is binomial theorem and how to solve these type of questions. And honestly, I just took these questions from the past papers and I just compiled it all, the most unique one. Okay, so hopefully this video will have helped you guys a lot. Must have helped you guys a lot. And let me know in the comment below if you have any problem. You can ask me. Okay, good luck. Thank you. Goodbye. Hello and welcome back, and in this video we are going to learn about topic 2, arithmetic progression and geometric progression. In the previous video we discussed and understand topic 1, binomial theorem, and now it's time for topic 2. So let's begin. Let me start with arithmetic sequence. Let's say that the first number is 5, and now I'm going to add 2. And again I'm going to add 2. And again. And again. And so on. And let's say that I have a number 3, and I'm going to subtract minus 3. So it's going to be 0, and again. 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 And so on. So these two sequences are arithmetic sequence because arithmetic sequence is a sequence whose terms go up or down by a constant step. The difference between each consecutive term is d. So if we want to find the common difference between the two numbers, then we can use the formula, use this, d is equal to t2 minus t1. So in this case 9 minus 7 is 2. And if you want to find the common difference of the sequence 2, then we can use the same thing as before, t2 minus t1. Let's say minus 9 minus 6, then it's going to be minus 3. And let's say that we have been asked for in sequence 1 that what is the sequence of 75, which means that what is the number of the 75 position of the sequence. So how on earth are we going to understand? So it's going to be really difficult to find out what is the value of the 75 sequence. So in order to find this, we're going to use the formula for the arithmetic sequence, and it is Tn is equals to a plus n minus 1 multiplied by t. Tn is a specific term. A is the first term, n is the number of term, and d is a common difference. So this is the formula. This is the formula for arithmetic sequence. Okay. Now we have discussed what is arithmetic sequence, but what is arithmetic series? The arithmetic series is the sum of all the terms of an arithmetic sequence. It's called arithmetic series. So it's actually a sum of terms. Which means that let's say that see this the first sequence. What if I wanted to know that for example that these are 5 terms, 1, 2, 3, 4, 5, and I want to know the sum of these 5 terms. So I'm going to use a formula. The formula is Sn is equals to n upon 2 multiplied by 2a plus n minus 1 multiplied by d. So let's say that of the first sequence I want to know the sum. So first sequence. So I'm going to find out the sum. What is the sum? N means there are five numbers of the sequence, and the first term is 5. Okay. Plus n. Okay, so there are 5 terms minus 1, and the common difference is 2. Now I'm going to use a calculator. So it's going to be 45. There you go. So this is arithmetic series. Arithmetic sequence is a sequence, and in order to make a sequence, you need to have a common difference. Okay, and whenever we've been asked that what is the number of the 75 position, or what is the number of 100 position, or what is the number of 125 position, then we're going to use this formula. Tn is equals to a plus n minus 1 and multiplied by t. Okay, this is arithmetic sequence. But if we've been asked that, okay, so this is a sequence. Now I want to know the sum of all these 10 number of this sequence. So I'm going to use arithmetic series, and this is the formula. So there are basically 2 formulas for the arithmetic. Now we are going to understand what is geometric. We are going to understand what is geometric sequence. A geometric sequence is a sequence in which you get from one term to the next by multiplying a constant. In arithmetic series, we try to add the constant, add or subtract the constant. But in geometric sequence, we are going to multiply by a constant. It's called a geometric sequence. and multiplying by the same number each time. This number is called the common ratio R. In the arithmetic sequence, we call it the D, called the common difference. But in geometric sequence, we're going to call this common ratio R. For example, let's say that I have let's say the two number is 2, and I'm going to now multiply by 5. 2 5 are 10, then again 50, then again 250, and so on. So the common ratio is 5. Okay, and let's say that we want to find out what is the common ratio. In order to find the common ratio, we will divide the second term to the first term. For example, 10 upon 2 is equals to 5. And let's say that we have been asked what is the position, or what is the number of the 75 position or 78 position. Okay, so in order for that, we are going to use the formula again, just like the arithmetic sequence. There's a formula for arithmetic. There's a formula for geometric sequence as well. So the formula we are going to use is Tn is equals to a multiplied by r minus n minus r n minus 1. So Tn is a specific position, just like in arithmetic, but different. A is the first term. R is the common ratio. And n is the total number of position. Total number, you can say. Total number of terms. Okay, so this is the formula for geometric sequence. This is geometric sequence. We try to multiply a common ratio in order to make the sequence. But in arithmetic sequence, we try to make an addition or subtraction in order to make a sequence. But now, okay, now we're going to understand what the geometric series is. Geometric series. The sum of all the terms of the geometric sequence is called the geometric series. Again, the sum. And the formula for using the sum is, let me write down the formula. It is equals to a1 minus nr 1 minus r. You can write it this way, or you can write it this way as well. It's the same thing. I'm going to write it down. Okay, you can write any one of them. It's the same thing actually. So get convergent. Sequence. Convergent sequence is something that whenever when the sequence is convergent, it tends to a different value. It keeps getting closer and closer to a certain value. So convergent sequence is sometimes in geometric sequence. For example, let's say that the first term is 1 and the common ratio is 0.2. So 1 multiplied by 0.2 is 0.2. And then 0.04, and then 0.008, and then 0.0016, and you can see that it is keep getting closer to 0. Okay, if this is how the sequence is, and in order to make up the sequence, the r value must be in this range in order to make up this sequence. And we should understand that we should understood that as the total number of terms goes to infinity, then Rn will keep getting closer to 0. Since we know that the formula is Tn is equals to a multiplied by Rn minus 1. So as the value of n getting closer to infinity, it's going and going and going, and it's keep on decreasing. So then it's going to be getting closer to 0. Okay, and let's say that I want to okay, and here's another interesting fact. Let's say that I want to know the sum of all this, the sum, and by getting the sum, you will see that it is you will get a certain value, which means after getting all the sum, you will come to a certain value, approximate certain value. That is what we can call it, the sum to infinity. Okay, so what is the formula for sum to infinity? This is the sum of infinity, the formula. This is the formula. And it must be remembered that in order to use this formula, we need to make sure that that we have this condition as well, that r must be less than 1 and r must be greater than minus 1. This is convergent sequence. And now let's start with the questions. Terms of the geometric progression. First 10 terms of the geometric progression. Okay, since we need to find the sum, we're going to use the sum formula. Is equals to a 1 minus r on 1 minus r. Okay, first of all, we need to find the common ratio. So the common ratio is 54 upon 81. I'm going to use a calculator. 54 upon 81, so it's going to be 2 upon 3. That's the common ratio. This is the common ratio, and since it's saying that we have to find the sum of the first 10 terms, so 10 terms mean total number of terms are 10, and the first term is 81. Okay, now I'm going to use this formula. Sum is equals to 81 multiplied by 1 minus 2 upon 3 10. Okay, 1 minus 2 upon 3. I'm going to use the calculator. So the answer is 238.8. Okay. So this was part 1. Now let's do part 2. The part 2 is the sum of the sum of all the terms in the arithmetic progression is okay. We need to find the sum of all the terms. So last term, this is the last term. Okay. Going to part 2. Okay, so this is the last term, which means what is the number? What is the position number of the last term? So I'm going to find out what is the position number of the last term. A plus n minus 1 multiplied by d. Tn comes to 25. A is a180. And we need to find n minus 1 multiplied by n d. What is d? You can see that 175 minus 180, so it's actually minus 5. This is d. So minus 5. Okay. Let's expand the bracket. Minus 5n plus 5. Now I'm going to use a calculator. Okay, so it's 32 and it's 32. Now let's make a sum. The sum, okay, s n is equals to 32 upon 2 multiplied by 2 multiplied by 180, since this is the first term, and 32 minus 1 multiplied by the common difference 5. I'm going to use the calculator now. The answer is 3280. Okay, so this is question 1. Now let's move to question 2. In an arithmetic progression, the sum of the first 10 number terms is 400 and the sum of the next 10 term is 1000. Find the common difference in the first term. Okay, find the common difference in the first term. So it's saying that the first 10 terms, let's say 10 terms, is 400 sum, and the next 10 terms is 1000. Okay, so the 20 terms altogether is 1400. Okay, so the first term, it says that in an arithmetic progression the sum of the first 10 terms is 400. Okay, sum of the first 10 terms, so I'm going to write it down. 400 is equals to 10 terms. I don't know what is the first term, so I'm going to write it down anyway. 10 minus 1, and I don't know the common difference. This is equation 1. Now it's saying that the sum of the next 10 terms is 1000, or I can just say that the sum of the first 20 terms is 1400. So I'm going to write it down 1400. Okay, I got the second equation. And now what I'm going to do, I'm going to make a simultaneous solve, either by using a calculator or by using my hand. So let me just use my hand instead. Okay, so 400, 5, 2, and 90. This is the first equation, and the second equation is 1400, 10, 2 plus 19d. Okay, let's make it more simply. Make it more simpler. 400 upon 5 is 80. And 1400 upon 10 is 140. Okay. Now using a simultaneous equation, simultaneous solve, I'm going to, here you go, 80 minus 920, so it's going to be 2a, and I'm going to put 2a in 140 minus 90d. Okay, and doing all that, it's going to be 60, and so d is equals to 60. Here you go, we got the common difference, and then putting this value in any of the equation. Let's say I'm putting in here, so it's going to be 140 2a plus 19d multiplied by 6, and the value of a will be, I'm going to use a calculator, 140 minus 19 multiplied by 6 upon 20, so it's going to be 13. And there you go, voila. So this was the first term, actually it was the first one, just done it. This is the answer. Now I'm going to remove it. Part 2. A geometric progression has first term a, common ratio r, and sum to infinity 6. A second geometric progression has first term 2a, common ratio r square, and sum to infinity, and find the values of a and r. Sum to infinity is the formula for sum to infinity is 1 minus r. And since we have these two types of geometric progression, so the first one is a1 minus r, and this is going to be 6. Okay, and the second one is has a sum of infinity to 7, has like a 2a, first term is 2a, and the common ratio is r square. I could write it down to in this way, 1 plus r and 1 minus r. Okay, then I'm going to put 1 minus r here, and 2a 1 plus r multiplied by 7. Now I'm going to a upon 6. Okay, I got these two. I'm going to do simultaneous solve. I'm going to put this value to this, and here you go. A upon 6 to a upon 1 plus r multiplied by 7. A is cancelled out, 6 to the 12, so in the upper hand is 7 is equals to 12. And then doing all that, you will get what will you get? You will get 5 upon 7. You will get 5 upon 7. This is the value of r. And now you could put this value of r in any of the equation. Let's say I'm putting in here. Okay, so 1 minus 5 upon 7 is equals to a upon 6. I'm going to use a calculator and I'm going to find the value of a upon 7. 12 upon 7. Answer. Question 2 is done. Let's move to question 3. Question 3. An arithmetic progression has the first term minus 12, the common difference 6, and the sum of the first n terms exceed 3000. Calculate the least possible value of n. 3000 exceeding 3000, n upon 2 multiplied by minus 12 is the first term, plus n minus 1, and 6 is the common difference. Let's simplify things. Minus 24 x n minus 6, again simplification, minus 30 plus 6n, and I think it's going to go convert into quadratic equation form square, and I was right. 6n square minus 30 minus 6000. Okay, my dear fellows, you can either use a calculator, which I'm using right now, or you can just do it by hand in order to solve the quadratic equation. So right now I'm just going to use a calculator. 6 minus 30 minus 6000. Okay, so I got these two values. The first one is n34.2, and the second one is minus 29.2. Okay, right now I just want you to see that this is the y-intercept. Okay, this is the y-intercept. I'm just going to draw a graph. Y-intercept, so this is minus 6000. Okay, so this one is positive, which means it's going to be a smiling curve. We got these intercept, so it's in here and it's in here. Minus 29 and 34. Okay, and it's going to become a smiling curve. And now we can see that 0 is greater than. So it's going to be here or here. Which means n greater than 34.2 and n less than minus 29. Since n is a minus, so it's going to be wrong. This is positive, so it's going to be right. So n greater than 34.2 n, which means n is equals to 35. This is the answer. Question 4. The first two terms in arithmetic progression are 5 and 9. The last term in the progression is the only term which is greater than 200. Find the sum of all the terms in the progression. Okay. The first two terms in an arithmetic progression are 5 and 9. Okay. 5 and 9. The last term in the progression is the only term which is greater than 200. Okay. Only term which is greater than 200. Find the sum of all the terms in the progression. Okay. It must be greater than 200. This is the last term, and it must be greater than 200. Okay, it's greater than 200. Formula in here. Okay, so it's a plus n minus 1 multiplied by d greater than 200. Simple. The first term, I need to find the first one. The first term is 5. Okay, here you go, 5 n minus 1, and the common difference between these two numbers is 4. So multiply by 4 greater than 200. 200 minus 5. You know what? 200 minus 5 and then upon 4 and minus 1. Using a calculator, 200 minus 5 and upon 4 is 195 upon 4. And minus 1 is greater than. Okay, n is, the value of n is 195 upon 4 plus 1. 199 upon 4. 199 upon 4, which means this is 49.75. So it's going to be 50. Okay, this is the value. Find the sum of all the terms in the progression. Now I need to find the sum of all the terms. So Sn is equals to 15 upon 2 multiplied by 2 multiplied by 5 plus 50 minus 1 multiplied by 4. Now I'm using a calculator directly because it's so easy. 5150 as an answer. Okay, question 5. A circle is divided into 6 sectors in such a way that the angles of the sectors are in arithmetic progression. The angle of the largest sector is 4 times the angle of the smallest sector. Given that the radius of the circle is 5 cm, find the perimeter of the smallest sector. Okay, first of all, you need to understand that a circle is divided into 6 sectors. What is the total angle, 360 angle of a circle? Okay, so a circle is divided into 6 sectors, which means there are 6 numbers in such a way that the angles of the sectors are in arithmetic progression. Okay, so there are 6 numbers. There are 6 total numbers. I'm going to use the formula of the sum. What is the sum? 360. How many numbers? 6 upon 2 multiplied by 2a. We don't know what is the first value, plus 6 minus 1 multiplied by t. We don't know the difference. Okay, so this is the equation. 720 6 2a 5d 720 12a 6 5 the 30 d. Now let's divide it by 3. 3 to the 6, 3 to the 6, 3 4 the 12, 3 5 the 50, 3 4 the 12, and 3 10 the. Now by 2, 120, 2 and 5. Okay, so we have this equation now, this equation 1. Okay, now we need another equation now to make a simultaneous solve and to find the value of a and d as well. A circle is divided into 6 sectors in such a way that the angle of the sectors are in arithmetic progression. Okay, the angle of the largest sector is 4 times the angle of the smallest sector. Okay. The largest sector is 4a is equals to a plus n minus 1 d. So 3a is equals to n minus 1 d. And since we know the last sector is a 6th number, so it's going to be 3a 6 minus 1 d. So 3a is equals to 5d. Okay, we got the second one. Now we're going to substitute this equation to this one. This is equation 2. We're going to substitute this. So 5 upon 3d. So 120 is equals to 2 multiplied by 5 upon 3 d plus 5d. So 5 is a 10, 10 upon 3, 5d. 120, 10d, 15d on 3, and I'm just going to use a calculator directly. Okay, given that find the perimeter of the smallest sector, find the perimeter. Okay, you need to find the perimeter. So one thing for sure, first of all, find the circumference. 2 pi r multiply by, since we know that the value of a is, okay, we didn't find the value of a, so we're going to put in here to find the value of a. 5 upon 3 multiplied by 72 upon 5, and it's 24. Okay, so the first term was 24. 2 pi r multiplied by 24 upon 360 degree. Since we need to find this, this is a sector like a pizza slice. This is an arc length. We need to find the arc length, and we already know what is the radius. So 5 5. So in order trying to find the arc length, we're going to use this. This is the angle of the smallest sector, 24. So 24 upon 360. This 2 pi r is the circumference, as we all know that circumference. Okay, so 2 pi 5 multiplied by 24 upon 360, and I'm going to use a calculator. 2 pi multiply 5 multiply 24 upon 360, so it's going to be 2 upon 3 pi. Okay, good. So now we need to find the perimeter. We already got 2 upon 3 pi, which is the arc length, plus radius. So this is the perimeter of the smallest circle, of the smallest sector. 5 plus 5, so it's 12.1. This is the answer. Okay, part 1 is done. Now part 2 is completely separate from part 1 though. The first, second and third of and the third term of a geometric progression are 2k plus 3, k plus 6 and k respectively, given that all the terms of the geometric progression are positive. Okay, calculate the value of the constant k and the sum of the infinity to the progression. Okay, so it's a geometric progression. I'm writing down in here 2k plus 3, k plus 6, okay, and k. I want to know what is the ratio, what is the common ratio. So I'm going to divide by this to this, k plus 6, which is you can say t2, t1 or t3, but it's so simple, you know. All I'm doing is just finding the common ratio, and the same thing as t3 upon t2, it will give the same common ratio, remember that. Now I'm going to substitute to this k plus 6 upon 2k plus 3, k upon k plus 6. Okay, so k plus 6 square, k square plus 3k, now k square 12k plus 36 is equals to 2k square plus 3k, and then k square minus 9k minus 36. Now I'm going to use a calculator to do it faster. 1 minus 9 minus 36, so it's 12. The value of k is 12 and minus 3. But since it says that it must be a positive, given that all the terms of the geometric progression are positive, so we're going to take this one instead of this. This is the answer. Okay, the sum to infinity of the progression. Okay, now we need to find the sum to infinity. Now to find that, we all know what is the formula. It is a upon 1 minus r. So what is the value of a? Okay, we're going to put, where is it? Okay, since the value of k is 12, I'm going to put it in here. So 12 multiplied by 2 is 24, 25, 26, 27. This is 27, and this is going to be 18, and this is going to be 12. Okay, and the common ratio is, I'm going to use a calculator. 12 upon 18, so it's 2 upon 3. The common ratio is 2 upon 3. So now let's use this. The first term is 27 and 1 minus 2 upon 3. 27, 1 minus 2 upon 3, so it is 81. This is the answer. Question 6. A profit has been made of $250,000 in the year 2000. The annual profit would increase each year by 5% of its value in the preceding year. What will be the profit for the year 2008? Okay, so the first term is 25,000, and then since now we know that the common ratio is 1.05, and so it's going to increase by 1.05. I'm going to use a calculator. 25,000 multiplied by 1.05, so it's going to be 262500. Okay, what will be the profit for the year 2008? So 2000 to 2008, so 9, total number of 9. What will be the profit for the year? Okay, so we need to find a, r, and minus 1. We need to find the position. The 2500 multiply by 1.05 and 8, oh sorry, 9, it must be 9. 9 minus 1, 369364 is the answer. Okay, but we can write it in this way as well, 369000 answer. Okay, so this is the end of topic 2, arithmetic progression and geometric progression. So now we're going to move to the next one. Okay, good. Hello and welcome back. This is A-Level Math P1, and in this video we are going to learn what is topic 3, quadratics. We are going to understand quadratics. Okay, we're going to start with quadratics. So let's begin. Okay, topic 3. We are going to start topic 3, quadratics. Okay, so what is quadratics? Quadratics is, quadratic equation. It is a polynomial equation of the second degree of power x. The general form is ax square plus bx plus c is equals to 0. So in a graph it would look like this. Let me just draw the graph. It would look like this. Okay, and the graph of a quadratic function is a parabola whose axis of symmetry is parallel to the y-axis. Okay, right now you can see this. These are called the roots. And this point is called the vertex. And the vertex of a parabola is the point where the parabola crosses its axis of symmetry. I'm going to tell you 3 ways to solve the quadratic equation. The first one is completing the square. The second one is factorization. And the third one is quadratic formula. Okay, and in any of these 3 methods, the completing the square is the most important one, and quadratic formula is the most important. But these 2 methods have different reason why we use them. So I'm going to define each one of them. Let's say that we have this equation, and now we need to solve it. Okay, try to break the middle term into 2 numbers, and then we take a common. So how to break the 2 numbers? First of all, I'm going to show you guys a most easy way and the most fastest way to break the middle term. Okay, in order to break it, we're going to make a square. Okay, so x is x square. Okay, and the last number will come in here, minus 30. Okay. In these 2 boxes, we need to put the numbers which are the multiples of minus 30. Also, these 2 numbers must be an addition or by subtraction of the middle number, which is minus 7. We're going to write here minus 30. It comes in here, the last number, and then we're going to write in here xs. So x multiplied by x is x square. Okay, now we need to think that what are the factor of minus 30. What are the factors of minus 30? Let's say 3 multiplied by 10 is equals to 30. Sounds good? These 2 numbers are the multiples of 30, and you can just put minus 3 or you can just put minus 10, any minus sign of the 2 numbers. Okay, but we need to you need to understand that these 2 numbers are the multiple of 30. Okay, we get it. But now we need to know whether if we do the if we do the addition or subtraction in order to get minus 7. So after thinking about it, and after seeing these 2 numbers, I can say that minus 10 plus 3 is equals to minus 7. Okay, and 3 multiplied by minus 10 is equals to minus 30. So there you go. We have divided the middle term into 2 numbers. So minus 10 and 3, or you could just write in here 3 or minus 10. It doesn't matter. Okay, so minus 10 and 3. If you make an addition, minus 10 plus 3 is equals to minus 7, and minus 10 multiply by 3 is minus 30. Okay, so just let me just write it down in here. Okay, so this is minus 10x and 3x, and this writing is going to be 3. So now I've I have broken down into 2 numbers, the middle term. Square minus 10x plus 3x minus 30, and now I'm going to take a common. So x is x minus 10 and 3 is x minus 10. Okay, and now since we know that these 2 we can take a common, so we're going to write in here minus 10 and then write in here x plus 3 is equal to 0. Now we can see that these are factors. Okay, and now we can make it equal to 0, each number. So x plus, okay, so x minus 10 is equals to 0, so it's going to be 10, and x plus 3 is equals to 0, so it's going to be minus 3. Okay, so these are the 2 numbers. These are the answers. This is the answer. This is how you solve it by factorization, by using a square graph and then putting the values, putting the last number, which is minus 30. Okay, we know that this is the middle term. The minus 7x is a middle term. We need to break it down to 2 numbers, and in order to break it, we need to find out the 2 numbers which are the multiples of minus 30. But also at the same time, it must be an addition or subtraction of minus 7x. So this is what we call factorization. And if this is very difficult for you, then there are other methods to solve it as well. This isn't the only method to solve. At some circumstances, this method can be used to solve all quadratic equation but because of the complexity, the other two methods are recommended. The quadratic formula and completing the square are the most recommended method to solve any quadratic equation. Factorization, the method factorization has some limit to solve, so it can only solve certain equations which are not complex. So now let's start with completing the square. Okay, let's say we have this equation x square minus 7x minus 30 is equal to 0. Okay, what I'm going to do, I'm going to start with the middle term. I'm going to divide this number by 2. So it's going to be minus 7 upon 2 square. This is how you write it. Okay, and minus 30. Then I'm going to take this number outside and square it. So I'm going to write it in this way. So it's going to be minus, okay, doesn't matter if it is x plus 7 upon 2 square or x minus 7 upon 2 square. Whenever we try to get this number out of the brackets, it's going to be minus. Okay, so in this way it's going to be x plus 7 upon 2 square minus 7 upon 2 square. Okay, and the same as this one as well, 7 upon 2 square, so minus 7 upon 2 square. Okay, so it's going to be 7 upon 2 square minus 30. Okay, let me just hold it right here. This is what we want. Now I'm going to show you why it is so important. As we all know that this is ax square plus bx plus c, right? So c is the y-intercept. This is the y-intercept, and a determines the thickness of the curve, and also it determines whether it's going to be a happy smile curve, okay, or a sad smile curve. Okay, so now I'm seeing that this is 1 right here. This is actually positive, so which means it's going to be positive. It's going to be a smiling curve, a smiling face. You can see this U curve, it's a smile. Okay, and whenever it's going to be minus a, so it's going to be a sad looking face, it's crying. This is how you need to remember it. So it's going to be a smiling curve. We know that the y-intercept is minus 30, so right here we got minus 30. These two numbers are the coordinates of the vertex. Okay, these are the coordinates of the vertex, which is x and y. Since it is written minus 7 upon 2, I'm going to change the sign. We always have to change the sign for x. So it's going to be 7 upon 2. 7 upon 2, which is the x coordinate of vertex. And minus 169 upon 4, we don't need to change the sign in here. This is how you take the coordinates in the completing the square. Okay, this is the vertex. And now if we try to solve this further, since we have this equation 7 upon 2 minus 169 on 4 is equal to 0. The standard way of looking this is, like this, minus h square plus k is equal to 0. This is the standard way of seeing this. A determines whether it's a happy curve or a sad curve, and h and k are the vertex, are the coordinates of the x and y coordinates of the vertex. So if I want to solve this even further, I will get the roots of the equation. The roots, we call it, are the intercept of the x-axis by the curve. So now let's do that in order to make it more, in order to understand it more beautifully. Okay, now we're going to under root square 169 upon 4. I'm going to use a calculator now. So it's 13 upon 2, which means 13 upon 2 plus and minus, and x minus 7 upon 2. Okay, so we have this 7 upon 2 plus 13 upon 2, or x is equals to 7 upon 2 and minus 13 upon 2. Okay, using a calculator we got this x is equals to 10 and x is equals to minus 3. These are the roots. So in here it's 3, and it's in here actually it's minus 10. So now the graph would look like this. It's going to look like this. Okay, yeah, it would look like this. Okay, moving on. This is what we call completing the square. So completing the square is the most effective method. It helps us to make a graph of the curve and then how it looks like, and also it helps us to find the roots. Let me just solve another question of the completing the square, but this time it's going to be a little tricky. 3x square plus 14x minus 5 is equals to 0. So right now I need to make a common. So it's going to be brackets. It's going to be in bracket form. So x square plus 14 upon 3 and minus 5. Okay. Now we are going to do the completing the square. We're going to divide 14 upon 3 by 2. So x plus 14 upon 3. 3 to the 6. So it's going to be 6. And it's going to be square. And then we're going to take this number outside of the bracket. So in square form. So it's going to be minus 14 upon 6 square minus 5 is equals to 0. And this thing is in bracket. Okay, it's in bracket. X plus 7 upon 2, so it's going to be x plus 7 upon 2 square, x plus 7 upon 2 square minus 49 upon 9. Okay, and now we're going to multiply 3 by these two brackets. So 3x plus 7 upon 2 square minus 349 upon 9. Then minus 5 is equals to 0. Okay, my mistake. This is actually 3. 3 and 3. And now we're going to find out the roots. So this is completing the square. We know if I wanted to, I can just draw the graph, So you know what? Let me just draw the graph then. So minus 5 is the y-intercept. So 1, 2, 3, 4, 5, minus 5. These two are the coordinates of the vertex. So minus 7 upon 3. I mean, it's going to be right here. The vertex, minus 7 upon 3 and minus 64 upon 3. Okay. And since we know what are the roots, so 1 upon 3 and minus 5. So here it's 1 upon 3 and here is minus 5. So it's going to be a look like this. This is a curve for the equation. And since we know that that this is plus 3, a is positive, so it's going to be happy face. I mean this one. For positive a, and for negative a, it's going to be sad face. Alright, this is completing the square. And now let's understand what is the quadratic formula. Okay, we have understand completing the square. It's very important. You need to understand it. Now we are going to start with quadratic formula. Okay, so let's start with the last method, quadratic formula. So what is the quadratic formula? Okay, first of all, the standard version of the quadratic equation is ax square plus bx plus c. C is the y-intercept. A tells you what is whether it is a smiling curve or a sad curve, and b tells you how much wider is the curve. But you will understand it in the function topic. Okay, for now I'm going to focus in here that what is the quadratic formula. This is the quadratic formula as I am writing right now. This is a quadratic formula. And the most special thing about this method, this formula, is whether it can solve any kind of quadratic equation. All right. Okay. And the next thing I want you guys to know is about imaginary roots. This is the reason. This is the reason why we couldn't use factorization, because it doesn't help us to find the imaginary roots easily. So imaginary roots can be easily find it out in completing the square, using completing the square, or this formula, quadratic formula. Let's say just that I just have this equation, x square minus 7x minus 30 is equals to 0, and now I'm going to put the formula, put the values in the formula. Okay, minus, okay, the value of b is minus 7, so minus 7, okay, plus minus the root b, well, the value is minus 7 square minus 4. Okay, the value of a is 1, so 1 multiply by, and the value of c is minus 30 upon 2 multiply by a, 2 multiply by 1. Okay, now let me just simplify it. Okay, so minus minus is 7 plus minus under root, and after simplification it is 7 7 49 plus 4 30 is 120. Okay, minus minus plus, so plus 120 and upon 2. Okay, and x is equals to 7 plus minus 49 plus 120 is 169. Okay, and it's going to be 13. So now it's going to be broken down into positive and negative. Okay, so x is equals to 10, x is equals to minus 3. These are the roots. Okay, and this is the quadratic formula, but I'm missing something, and that is discriminant. And discriminant is a very special formula that you could only find in quadratic formula. And this is the discriminant. This one, b square minus 4ac, is the discriminant. And what's so special about this? It tells you that whether the curve has intersect 2 times, so it's going to be greater than 0, or whether the curve has intersect 1 time, so it's going to be is equal to 0, 1 time, just one touch, tangent to the curve, and whether the curve haven't intersected, so it's going to look like this, it's out. And these type of curve, whenever we have these type of curve, you just understand that you will have imaginary roots, because it is imaginary, it doesn't exist in the real world. You will have imaginary roots. In here you will get one root which is real, one real root, and you will get in here 2 real roots. This is what we call discriminant. Okay, so let's say that we have this equation x square minus 7x minus 30 is equal to 0, and just and for example someone asks, for example, I want to know that whether this curve going to intersect 2 times, whether this curve is going to intersect the x-axis 2 times, 1 time, or whether it doesn't intersect the x-axis. So I'm going to use discriminant to find it out. So I can see that let me just use the discriminant, and by using the discriminant, if I put all the values, I will get 13. Wait, I will get 169. And since we know that it is greater than 0, so yes, it got 2 real roots. Okay, it got 2 real roots since it is greater than 0. If it is equal to 0, then it got 1 real roots, and if it is less than 0, then it doesn't intersect the x-axis. The curve doesn't intersect the x-axis, not even 1 time, and you will only get imaginary numbers. Imaginary numbers, with I, 3 plus 2i, etc, etc. You got the I, which means it is imaginary numbers. Okay, this is the special thing about discriminant. Okay, another thing I want you guys to tell you that, let's say okay, the 2 things I need to tell you that about discriminant is that first it's going to tell you that whether the curve have intersect the x-axis or not, okay, or how many times, or maybe it doesn't intersect the curve at all. So discriminant will do the job for you. And the second thing is, let's say that I have a line. The second thing is for example, I have an equation of a line A of whatever is equal to x plus 2, meaning y is equal to x plus 2, and then I've been given a curve as well. The equation of the curve is y is equal to x square plus 2x minus 3, etc. So I have been given these 2 equations, and then the question say, okay, it intersect the curve 2 times, or it intersect the curve, or the line is a tangent to the curve. Okay, so which means it get only 1 real root, or the line and the curve doesn't intersect at all. Okay, but let's say that the line and the curve has intersect at 2 times. So I'm going to prove it that it is the case. So I'm going to use discriminant to find out x plus 2, the line of the equation, and the line of the curve, and the equation of the curve is y is equal to x plus 2 is the equation of a line, and for the equation of the curve is x square plus 2x minus 3. Okay, so x plus 2 is equals to x plus 2x minus 3, and x square plus 1x minus 5. Okay, and now I'm going to use a discriminant. So 1 square minus 4, 1 minus 5. Now I'm going to use a calculator. And it's 21, which means it is intersecting points. It got 2 real roots. This is how you use discriminant. And now we're going to do the exam questions. Exam question 1, solve the inequality 2x square plus 8x minus 10 greater than 14 and find the set of values of x. You can use a calculator to solve this quadratic equation, and it's a great shortcut, you can use a Casio calculator to solve any quadratic equation. Okay, now let's begin. Okay, so we have this equation 2x square plus 8x minus 10 greater than 14. Okay, I'm first thing to there's something to tell you about. Okay, so minus 10 is a y-intercept, 2x square. Okay, a is positive, which means it's going to be a smiling curve. We have this graph. Okay, it's going to be a smiling curve. There is minus 10 intersection. Okay, and let me just let me do the completing the square now to make it understand for you guys what is happening. Okay, so 2x square plus 4 minus 10, then 2x plus 2 square minus 2 square minus, okay, this is going to be in the brackets, minus 10, and now it's going to be like this, square. Okay, so it's actually 2 to the 4 to the 8 minus 18 greater than 40. Okay, let me just use a calculator for directly 2x. Okay, by using a calculator I just found out the roots. The factor is x minus 1 and x plus 5. Okay, greater than 14. So the roots are 1 and minus 5. Okay, this is the y-intercept, and the vertex, the coordinates of the vertex are minus 2 and plus. Okay, it is minus 2, as we just found out, minus 2 and minus 18. So it's in here, minus 2 and minus 18. So it's going to be around here. It's going to be around here. Okay, minus 2 and minus 2 and minus 18. Okay, and so we have this graph. Right, it's going to be like this. Okay, it's going to go up and go up. Okay, so this is the graph for 2x square plus 8x minus 10, and it must be greater than 14. So 14. Okay, there are two things. Okay, the first equation is y is equals to 2x square plus 8x minus 10, and the second equation is, let's say, it's 14. So right here, let's say it's going to be this is 14. Okay, y is equals to 14, and this is the line. So there's an intersection. Okay, for 8x minus 10, 14, then 2x square 8x minus 24 greater than 0. And I'm just going to use a calculator. Minus 2 and x is plus 6 greater than 0. Okay, solve the inequality 2x square plus 8x minus 10 greater than 14 and find the set of values of x. The one thing I want you guys to understand that there are two equations, and these two equations are intersecting. Okay, so the first equation is 2x square plus 8x minus 10, and the second equation is y greater than 14. Y greater than 14, or you can just call it y is equal to 14. So first of all, I just try to solve it for you guys. The first equation, 2x square plus 8x minus 10, and we have the vertex minus 2 minus 18. It is right here. Okay, minus 10 is the y-intercept, and we have the two real roots, minus 5 and 1 in the x-axis. Okay, but since now I need to but right now it says 2x square plus 8x minus 10 greater than 14. It is telling you that y is equals to 14 is intersecting the curve at these 2 points. Okay, and what is the value of these two roots, two real roots, these 2 points? So the value is x is equals to 2 and x is equals to minus 6. So this is x is equals to 2 and this is x is equals to minus 6. These are the points of intersection between these between the curve and the line y is equals to 14. Okay, now it's now there's an inequality. Y is greater than 14. Y is greater than 14, and it's telling you that what happens if the value of y increase. If it's saying that if the value of y increases, y is equals to greater than 14. Okay, if the value of y increases like this, okay, if the value of y is greater than 14, if the value of y increases, if the value of y is greater than 14, then what will be the value of, then what will be the the value of x, x1 and x2. Since the curve is going in this way and the curve is going in this way and the curve is going in this way, all the curve goes in this way. It goes on increasing and increasing, going this side and this side. So we can say that x is greater than 2 and x is less than minus 6 because it's going this way, this side, and it's increasing this side. This is the inequality that I want you guys to tell you about. So this is how we're going to write the inequality. We're going to draw the graph and then we're going to see it. So it's greater than 2 and x is less than minus 6. Okay, question 2. Determine the set of values of the constant k for which the line y is equals to 4x plus k does not intersect the curve y is equals to x square. Like I told you guys, this is how the question is made. Okay, so we got two equations, the line and the curve. Square is equals to 4x plus k, then x square minus 4x minus k is equal to 0. And it's saying that it does not intersect the curve. It's telling you that, and now it's saying that determine the set of values of the constant k. So the main goal here is to find the constant k, and the question is telling us that it does not intersect the curve, which means the discriminant must be less than 0. B square minus 4ac less than 0. Okay, now I'm going to put the values. It's going to be minus 4 square minus 4 1, which is a, the value is 1, and minus k. Okay, for 4 to 16 minus plus, so 4k. So it's going to be 4k and k is less than 4. There you go. This is the answer. Question 2 is done. Just like that. It's very easy. When you guys know the concept, then this A-level math P1 is a joke. It's very easy. Question 3. A line has equation y is equals to kx plus 6 and a curve has equation y is equals to x square plus 3x plus 2k, where k is a constant. Find the two values of k for which the line is a tangent to the curve, which means one real root. It's going to be one real root since it's saying that it is a tangent to the curve, which means it is touching a one point of a curve. So it's going to be one real root. Okay, so discriminant is equal to 0. Let me write it down. Y is equals to kx plus 6 for the line, and for the curve is y is equals to x square plus 3x plus 2k. Okay, find the two values of k. Fine. Kx plus 6 is equals to x square plus 3x plus 2k. Now let's simplify it. X square plus 3x minus kx plus 2k minus 6. Again, x square plus x3 minus k plus 2k minus 6. Okay, here you go. Now we're going to use the discriminant. B square minus 4ac is equals to 0. So 3 minus k square minus 4. The value of a is 1. So 1 and multiply by 2k minus 6 is equal to 0. 3 3 is a 9. 3 to the 6k and k square. 9 minus 6k plus k square minus 8k plus 36. 4 6 4 is 24. 24. Okay. So k square minus k minus 8 and plus 33. Okay, minus 14k plus 33 is equal to 0. And I'm just going to use a calculator directly. I don't want to waste any more time because I know that you all will do it right and perfectly. So 11, the value of k is 11 and value of k is 3. So this is the answer. Two values of k, done. Question 3 is done. Question 4, the equation of a curve is x, y is equal to 12 and the equation of a line L is 2x plus y is equal to k, where k is a constant. In the case where k is equal to 11, find the coordinates of the points of intersection of L and the curve. Find the set of value of k for which L does not intersect the curve. Alright, so let's begin with part 1. In the case where k is equal to 11, find the coordinates of the point of intersection of L and the curve. Okay, so this is the curve. It's actually like this. Okay, for the curve, for the line, y is equals to k minus 2x. And for the case, it's just, in the case, for the case, it's a special condition. Y is equals to 11 minus 2x. Now we're going to solve this. X squared minus 11 plus 12. Okay. Now I'm just using a calculator. We need to solve this using a quadratic. You can use a quadratic formula, complete the square of factorization, but I'm using a calculator. You can always use a calculator if the calculator is allowed. So 4 and 3 upon 2. Okay. of the point of intersection of the line. Okay, so 4 and 3 upon 2 is the answer, but we need to find the value of y as well. So y is equals to, okay, when we put 4 in, let's say 12 upon 4 is 3, so it's 3. And if we put 3 upon 2 in any of the equation, it doesn't matter, it will give you the same answer. And for the as for the x value, x is 3 upon 2, so it's going to put any of the equation, putting in any of the equation, could we get y is equals to 8. This is the answer. Okay, question 4 is, part 1 is done, part 1, only part 1. Now let's move on to part 2. Find the set of values of k for which L does not intersect the curve. Fine. Okay, it does not intersect the curve, which means b square minus 4ac is less than 0. Putting the values. For 2 is 8 and multiply by 12, so it's going to be minus 96. Okay, before moving on, there is something I need to show you guys. Whenever we get these kind of confusions regarding inequalities, we always try our best to draw a graph. Okay, so let's start with a curve. Okay, if I put 0, it will come to infinity. It will come to infinity. Okay, and if I put y is equals to 0, because if x is equals to 12 upon 0, then it's going to be infinity as well. So infinity. Okay, let's say if x is equals to 1, then it's going to be 12. It's going to be 12. If I put x is equals to 2, then it's going to be 6. It's going to be 6, half of the number. If I put 3, then it's going to be 4. So it's going like this. Okay, if I put minus 1, then it's going to be minus. If I put minus 1, then it's going to be minus 12, which means it's like this. This is the graph of the curve. The curve of y is equals to 12 upon x. Okay, now it's saying that okay, let me just, if I make a under root square, what will I get? I will get, okay, so I will get plus under root 96 and minus under root 96. If I try to simplify it, if I try to see, it's actually it's going to be 9.8 positive. Okay, and in here it's going to be minus 9.8. Yep. Okay, now I need to know the inequality. Now let's see the line. Line is y is equals to k minus 2x. Okay, so it is minus 2. The gradient is negative, so which means it's going to be in this side. Okay, but okay, k is equals to 9.8. K is equals to 9.8. Okay, let me just write down the minus 2x plus k. We know that it's going to be the opposite. The equation of a line would be in this way, but we don't know whether it could be anywhere between these two graph of the curve. Okay, the value of k could be positive 9.8. Okay, value of k means c-intercept, so it could be positive 9-intercept. It could be in here. Okay, touching this curve, or okay, this is 9.8. Okay, and this is in this way the line, or it could be in here like this way, and this is minus 9.8. And now since it said in the question that the line and the curve does not intersect at all, which means the value of k could be less than 9.8. Okay, it must be less than 9.8, which means the value of k, the y-intercept, it will go down. Okay, and k must be greater than minus 9.8, and it's going up. So there is no intersection between k less than 9.8 and k greater than minus 9.8. This is the answer. These are the values, these are the inequalities. Part 2 is done. Question 5. The equation of a curve is y is equals to 9 upon 2 minus x. Find the set of values of k for which the line y is equals to x plus k intersect the curve at two distinct points, which means the discriminant must be greater than 0. Okay, so we have the equation of the curve y is equals to 9 upon 2 minus x, and we have the equation of the line y is equals to x plus k. Now let me do the magic. discriminant is greater than 0. That's good. Okay, so we have the quadratic equation. Now we're going to solve it. I'm using a calculator. The one is 4 and the other is -8. Now, okay, we have these values and now we need to define the inequality. So I'm going to draw a graph. Always draw the graph for the inequality whenever we need to understand the inequality. It would be much better for you, much be easier for you than to get confused. Always try to solve these equations, solve these questions through logic, logic. Without concepts, you can't do anything. You can't do anything. You need to do with logic. So y is equals to 9 upon 2 minus x. Okay, what happens if I put 2? If I take the x where x is equals to 2, then it's going to be in infinity. So let's say it's 2, then it's going to be infinity. This is the line. Okay. Good. If I take x is equals to 3, then if I take x is equals to 3, then it's going to be -9. So it's going to be right here. If I take x is equals to 4, then it's going to be 4.5. Okay. If I take x is equals to 1, then it's going to be 9. If I take 0, then it's going to be 4.5. If I take 0, it's going to be 4.5. So it's actually like this. Okay, another thing to understand that if I put 2 minus x is equals to 9 upon y, okay, and 2 minus 9 upon the next, if I put 0, then it's going to be in infinity as well. Okay, it's going to be like this as well. So it's like this here and here. Okay, now we have the value of k is equals to 4 and k is equals to -8, and we also know that the line is y is equals to x plus k. So okay, the gradient is 1 and it is positive, so it could be in this way. Sorry, it could be in this way. Okay, but it must be between these. Oh wait, since it says that it intersects the curve at 2 distinct points, which means it must be intersecting here or it must be intersecting here. Okay, so we have the k is equals to 4, which means k is equals to 4 and it must be like this and it's intersecting. And k is equals to -8, which means k is equals to -8 and it must be intersecting like this. So k must be greater than 4 in order to intersect at 2 distinct points, and k must be greater than 4. Okay, and k must be less than. If it's less than, then it's going to be -9, -10. So this is the answer. Okay, if k is greater than 4, then you can see that this is the graph. Okay, this is the graph, and if the line passes this, then it's going to intersect at 2 real points. Or if this is a graph and if the line passes it, then it's going to be passed at 2 real it will pass at 2 real points. Okay, so this inequality has been proved. This is the answer. And thanks again for watching. This is topic 3, quadratic, and we have completed it. And now the next topic will be functions and then coordinate geometry, but especially function is a little bit much more. There are lots of. Hello and welcome back. This is topic 4, functions, and today in this video we are going to start with functions. So let's start. So we are starting topic 4, functions. A function is a process that changes a set of input number into a set of output number. Literally means that input, whenever we give an input, it comes into a process and then output. So a function is basically a machine, a box, and you're putting a coin inside a box. This is a coin. You're putting inside a machine, and you get a candy or a snack, anything. So input, process, output. This is what we call function. So there are 2 types of functions. One-to-one function, which means one input, one range, and many-to-one function, which means 2 input but the same output. So let's say that we have this equation y is equals to x square plus 2. This here is known as fx, and x means we are putting x means we are putting input, and y is the output. We can also call this x a domain. We call it a domain, and we call y range. For example, this is a domain x, this is a range y. Let's say if we have a domain 0, 1, 2, 1, and if I put 0 and y is equals to x squared plus 2, what will I get? I will get 2. No, I will get, yes, I will get 2. If I put 1, then I will get 3. If I put 2, then I will get 6. And if I put again 1, then I will, if I put minus 1, then again it's going to be 3. Okay, maybe I don't need to write it down. So if I put 0, it will be 2. If I put 1, then it's going to be 3. If I put 2, it's going to be 6. And again, if I put minus 1, then again it's going to be 3. Okay, 1-to-1 function means one input, one output. And many-to-one function means many input but same output. And the association between x and y is called a relationship between x to y. Okay, so again, let's say we have this equation y is equals to x squared plus 2. Is this a function? How on earth am I going to find out that whether it is a function or not? First, by putting a value and knowing whether it's a one-to-one function or many-to-one function. The second thing is to draw a graph. So let me just draw a graph. Okay, x squared plus 2. 2 is the c-intercept, which means y-intercept. 2 is the y-intercept, and x squared, which means it's going to be, okay, 1, 2, so it's going to be right here. This is the graph of y is equals to x squared plus 2. The quickest and most easiest way to find out whether this graph is a function or not is to use a vertical line test. If the line intersect at only one point, if the line intersect not more than one point, then it is a function. So if I try to see, then just using a vertical line test, and yes, it is intersecting at only one point, not more than once. Okay, which means it is a which means that this is a function. This is a function. So vertical line test has been passed. Vertical line test is passed. Okay. Okay, let's have another example. Let's say that y is equals to x minus 3. Okay, this equation was a curve, but now I'm using a different equation. This is the equation of the line. Okay, so again I'm going to draw a graph and I'm going to find out whether it's a function or not. So y is equals to x minus 3. 1, 2, 3. There is 3, and then you put a line through it, and voila, y is equals to x minus 3. Is this line a function or not? We will use a vertical line test. So if I'm going to do this right, then yes, it is a function. Vertical line test passed because it is intersecting only just not more than once, just one time. Okay, let's say let me see another example. Let's say that I have the equation y is equals to under root x. Okay, and if I draw the equation, then it would look something like this. So is this a function or not? Is this a function? Again, I'm going to use the vertical line test. So I'm using a vertical line test, and no, bro, this is not a function. This is not a function. Do you know why? Because it is intersecting 2 times. It's intersecting more than once. So no, this is not a function. One-to-one function is a line. You can call this is a one-to-one function, and this is a many-to-one function. Okay, because one input, one output, one-to-one function, which could come in a line equation. One input, but and many input and one output is the curve. Okay, now I want you guys to understand about what is undefined range. The undefined range. Okay, what is undefined range? The domain of a function y is equals to fx consists of all real numbers x except those for which fx is undefined. And the condition for having an undefined range is number 1, taking a square root of a negative number. The second condition is dividing by 0. Dividing by 0, what does that mean? Which means if we try to divide any number by 0, it will give infinity. That's the problem. That's why it's going to be undefined range. And as for the square root, if you take a square root of any negative number, then again it will give an error. Okay, and let's say that I have this equation under root 4 minus x upon x minus 2, and interesting about this is if you put the value of 2 in here, then it will become 0 and then it will come to infinity. Okay, and in here if you put a value greater than 4, then again it will become a minus number, negative number, negative number, and it will become a math error. So okay, so we have to define the domain range in order to use this function, in order to use this equation. Okay, so I'm going to set up a domain range. So I'm going to say, okay, well, you can use 2, first thing, and the second thing is that x must be less than or greater than 4. This is the domain range, and there's definitely a different domain range for a different function equation. So it will come in, it will be mentioned in the exam question whenever you try to solve it. First see what is the domain range, and then most of the time they try to ask you about to find the range of the function. So using a domain range, you try to put the numbers which is included in the domain range, and then you figure out the output, figure out the range. Okay, inverse function. Okay, I'm going to start with inverse function. Okay, inverse function is nothing but just a mirror, mirror of any equation. And let's say that you have this graph and you have this, let's say y is equals to x, and let's say that you have been given an equation which is like this. This is the line, this is the function. Okay, and then you've been asked what is the inverse function of fx. What is the inverse function of fx? So the inverse function of fx is this one. This is the inverse function. So whenever you guys try to draw the inverse function, first of all, you will always try to draw the straight line y is equals to x, and then because this y is equals to x will become as a mirror. Let's say we all know how the mirror works, right? You put a face in front of a mirror, and the mirror gives a reflection. So fx minus 1 is the reflection of fx. Okay, this is what inverse function is. Okay, let me just let me solve the question. Inverse of 2x plus 3. Okay, so y is equals to 2x plus 3. Okay, what I'm going to do, I'm going to change the position of y and x. So x is going to be in here and y is going to be in here. And now I'm going to make subject y. I'm going to make y as a subject. X minus 3 upon 2 y. So this is the inverse function of, this is the inverse function, the mirror. This is how you find the inverse function. Okay, so let's say that I want to draw this. I'm going to draw it. Okay, so y is equals to 2x plus 3. 3 is 1, 2, 3. This is 3, and so it's going to be like this. So fx is equals to 2x plus 3, and I'm going to draw y is equals to x in order to find the inverse function. Okay, and then I have this equation of the inverse function, x minus 3 upon 2. I can even simplify this, so x upon 2 minus 3 upon 2, and 3 upon 2 is 1.5, so 1 and 1.5, so it's going to be 1.5, and so it's going to be like this. Okay, you know what, yeah, it's going to be just like this. Or maybe I could just show you the animation stuff. See, this is like this. Okay, now moving on. Question 1. So now right in front of you guys, this is the question of inverse function. I'm going to show you guys on how to find the inverse of any equation. Let's say that this is the equation, and in the question 1, it says let's find the inverse of y is equals to x squared plus 2 and prove whether this inverse is a function or not. Okay, number one thing I want you guys to tell you that whenever we have these kind of equation and then we try to draw a graph, so we use the vertical line test. Okay, we use a vertical line test in order to prove whether this equation is a function or not. So let's say it says this is x squared plus 2, right? So I'm going to draw a graph. Okay, 1 2, and there you go. It's a curve actually. Since it's quadratic, so it's definitely going to be a curve. Okay, and now I'm going to use a vertical line test in order to find out whether this is a function or not. So vertical line test, as we all know, straight vertical line passing through it, but only passing through it only one point, not intersecting more than once. So yes, this is a function. Okay, so vertical line test is passed. Now I want to know whether this equation, which now I want to know that after finding the inverse of this equation. So let's say, well, let's find the inverse of this equation. Okay, now we are going to find the inverse of this equation. The inverse, the mirror. Okay, so I'm going to change the position of x and y. So it's going to be like this, and then x minus 2 and under of square y. And there you go. We have found the inverse of this equation. Okay, this is the inverse. And now I want to know whether this inverse is a function or not. Okay, so like I said, we have this equation y is equals to x squared plus 2. We use the vertical line test in order to find out whether this is a function or not, and I've done it, and yes, this is a function since it's passing only one point, not intersecting more than once. Okay, now I just find out the inverse of this equation, and I wanted to know whether this inverse is a function or not. Okay, so so there are two ways to find out whether this inverse is a function or not. Anyway, I'm just going to draw it, how the inverse looks like in a graph. Since I'm going to draw the mirror y is equals to x, and I can see that it would look something. Okay, so the inverse would look something like this. Okay, and now I want to know whether this inverse is a function or not. So there are two ways. One way is to check with the vertical line test to this inverse. So if I try to use a vertical line test, let me use a different color. Let's say orange. Let's say a green vertical line test. So I'm using a vertical line test, and yes, this is not a function, not a function. Okay, this is method 1, and the method 2 is by using a horizontal line test to the original equation. The second method is using the horizontal line test. Line test on this graph of the origin in order to find out whether the inverse of this equation is a function or not. So no, the inverse of this is not a function because it is intersecting more than once. Okay, and I'm just going to show you this animation. Now you can see it, right? This is what I'm talking about. So using a horizontal line test, it directly proves that the inverse of this equation is a function or not. Draw a graph of the inverse and use a vertical line test in order to find out whether this is a function or not. And so there you go. Find the inverse of y is equals to x squared plus 2. We have found it, and prove whether this inverse is a function or not. So yes, this is not a function. We can either use a vertical line test on this one, or we can use a horizontal line test on this one. So in both manner, we can clearly prove that the inverse is not a function of the equation. That's it. Now I need you guys to understand about completing the square, as we have discussed in the topic 3 quadratic. I told you guys that this is very important. This method is really important in order to graph a curve. Okay, so we know the standard way of drawing a graph by knowing the value of plus k. And I told you guys that if it is plus, then it's going to be a happy smile curve, and if it is minus, then it's going to be sad smile curve. And the x and the h and k are the coordinates of the vertex. And I told you guys that the sign of h will change. The sign of h will change. For it is minus, so it's going to be plus. Okay, and this is the coordinate of a vertex. And I told you guys what is a vertex. This is a vertex. This point is a vertex. And I'm starting from the beginning. Ax squared plus bx plus c. So c is the y-intercept. I told you before. A determines whether it's a happy smile or a sad smile curve. And ax plus bx determines something else. If I try to ax plus bx and ax plus b, so changing b moves the axis of symmetry of the graph in the x direction. Okay, by changing b. If a and b have the same sign, whether it is both positive or both negative, the axis of symmetry is to the left of the y-axis. And if a and b have different sign, of symmetry is to the right of the axis of the y-axis. That I have this equation y is equals to x squared minus 3x plus 4. Okay, and I need to draw this graph of this equation. So how about I use completing the square? Let's do that. So x x minus 3 upon 2 square minus 3 upon 2 square plus 4, and x minus 3 upon 2 square. Now I'm using a calculator. 4. Okay, so we have found out what is the coordinates of the vertex. 3 upon 2, which means 1.5 here. Okay, 4 is the y-intercept. So 1, 2, 3, and 4. 4 is the y-intercept. 5, and 3 upon 2 is 1.5. So there you go. We have found the coordinates 3 upon 2 and 7 upon 4. Okay, show you guys something else. X minus 3. Okay, notice that the coefficient that the a and b have a different sign. Axis of symmetry is to the right of the y-axis in 3 points. So 1, 2, 3, 3 points. Okay, this is a curve. 4 is a y-intercept. This is 4. We know the coordinates of the vertex. We put right here, and after finding that the a and b have different sign, so it's going to be to the right. The axis of symmetry will be to the right of the x direction, and it is minus 3. So 1, 2, 3. Forget the sign since it's 3. So 1, 2, 3. This is the curve. Since we have created the graph, right now I'm going to show you guys some animation. Okay, so we have created this graph x square minus 3x plus 4. Let's see the button on how to move it up, down, left, and right. So if fx plus 2, that means we are trying to change the c. We are incrementing y-intercept by 2. Since there's no x, it's just plus 2. So it's going to change the y-intercept by going up by 2. And if it is fx minus 2, then it is decrementing y-intercept by 2. So it's down. What about left and right? If we put x plus 3 in a bracket, then it's going to be 3 to the left of the x-axis. It's going left. Okay, it's going left. For example, fx plus 3. Okay, let's say we have this x square minus 3x plus 4 and 5 x plus 3 is going to be x plus 3 square minus 3 x plus 3 and plus 4. Now after explaining this, then it's going to be a different equation. Okay, and this equation will give this, instead of division, it will go to the left. And the same thing is for right as well. Okay, and that's it. Now the last thing you guys need to understand about what is about the combining function. Okay, so I'm going to show you guys a bit of animation. If x is in the domain of both f and g, then as follows, we have 4 different types of condition. F plus gx is equal to fx plus gx. F minus gx is equal to fx minus gx. F multiplied by gx equals to fx dot gx, and f upon g is fx upon g, and gx cannot be 0. This is a combining function. Okay. And the last thing I want you guys to understand about is what is the composite function. So a more important way to combine two functions is to form their composition, which is like this. The composition of two functions of f and g is f, g, x, which means f, and instead of writing x, it's going to be g and then x. So this is a composite function. Let's say that fx is equals to 3x minus 2 and gx is equals to x squared minus 4. If I want to find the composite function of fgx, so it's going to be like this. So 3, and then I'm going to put in here, so x squared minus 4 and minus 2. So 3x squared, 3 4 the 12, and minus 2. So it's going to be 3x squared minus 14. And if I want to find the composition of g fx, then this is the gx and the fx would come in here. Okay, so 3x minus 2 and minus 4. This is the composition of gfx. 3x minus 6. Gx x squared minus, I forgot to put x squared. So I'm going to open the bracket. I'm going to expand this. It is a 9 square 12x plus 4 minus 4 cancel, and this is the answer. Okay, this is composite function. And now let's do the questions. The composition of f and g can be formed only if some of the numbers in the range of g are in the domain of in the domain of f. Okay, this is really really confusing. But if I'm going to do the question of this, and then it's going to be crystal clear for you guys that how to find the domain of this to that. Because the thing is that if we are taking the composition, so you need to understand that the range of gx is the domain of f. And if you try to take this composition, then the range of fx is the domain of gx. So I'm going to do the questions right now, and then it will be crystal clear for you guys to understand it. So let's do the questions. Part 1, x plus 2x squared plus 8x minus 10 in the form of ax plus b plus c. Okay, it's the same standard form. Right now we are going to do this, you and me together. Part 1. So the equation is 2x squared plus 8x minus 10. Take a common, 2 first of all in order to make it simplified, and then start the fun. X plus 4 upon 2 square minus 4 upon 2 square. Okay, I don't need to write down that. Okay, it's done. To the 4, to the 4, okay, 2 power 2 is 4, 4 to the 8. And there you go, my friends. This is the standard form. This is the standard form. Part 1 is done. Part 2, for the curve y equal to x square plus 8x minus 10, state the least value of y and the corresponding value of x. Least value of y is, obviously you guys know, I've just taught you guys that. Let me draw the graph. A is positive, so it's going to be a happy smile curve, and minus 18, so minus 18 and minus 2. It's going to be minus 2 and minus 18. So let's say right here. And minus 10 is the y-intercept. Okay? So this is the least value of y actually. This is the least value of y. So part 2 answer is, and the corresponding value of y. This is the answer of part 2. Because this is the least value of y and the corresponding value of x. The coordinates of the vertex. Okay, part 2 is done. Part 3, find the set of values of x for which y is greater than 14. So it's saying that y is greater than 14, meaning this is a line, it is intersecting at 2 points. And what happens, what is an inequality if the line is greater than 14? Okay. Okay. So let me just write it down. 2x square plus 8x minus 10 greater than 14. So 2x plus 8x minus 24 greater than 14, and I'm using a calculator just in case. I be 2 and minus 6. So x is equals to 2, x is equals to minus 6. So here you go, there is 2 and there is minus 6. Now I need to find the inequality. Okay, if y is greater than 14, then obviously it's going to go there, it's going to go there. So meaning x must be greater than 2 and x must be less than minus 6. So x greater than 2 and x less than minus 6. Okay, part 3 is done. Part 4, given that fx is equal to x square plus 8x minus 10 for the domain x greater than k. Okay, find the least, given that fx is equal to x square plus 8x minus 10 for the domain x greater than k. Find the least value of k for which f is a 1, 1. Okay. X greater than k. So let's suppose if I want to erase this whole part. Okay. Now you can see here, this represent 1, 1 function instead of many to 1 function. 1, 1 function. It's become a linear. And x greater than k means minus 2. Okay, x must be greater than minus 2. Because in here it is minus 2. The coordinates of the vertex. Okay. So find the least value of k for which f is a 1, 1. Sir, I just found the value of k. Okay, part 5. Express f minus 1 x in terms of x in this case. Okay, now I need to find the inverse of this 1, 1 function, of this 1, 1. I need to express this in this case. So, okay. Express in, to find the inverse, we're going to use this one. Okay, change the position. Okay, you can just call this y. Okay, this is y. Change the position, so 2y plus 2 square minus 18 is equals to x. And then you will get this. And there you go. And the domain will become a range, you know. Since the domain of the function is this, so the range will be, it will become a range. Okay, I just forgot to tell you guys that the domain of this function, the inverse, the domain of this function is x greater than minus 2. So it's going to be, okay, this is the domain of fx. Okay. So after taking the inverse, it's going to convert to range of fx. Okay. I forgot to tell you guys that the domain of fx and the range of fx will be converted to range of inverse. and the range of fx will be converted to domain of inverse. So whenever we try to find the inverse of any function, that particular function's domain and range will be converted to range and domain of the inverse. Okay, so the domain of fx will be converted to range of fx whenever we try to find the inverse when finding the inverse. Okay, and the range of fx will be converted to domain of f minus whenever we try to finding the inverse function. Okay, so it's going to be on a graph. It's going to be like this. It's going to be like this, and the range will be, greater than -2. Okay, so the range will be greater than -2, which means this is -2. Okay, so it's going to go like that. All of them is done. Okay, I didn't actually the best way to draw a graph, whenever you try to always remember that whenever you try to draw a graph, let's say that, of the inverse function. So we actually, first of all, number one thing, draw the fx. Okay, then number two, draw y is equals to x, which is a mirror. And then number three, draw the approximate graph. Okay, you don't need to make a complete clear, a complete authentic graph of the inverse function. The examiner will not ask you that. They will just simply want to see whether you have the concept of whenever there is a mirror, y is equals to x, and then I just show you guys this is we erase the half of the part of the curve, and we this is converted to one-to-one function. Okay, this is converted to one-to-one function, and we have the domain which is greater than x greater than -2. Okay, and so according to this line, if I just try to see that this is the mirror, and so it's going to intersect in here. So it's going to intersect in here, and then here. The domain will become a range of inverse -2. Okay, so you just need to see the mirror of y is equals to x, and then you just need to cross this point, obviously. There. So this is the fx, this is the mirror, and this is fx minus 1, inverse, the inverse of function. There you go. Okay, question 2 is done. Question 3, the function x squared minus 6x is defined for the domain x greater than 3. Express x squared minus 6x in the form x minus p squared minus q, where p and q are constant. Okay, and then find expansion for this and state the domain of this. Okay, doing part 1. Express this to this, it's easy peasy. Using the completing the square, 6 upon 2 square, 6 upon 2, and then bracket, 0, then 3, 3 and 9. There you go. Okay, so value of p is 3 and the value of q is 9. Alright, for h minus 1 and state the domain of h minus 1. Okay, I also need to see that the domain x greater than 3. Okay, let me just draw the graph. Okay, it's going to intersect at 0 and 3, 1, 2, 3, and minus 9. Minus 9. So there you go. It's going to go like this. Okay. This is 3 and minus 9. And it's saying that x is greater than 3, which means this one will be erased. Since the domain is x greater than 3. The domain is x greater than 3. So this is one-to-one function. Okay. And now I need to find the inverse. So I'm going to change this to inverse. So part 2, we are going to do part 2. Okay, change the position. Y is in here and x is in here, and make y the subject. And then put the square root, and then put 3, and there you go. Y is the inverse of the equation. This is the inverse. This is the equation of the inverse. And if I try to find the graph of the inverse, first of all I'm going to draw the mirror. Y is equals to x, and I'm going to make it increasing and increasing and increasing. It's going to go just like that, and then I'm going to see. So, but for the function, it's going to be x. Oh, okay, it's going to be y greater than 3 range for fx minus 1. All right. So 1, 2, 3. There you go. So this is 3. This is 3. Then I'm going to go like this. There you go. This is the inverse. See the domain of the function is, y is greater than minus 9. the range of the function is wise of the function. But for the inverse, it will become a domain x greater than minus 9. So in here it's going to be minus 9 as the domain, and in here it's going to be 3 as a range. Yes, it's going to be 3, y greater than 3. Okay, so there you go, minus 9 and 3, domain of fx inverse 1. Question 4, and I'm warning you guys, this is the question of composition function, and it's very important and it's very tricky. Question 4. The function f is defined by fx is equal to 3x plus 1 for x less than a, where a is a constant. The function g is defined by gx is equal to minus 1 minus x squared and x less than minus 1. Find the largest value of a for which the composite function gf can be formed. We need to look at the domains, my friend, ladies and gentlemen. We need to look at the domains. This is the domain for fx. And this is the domain for gx, and we want to make the composition function of gfx. Okay, since we know that the domain, look it in here, this is the domain, and whenever we put the domain, and then it will come out, it will give the range. Okay, then the range of fx is the domain of gfx, is the domain of gx. This is the domain, we put the domain in here, we find the range, and the range of fx will become the domain of gx. Okay, so now I need to find this value a. So what I'm going to do, I'm going to put a in the function fx, and I'm going to find the range. Okay, so fa is equals to 3a plus 1. Okay, so this is the range of fx, and now I'm going to put this in the domain of gx. Okay, and look closely. The domain of gx must be less than minus 1, and we need to find the largest value of a for which the gfx can be formed. Okay, but it needs to be connected to this. The domain of fx must be connected to the domain of gx. First of all, what we're going to do, we're going to put the domain of put the domain in the fx, and then find the range, and then the range will become the domain of gx, which means it's going to get equal to this. Okay, so 3a plus 1 is equals to minus 1. The domain of the range of gx will become the domain of the domain of fx will become the domain of gx, and in order to become the domain of gx, it must less than or equal to minus 1. So I'm going to make it equal to minus 1 in order to find the value of a. Okay, so it's going to be a is equals to minus 2 upon 3. So this is the largest value. So this is the largest value for which gfx could be formed, you can say it. Okay, so this is part 1. Okay, part 2. For the case where a is equals to minus 1, solve the equation fgx plus 14. Okay, solve the equation fgx. It's not gfx, but now it's fgx. So f and then gx. Okay, the range of gx will become the domain of fx. So it's this time in part 2, it's reverse. So 3 minus 1 minus x squared plus 1. So it's going to be minus 3 and minus 3x squared plus 1. And it's going to be minus 3x squared plus, minus 2. It's going to be minus 2. Okay, it's going to be minus 2. And now it's saying that fgx plus 14 is equal to 0, and we need to solve this. So minus 3x minus 2 plus 14. And so it's going to be plus 12. Now we need to solve this. So 3x squared minus 12 and x squared minus 4. Since we take a common, 3 1 the 3, 3 4 the 12, and 4 will be right here, and then x is equals to 2 and x is equals to minus 2. Now we need to see that which of these answers is correct, either x is equals to 2 or either x is equals to minus 2. So in order to find it out, we know what is the domain of fx. The domain of fx is minus x less than minus 1. Okay, so x must be less than and equal to minus 1. So minus 2 minus 3. So right now we can see that this is less than minus 1. So this is the right answer, and 2 is out of the question. 2 is not included in the domain. Okay, so this is the answer. Values of x which satisfy the inequality gfx less than minus 50. Okay, yeah, that's a challenge. Part 3. Now it's saying the gfx. Okay, instead of gx, it's gfx. So gx was minus 1 minus x squared, next greater than minus 1, and fx was 3x plus 1 and x less than minus 1. Both of them have the same domain. Okay, now gfx. Gfx is equals to minus 1 minus, minus 3x plus 1 square. Minus 1 minus 3 is a 9x squared. 3 2 is a 6x plus 1. Then minus 1 minus nx squared minus 6x minus 1. And then minus 9x squared minus 6x minus 2. Okay, and it must be less than minus 50. Fine, less than minus 6 minus 50. Okay, So nx square minus 6x. Okay, so it's going to be 48. And let me just change the sign as well. Plus 6x minus 48 greater than 0. Let me take 3 as a common. 3, 6 and 9, 2 to the 6, and 3 1 the 3, 3 5 the 5, 3 5 the 3 6 18. Okay, greater than 0. So the first one is 2, and the second one is minus 2.67. Okay, but I need to find the set of find the set of values. I need to prove the inequality. Okay, in order to find the inequality, we're going to draw the graph. Okay, since this is minus, it's going to be a sad face. Okay, it's going to be a sad face. So minus 2 is the intersection. There you go, minus 2. And since it's going to be like this, you know, it's going to be a sad face anyway. So it's going to be like this, and y is equals to less than minus 50. So let's say there's a line which is y is equals to 50, and if y is equals to less than minus 50, so y is less than minus 50. Since it is less than minus 50, so it's going to go down. Okay, which means this is the line y is equals to minus 50, and if we have this inequality y is equals to less than minus 50, then the line will go down, and as the line go down, then you know it's going to intersect from here and from here. So x is less than minus 2.67, and x is greater than 2. X is greater than 2. So we have the inequality. Okay, so we have this, and now we are going to see that which one of them is right. We need to see the domain of gx. And now we can see that there's x less than minus 2.67, so it's going to be minus 3, minus 4. This one is right. This one is wrong. It's not coming in the domain. Okay, since we know that it's less than minus 1. So this is the answer. This is it, guys. We have done the work, the whole work. And I hope you guys have understood what has happened here. And you can ask me in the comment section and ask me anything, any problems regarding this topic. Thank you so much. Hello and welcome back. And in this video, we are going to start in this video, we are going to start with transformation of function. Okay, so this is a bonus. Actually, there's been an update in the syllabus in A-level maths. So transformation of function is a new one. It's a bonus of, you know, it's an addition in 2021 syllabus. Okay, so let's begin. So there are 8 types of things. There are 8 types of transformation: up, going up, down, going down, left, going left, right, going right. Okay, reflection in the x-axis and y-axis. Reflection on the x-axis and y-axis. Reflection on the y-axis. Okay. Then stretch or shrink. Vertical stretch or shrink on the x-axis, or you can just say stretch or shrink on the x-axis and stretch or shrink on the y-axis. So it's going to be vertical whenever we try to shrink or stretch the curve, whenever we try to stretch or shrink the curve on the x-axis. So it's going to be on vertical side. Stretch or shrink, or you can call it compression instead of using. So it's the same thing, compression or shrink. It's the same meaning. Shrink on the x-axis. Okay. And horizontal, and whenever we try to stretch or shrink on the y-axis, so it's going to be in horizontal way. So horizontal stretch or shrink, or you can call it compression, on the y-axis. So these are 8 ways of transforming a function, transforming a curve, or any diagram. Okay, so let's begin. Okay, I'm going to use some a bit of animation as well. So as for whenever we try to, you know, change the whenever we try to move the function or curve or any graph going up, then the way, in order to, you know, change in order to move the graph upward or downward, we will try to change the y-intercept. Okay, so let's say that we have the equation. Example is x square plus 2x. Okay, and you can see the graph in front of you. Well, let me just draw it myself as well. Okay, so the graph would look like something like this, and it's going to cross with a y. Okay, like this. Okay, you notice that this is the y-intercept. Okay, so whenever we try to, you know, moving upward or downward, we will try to change the y-intercept. Okay, so it's fx plus k. Plus k means any number. K is a constant actually. So plus 1 or plus 2. So it's going to go up by changing the y-intercept. Okay, and for down, fx minus k. So it's going to go down. Changing, or we only changing the y-intercept. Okay. As for going left,
it's going to be fx plus k. Okay, which means if anything is add up, if it is fx plus k, then it will go left side left k times. Let's say it is fx plus 2, so it's going to move 2 times. 2, it's going to move at 2, 1, 2, so it's going to be like this. Okay, and you can see the animations as well. As for going right, it's going to be fx minus k, so it's going to go right k times. Okay, as for the reflection on the x-axis, it's going to be, okay, reflection on the x-axis, you can see this a, as I've told you before, that if it is plus a, then if it is plus a, then it's going to be a smiling curve, and if it is minus a, then it's going to be a sad curve, so by doing the reflection on the x-axis, we will try to use this way. Okay, so in this way, it's going it will change the sign of a, it will become minus a, and then it will look something like this, reflection on the x-axis, which means on x-axis will act as a mirror, and as for reflection on the y-axis, acting as a mirror, we will use this. Okay, so whenever so reflection on the x-axis, we will use a minus sign will be outside, and reflection on the y-axis, the minus sign will be on the inside. Okay, vertical stretch and shrink on the x-axis. Okay, this one is a little bit tricky, so I want you guys to understand. Okay, because these two are quite in opposite, they're opposite condition. These two are quite the opposite. Okay, so starting from vertical stretch or shrink on the x-axis, let's say that, okay, I'm also showing you the animation as well. Let's say that we have this. Okay, and we have this equation, x square plus 4x square plus x minus 3, and it will going like this. Okay, stretch, which means it will stretch out, going this way. Shrink, which means it is going this way. Shrink, it is shrinking. Compression. Okay, so vertical stretch or shrink on the x-axis, which means it's going to, okay, so this is y-axis, vertical stretch or shrink on the y-axis, so this is y-axis, and as for the x-axis, okay, so it's a curve is like this. As for the x-axis, if it is stretching, then it will go, if it is stretching, that will go here, and here it will stretch this way, and if it is shrinking, then it will go in this way. Whenever we try to stretch, it will stretch away from the x-axis, and whenever we try to shrink, it will shrink toward the x-axis. Okay, and the condition for stretch or shrink is, if k is greater than 1, then it will shrink. Sorry, if k is greater than 1, then it will stretch, and if k is less than 1 and greater than 0, then it will shrink. Okay, and then it will shrink. Okay, and we can do the stretch or shrink on the y-axis through multiplying the k constant by y. Okay, that's how it is, multiplying the y coordinates in order to make a stretch or shrink. Okay, and okay, horizontal stretch or shrink on the y-axis, so this is the horizontal. Okay, so it will go horizontal. On on the x-axis, it will go vertical stretch or shrink. On the y-axis, it will go horizontal stretch or shrink. Whenever it will stretch away from the y-axis, and whenever it will shrink toward the y-axis. Okay, and the condition is quite the opposite as for the x-axis. On the y-axis, the k must be greater than 1 in order to shrink. Okay, and as for the stretch, it must be greater than 0 and less than 1 in order to stretch. And by dividing x coordinate by k, we can accomplish this stretch shrink on the y-axis. Okay, so this is the y-axis, this is the x-axis, and there you go. This is the transformation of functions. So I hope that you guys have understood about what I'm doing here, and I've also tried my best to show you guys these animation stuff. So this is the end of chapter 4 functions. The end of chapter 4 functions. Okay, and now we are going to chapter 5, which is coordinate geometry. Okay, goodbye and welcome back. This is topic 5, coordinate geometry, and in this video we are going to learn about the equation of a line. We're going to understand about the distance formula. We're going to understand about what is the midpoint and how to find the midpoint using a formula. We're going to understand about what is the gradient and how it affects the steepness of the line. And then parallel lines. Parallel lines are those lines which have the same gradient but different y-intercept. And then perpendicular line. Perpendicular line means 90 degree intersecting to the other line. And then simultaneous solves. We use simultaneous solve to find the whenever any two lines intersect, whether it's perpendicular or not. And then we need to find what is the coordinates of the intersection. Then we use the simultaneous solves. And then we have angle between line and the x-axis. And then we will understand lastly what is the equation of a circle. Okay, so let's begin. Okay, so let's say that we have 2 points A and point B. Okay, and so point A will be right here and point B will be right here, and it says that we have to make a line through these points, so we will try our best to make a straight line. Okay, so this is a straight line. Okay, and we all know that this line and we all know that in order to make this line, that y is directly proportional to x, and after removing the proportionality sign, it will become mx. Okay, m is a constant gradient, it's the gradient, and mx plus c, since it is intersecting the y-axis, so c is the y-intercept, it is the y-intercept. Okay, and m is the gradient. All right, so what we have, so we need to find the gradient of this line, so we're going to make a triangle, and y2 minus y1, x2 minus x1. Okay, so this is the formula of the gradient, y2 minus y1 upon x2 minus x1. So it's going to be, okay, so the value of y2 is 8 minus y1 is okay, value of y2 is 8 and value of y1 is 2. 8 minus 2 upon value of x2 is 8 and value of x1 is 2. So 8 minus 2, so it's going to be, I'm using a calculator, so it's going to be 1, which means that we have a gradient which is equal to 1. Okay, so we have found the gradient. All right, and now let's say that we want to find the y-intercept. So y is equals to 1x plus c, and now I want to find the y-intercept, which is c. So I'm going to choose any two. I'm going to choose any one of the 2 points. So we have 2 points. So choosing any two. Let's say I'm choosing any one. So let's say I'm choosing this one. Okay, and then I'm going to put down the values. So 2 is equals to 1 multiplied by 2 plus c, and then it's going to be 2 minus 2 is equals to c is equals to 0. So c is equals to 0. Either you can use it, you can find the value of c by calculation, or you can just see it on the graph that it is indeed intersecting at 0. The y-intercept, it is intersecting the y-intercept at 0. Okay, so the whole equation will become simple as this, and so this is the equation of the line. Okay, yep, just like I told you guys, this is the equation of a line. Y is directly proportional to x, and then y is equal to mx plus c. M is the constant and c is the y-intercept. M is the gradient of the line, c is the y-intercept. All right, and now let's find the gradient. Just like I told you before, we're going to make a triangle. Y2 minus y1 upon x2 minus x1 is equals to 1. And so y is equal to 1x plus c, and as we can see on the graph, you can either do it by calculation or see it on the graph. Right now we are seeing on the graph and it's intersecting at 0. So there you go, y is equals to x. Okay. Right now it's saying that what is the length of the line AB. So this is A and this is B, and we need to find the length of line AB. So we will use a Pythagoras theorem. Okay, so according to the Pythagoras theorem, this is H, this is P, and this is B. Okay, so P square is equals to B, so this is H, this is P, this is B. So H square is equals to P square plus B square. Okay, so H is what we really need to find. It is a distance. Okay, so H square is equal to, instead of writing P, we can write it like this: y2 minus y1 square plus, and instead of writing B, we can write it like this: x2 minus x1 and square. Okay, and after that we're going to do under square root y2 minus y1 square plus x2 minus x1 square. Okay, so this is the formula for finding any distance, finding the length of any 2 points. Okay, so we need to find the length of the line AB. So this is line AB, and I'm going to put down the points, and I'm going to find the distance. Okay, so right now the distance of P 8 minus 6. So 8 minus 2 is 6 square plus, and x2 minus x1 is 8 minus 2 again, so it's also 6. Okay, and now I'm going to use a calculator. Okay, so it's 72, and then doing more simplification. So this is the answer. This is the distance. This is the distance of the line AB. This is the distance. Okay, good. So just like I told you guys, in order to find the length, you will use the Pythagoras theorem. So this is the Pythagoras theorem. This is how it is: y square y2 minus y1 s2 minus s1 square it. You got this, and there you go. This is the length of the line AB. Okay, so right now we need to find the midpoint of the line AB. All right. So we need to find the midpoint of the line AB. So midpoint, which means this is A, this is point A, this is point B, and now we need to find the midpoint M. So in order to find the midpoint, first of all, let me write it down: x1, y1, x2, x2, y2. Okay, so the formula from finding the midpoint is midpoint of x is x1 plus x2 upon 2, and finding the midpoint of y is y1 plus y2 upon 2. Okay, so x1 is 2 and x2 is 8. Okay, y1 is 2, and y2 is 8. Okay, now I'm using a calculator. So it's going to be 5, which means the coordinates of m is 5, 5. So this is 5, 5. There you go. So this is how it is. 5, 5 is the coordinates of m. All right. Okay, right now what you guys seeing is the parallel line. So this is the parallel line. So this is the parallel line. Okay, it's going parallel to the to this line. It's parallel, and so it will have the same gradient. The only difference is the y-intercept. So it's intersecting at this point. Okay, different y-intercept, and different y-intercept. That's the difference. So all parallel lines have the same gradient. The only difference is the intersection of y-axis. Okay, so this 90 degree. Now what comes is perpendicular line. So perpendicular line means that this line and this line is 90 degree intersecting to each other. Okay, 90 degree intersection, intersecting a line to 90 degree is known as perpendicular line. And in order to find the gradient of this line, we will use this: m multiplied by m is equals to -1. This is the formula in order to find out the gradient of this. The first m or the second m, whatever which one is, the first m could be is the original line, is the gradient of this line, and the second m which we will going to find out is the gradient of the perpendicular line. Okay, so we can write it like this: minus n upon m, and then we could find the gradient of the perpendicular line. Okay, so gradient of the line, gradient of the perpendicular line, this is how it is. M is equal to -1 upon m, and this is how you're going to find it. Simultaneous equation. Okay, so we have these two lines. So we have these two lines. It's going here and it's going here, and it is intersecting, and we have this equation, these two equations of these two lines. And now when you are given two equations in two unknowns such as x and y, they usually have a common solution where the two lines meet at a point. Okay, so this is a point. These are called simultaneous equation. Let's say that we have been asked a question that what is the point where the two lines intersect. It doesn't matter if it is intersecting at 90 degree or 2 degree. It could be intersecting like this, it could be intersecting like this, it could be intersecting like this. Doesn't matter. You will use a simultaneous equation, okay, in order to find the coordinates of this point. So let me just do it right in front of you guys. And y is equals to 2x minus 3. Okay, you can do the simultaneous equation using a calculator. You can do that. It's a very fastest method, or you can do it by hand as well. So I'm going to show you guys how to do it by hand as well. So let me just make it. Okay, so since we all know that it is intersecting and it has a common solution, it must have a common solution, which is why I'm going to put y into this. Okay, so it's going to be equal to -2 upon 5x plus 9 upon 5. Okay, and now I'm going to try my best to simplify it. So 2 upon 5x plus 2x is equals to 9 upon 5 plus 3. Okay, I'm using a calculator as well to simplify fast enough. So 12 upon 5 x is equals to 9 upon 5 plus 3. So it's 24 upon 5. Okay, cancel out. And 24 upon 12 is 2. So x is equals to 2. Okay, now I found the value of x. Now I need to find the value of y. I'm going to put this value of x into any of these equation. In any of these equation. You can choose any one of the equation. I'm choosing this one since this is even more simpler. So y is equals to 2 multiplied by 2. I'm putting 2 here, and then 2 to the 4 minus 3 is equals to 1. So it's going to be 1. So this is how you use simultaneous equation. Okay, inequalities in graph form. It is often possible to show the region on a graph that satisfies an inequality. Even though this inequality is not a part of coordinate geometry, but it is a part of function and quadratics. I want you guys to understand it a little bit. So we have these three of these. Let me put right here. 3 of these equations, and we have the inequality. So x is greater than 0, which means it will go right there. Y is greater than 1 upon 2x minus 2, which means this whole line, this whole green line will go here in order for y to increase, and then 2y is less than 4 minus 3x, which means you can just put more simpler, which means it's saying that 4 upon 2 minus 3 upon 2x. So y is less than, okay, it must be less than. In order to be less than, this whole blue line must go down in order for y to be less than, you know, must be less than, you need to go down. So it will go down, and y, and the value of y will be less. Okay, this is what inequality is. So you can see this animation in front of you, just watch it really closely. This is what I'm really talking about. So we shaded this region according to the given inequality. Okay, angle between line and the x-axis. How on earth are we going to find this angle between the x-axis and the line? Wait, so this is a triangle, this is x, this is mx, okay, and we need to find this angle. So I'm going to choose tan, okay, so this is p and this is b. So p upon b, tan is equals to, tan theta is equals to p upon b, and x's will cancel out, leaving only m upon 1. So this is a formula in order to find the angle between line and the x-axis. X and mx, this is the angle, you cancel out, and 1, leaving only this. This is the formula for finding the angle. And now we have this example, okay, and the acute angle between the two lines. So this is the first line, this orange or yellow you can call it, and there's the blue line, y is equal to 2x minus 4, and we need to find the angle between these two lines. So what I'm going to do, I'm going to make a triangle of this one, okay, so this is very, it's a straight triangle, and we need to find the angle of this one, okay. So what is the angle of this one? I'm just going to use tan, and then we know that the gradient is 2, so 2 upon 1, and I'm going to use a calculator, and I'm going to find the value of this angle. So it's going to be 63.4, rounding it, you know, 63.4 is the angle of this one. 63.4, okay. And if I try to make it minus to, you know, 180 minus 63.4, what will I get? 180 minus 63.4, then I will get 117. I will get 117. Okay. Now, what is the angle of this one? Okay. I'm going to use tan. Theta is equals to, okay, this is the line. I'm going to make it simplified, so it is 1 upon 2 x plus 5 upon 2 is equals to y. So 1 upon 2 is the gradient, so it is 0.5 upon 1. Okay, I'm going to use a calculator. 0.5 and yeah, 26.6. So this one is 26.6. Okay, and now what I'm going to do, I'm going to do this 180 minus 26.6 minus 117, and what will I get? 26.6. Okay, 180 minus 26.6 minus 117, and I will get 36.4. So this is what it is. This is the angle, 36.4. And since we all know what is the rule for the angle, you know, whenever we have this kind of intersection and, you know, this angle and this angle are equal, so we have found the acute angle, and then the acute angle is 36.4. This is the answer. Just see the animation right in front of you. 63.4, 26.6. Okay, I just rounded up, you know, 117, but it's fine. So it's 36.8. There you go. You can see this animation right in front of you. This is a circle. Looks like, let's say that this is a circle, you know, this whole thing is a circle, and this is the point. All right, and you can just see this point has a coordinate x and y. So this is x and this is y and x, and we have the center h and k. So what is the radius? So again, we will use the Pythagoras theorem. All right, so r square is equal to h square plus y square. Okay, but hey, we have this triangle which is, you know, h and x. Okay, h and x, this where this h, this x, and in here this is y and this is k. Okay, so h minus x and y minus k. So I'm going to put it right here. R square is equals to h minus h square plus y minus k square, and then yeah, this is the standard form of a circle. This is the standard equation of a circle. This is standard. Okay, and the best way to read this is, whenever it is written minus h and minus k, it means that this is the coordinates of the center. Okay, this is the standard equation of a circle. Doesn't matter which point you want to go with, it's the same thing. It will remain. Equation of a circle whose center is a point hk and whose radius is r is h minus h square plus y minus k square is equal to r square. Okay, so we have all these things. Then center is this. There's a sign difference. The sign will always change. Okay, There you go, this and that. What we're understanding is minus h minus k, so it's going to be hk. Okay, the sign will change, plus h plus k, which means it's going to be minus h and minus k. Minus h plus k plus k. So minus h will be h and plus k will be minus k. So sign will change. Okay, this is how you will read it. This is how you will read the coordinates of the center whenever we try to examine the equation of a circle. Plus k plus h minus k is minus h plus k. The sign will change when we read it. The sign will change when we read it. Okay, note that the sign changes whenever we find out the coordinates of the center of a circle from the equation. If the center is at the origin 0 0, then hk is 0, the equation reduced to x square plus y square r square. Let's say that we have this and we have this, and the center and the circle is at the center. Its center is at the origin, so it's like this: 0 square plus y minus 0 square is equals to r square. It could be in this way, or it could be in this way: plus 0 square plus y square is equals r square. So it's the same thing. Voila. So it's the same thing, just like that. Okay, whether it's this way or that way. Okay, so we have this equation. Question 1: find the center and the radius of each of the following circles. So starting with part 1, part A. We will start with part A. Okay, find the center and the radius of each of the following. Okay, so the center is 0 and 0, because it is like this. Or wait a minute, maybe it's not 0. Let's try again. 2x square 2y square is equals to 0. We take the common 9 upon 2, and yes, it's the center. The coordinates of the center is 0 0, as we have understood before. And as for the radius, it is r is equals to 9 upon 2. This is the radius. Okay, let me use a calculator. 9 upon 2. So yeah, this is the radius. Okay, part B. It's even more trickier than before. X minus 3 square plus 2y plus 4 square is equal to 45. We take a common, we put it there. Okay, so x minus 3 square plus y plus 4 square, and okay, minus 3 plus 4, so 3 and minus 4 are the coordinates of the center, and under root 45 upon 2 is the radius. Part B is done. Part C. X square plus y square minus 8x plus 20y plus 110 is equals to 0. Okay, so what we really need to do is let's put this here, x and then y square plus 20y, okay, and then minus 20, putting 120 on this side. Okay, now what I'm going to do, I'm going to use completing the square. That's right, completing the square for this special equation. This equation is a little bit tricky and very special. We only use completing the square in order to solve these kind of tricky questions. Okay, so what I'm going to do, x square minus 8x plus, okay, what should I put in order to make this complete? So minus 8, so it must be minus 8 upon 2. It must be minus 8 upon minus 8 upon 2 square. Okay, and then y square plus 20 upon 2 square is equals to minus 20. Since we have put this extra, we're going to put in here as well. Okay, so it's going to be plus minus 8 upon 2 square plus 20 upon 2 square. After that, I'm going to use a calculator. So it's going to be like this. So x square minus 8x, and it's actually like this. It's plus minus 4 square plus y square plus 20y plus 10 square is equals to minus 20 plus minus 4 square plus 10 square. Okay, x square and minus 4, so it's going to be x minus 4. We all know what is the formula. Yeah, that x a square plus 2ab plus b square. So we're going to see these two numbers, and then we're going to understand that these are the numbers. Okay, so these are the numbers. Okay, yeah, so plus and y plus 10, because this is y, this is 10. Yeah, okay. Square is equals to minus, okay, I just made a mistake. This minus 110, this minus 110, and this is also minus 110. Okay, so minus 110 plus 4 for the 16 and 10 tens are 100. Alright, so it's going to be x minus 4 square plus y plus 10 square is equals to 6. Because if I just see this, yeah, it's going to be 6 is equals to 6. Okay, so 4 and minus 10 are the coordinates of the center, and under root 6 is the radius. Okay, that's that. 2x square plus 2y square minus 14x minus 10y minus 163 is equals to 0. 0. Okay, so what I'm going to do, first of all, I'm going to make it simplify. I'm going to take a common all of these by 2, so and then divide by 0, so it's going to be x square plus y square plus minus 7x minus 5y and minus 163 upon 2. Okay, so x square minus 7x, y square minus 5y and 163 upon 2. Again, completing the square, so it's going to be x square minus 7x and plus 7 upon 2. Then y square minus 5y and plus minus 5 upon 2. Okay, 5 upon 2 square is equals to 163 upon 2. So 7 upon 2 square minus 5 upon 2 square. Alright, so this one is going to be x minus 7 upon 2, and this one is going to be y minus 5 upon 2 is equals to, and I'm using a calculator, summing all this up, it's going to be 100. Alright, now we have the coordinates 7 upon 2 and 5 upon 2 are the coordinates, and under root 100, which means 10, is the radius. So there you go. Question 2, find the equation of each of the following circles. Center 0 0, radius 8. So x minus 0 square plus y minus 0 square is equals to 8 square. So it's going to be x square y square is equals to 8 square, which is 64. X square y square is equals to 64. This is the equation of A. Okay. As for B, center is this one, radius is this one. So x minus 5 square and 5 plus 2 square is equals to 4 square. So x minus 5 square plus y plus 2 square is equal to 4 4 16. This is the equation. We find the equation of the circle with center 2 5 passing through the point 6 8. Okay, so this question is a little bit tricky. Find the equation of the circle with center 2 5 passing through the point 6 8. Okay, so x minus 2 square plus y minus 5 square is equals to r square. Okay, so we have this equation and we need to find the equation of the circle, and it is passing through the point this. So let's say that we have the circle and it must be around right here, so it's passing through it, right? So what we're going to do, we're going to put these values in x and y. Okay, and then we will find the radius. So x 6 minus 2 square plus 8 minus 5 square is equals to r square, and then for the 16, 8 minus 5 is 3, 3 is a 9, and r square and so forth plus 9, and it's going to be is equals to r square, and r is equals to 5. So this is the radius. So the equation is like this. 5 square is equals to 5 square, which means it's the equation is y minus 5 25. This is the equation. 3. A diameter of a circle has its endpoint at A and B. Find the equation of a circle. So let's say I'm just drawing a graph. Okay, so minus 6 and 8. So minus 6 and 8 could be right here, and 2 and minus 4 could be, right here, and then we make a circle. And this could be the center, and if you pass through this line, it must be a straight line, and so we can just find the center of the circle by using a midpoint formula. So minus 6 plus 2 upon 2. Okay, for the x, and for the y is 8 minus 4 upon 2. Okay, so minus 6. Okay, so it's going to be x is equal to minus 2, and y is equals to is also minus 2 is equal to plus 2. So the center, the coordinates of the center is minus 2 and plus 2. Okay, so it's going to be x plus 2 square y minus 2 square is equals to r square, and now we need to find the r square. So we're going to put any one of these two values. Let's say I'm putting b. Okay, so I'm going to put b. So 2 square plus minus 4 minus 2 square is equals to r square. 4 4 is 16, 6 6 is 36 is equals to r square, and so it's going to be, okay, so 16 plus 36, it's going to be 52. So yeah, this is how it is, 52. So we have found the equation of a circle. So it is this, y minus 2 square is equals to 52. This is the Equation 4. Find the equation of the circle which passed through the point 2, minus 2, and 3, 4, and whose center lies on the line x plus y is equals to 2. Okay, find the equation of the circle which passed through the point this and this. You can just call it A and B, pass through the point this, and whose center lies on the line x plus y is equals to 2. So let me just draw the graph. Alright, x plus y is equals to 2, so y is equals to minus x plus 2. So it's going to be like this. Minus x plus 2. Okay. Minus x plus 2, so this is plus 2, it's intersecting in here, so it's going to be like this. Okay, this is the line. Find the equation of the circle which passes the point and whose lines, okay, the center lies on this line. Okay, the center lies on this line, x plus y. So okay, it lies on this line. Now, so I have these 2 points, 2 minus 2, so it's going to, okay, 2 minus 2, so it's going to be here, 2 minus 2, and 3 and 4, and it's going to be like here. Okay, and let me just draw a line through it. I'm going to make a line. I'm going to find the equation of it. Let me just find the gradient. Let me write it down. 3, 4, 2, minus 2. Okay. Yeah. Okay, so I'm going to find the gradient. 4 minus 2 upon 3 minus 2. 6 upon 1. So the gradient is 6. Okay. So y is equals to 6x plus c. And then I'm going to put any of the values. Let's say I'm putting 2 and minus 2. So minus 2 is equals to 6 multiplied by 2 plus c, so c is equals to minus 14. So the equation is y is, so it's plus actually, plus 6x minus 14 is the equation. Okay, the equation of this one. I'm going to find the equation of the perpendicular line of this line. So I'm going to find the equation of the perpendicular line. Okay, and the perpendicular line will intersect the midpoint of this line, of this A and B point. It must cross the midpoint, and after crossing it, I'm going to use I will do the simultaneous solve, and I'm going to find the center of the circle, and that's how it is. So okay, so let me just remove all this, and then I'm going to show you guys a bit animation, some bit of animation, then you'll guys understood it. Okay, so this is the graph. Okay, x plus y is equal to 2. We have the coordinates, and then we're going to make a line. We're going to find the gradient of this line. So we are finding the gradient, and it is 6. So y is 6x plus c. Then putting any of the two values, any of the the coordinates of any of the 2 points, and we have founded the equation. Then we are going to find the gradient of the perpendicular line, and the perpendicular line must cross the midpoint. There you go, it crossed the midpoint of this, and we also need to find the coordinates of the midpoint, so it's 5, 1, 2, and 1. There you go. And then after that, okay, we're going to find the equation of this line as well, of the perpendicular line, and then we are going to do simultaneous solve of these two equations, x plus y is equal to 2 and y is equal to minus x minus 1 upon x plus 17 upon 2. We're going to do simultaneous solve, as you can see in front of you in the screen. We have founded the values of the center of the coordinates. Now put any points, 2 minus 2 or 3, 4, let's say 2 minus 2, and then putting the values, and then you will find the radius. So this question is a really difficult question, and it's very unique, and I want you guys to know this pattern. Okay, so this is it for today's coordinate geometry. Hello and welcome back. This is topic 6, circular measure. Okay, and in this video we are going to understand about the circle, its properties, angle properties, and all the stuff, whatever we need to learn about the circle, and we need to understand what's the difference between degree and radian. Okay, so let's begin. So this is a circle, this is the radius, this is the diameter, this is a chord, this is the tangent to the circle, it's touching the one point, this is a segment, the area is a segment, and this part is a sector, and this is the arc length. So this area is a segment, okay, this one is a segment, and this pizza part is a sector, and this this and the part of the perimeter is known as the arc length, and the whole perimeter of a circle is known as the circumference. And you all know what the tangent is. Tangent is something that you put a line, you cross a line to only just you're touching the one point of the circle. You're just touching the one point of the circle, and then after that it will become a 90 degree. It will become a 90 degree to the radius and reaching the circle. Okay, so this is the radius, this is the tangent. It's going this side. It will become a 90 degree. Okay. This is everything about the circle. Now, the symmetry properties of the circle. You need to know what is the symmetry properties. Okay, starting with the chord. So this is the chord. If you try to bisect it, then it will be the perpendicular bisect of the chord pass through the center of a circle. Okay, this is the chord, another chord, and if there is equal chord, then it will be equidistant to the circle, to the center of the circle. And the third is what happens if we put a tangent to the circle. Then obviously it will become a 90 degree to the center of the circle. The angle between the tangent and radius of a circle is 90 degree, and these two angles are equal, since it is equidistance. And this part, the angle Okay, so this part is about the rectangle. That if, for example, there's a rectangle in a circle, then its angles on opposite side will add up to 180. A plus B will be 180, and C plus D will be 180, etc. But if the rectangle is if the part of the angle is outside of the circle, then this condition will not be acceptable. Okay, you cannot say that the angle of A and angle of B, A plus B is 180. No, sir, because this part of the angle is outside of the circle. That's why. So you need to make sure that the rectangle must be inside of the circle in order to meet this condition. In order to meet this condition, that the opposite side will add up to 80. Opposite side will add up to 180. Okay. The symmetry. The cyclic quadrilateral has 4 points of the quadrilateral touching the circumference of the circle. Angle properties of a circle. Okay. Let's say that there's a triangle. As it doesn't matter which part of the it is touching the circumference, it will remain as 90 degree. Okay. Doesn't matter if it is going from this side to this side, but the condition is it must touch the point of the circumference. Okay. This animation. Here's another one. Okay. If you try to stretch this out to touching the point of the circumference, then A is equal to multiplied by B, and it doesn't matter if it is in different position, the will be same. Doesn't matter if it touches in different position. It doesn't matter if it touches the circumference of the circle in different position. As long as it is touching it, it doesn't affect the angle. And the angle of A is bigger than the angle of B, and in order to find the angle of B, you need to divide A by 2 is equal to B. Okay. The same thing, the same rule applies as this one to this one as well. Okay. Same thing. And this one is also yeah, it's also the same thing. Closely same thing. Okay. Radian and a degree. Okay, you know what is a degree? 90 degree, 20 degree, 360 degree, but in radian it's in 2 pi pi or pi upon 2. This is radian. Okay, so the difference between degrees and radian is, let's say that there is 90 degree, so it's going to be pi upon 2. If it is 180 degree, then it's going to be pi. If it is 360 degree, then it's going to be 2 pi. Okay, and what actually the radian is, that 1 radian is equal to 1 circumference upon 1 radius. This is what a radian is. Okay, or you can just simply put this in this way, that as the circumference is directly proportional to radius. Okay, if the radius is larger, the circumference will be larger. Okay, and if you remove the proportionality sign, then it's going to be this way. This is the formula. You can write it in this way. Okay, this is the radian, this is the circumference, and this is the radius. Okay, this is the formula. And if you want to know the circumference of the circle in radian form, then you can put in this way, that 2 pi r is the total circumference multiplied by radian upon, and the total radian is the total radian is of the circle is 2 pi. Okay, so pi is cancel out, leaving okay, and 2 also cancel out, leaving only. Okay, you're just finding the circumference of the circle. So as arc length, you can say arc length or the whole circumference. Okay, so r radian is equals to circumference or arc length. This is formula 1 for the circumference, or you can say for the arc length. And as for the area, let's say pi r square multiplied by radian upon 2 pi. So pi cancel out, leaving only 1 upon 2 r square radian is equals to area of a circle. So this is formula 2. Okay, so this is what radian is. So radian is basically is that 1 radian will be 1 circumference upon 1 radius. This is what radian is. Okay. Degrees have different formulas for circumference and area, and radian have different formulas for circumference and area. 1 radian is the angle subtended by an arc length equal to the radius of the circle. Alright, so this is what radian and degree is. Now coming for the cone. You need to understand a little bit about cone, and you need to understand about the slant height and all these things. The slant height is the height which is slant. It's like this. This is the slant height. This is the normal height that we vertical height. And this is the radius, and this is the circumference of the circle, and this is the peak. Okay, it's small. You can say the cone is like a hatch. You can find the slant height by using a Pythagoras theorem. Okay, so L square h square plus r square, like I told you, to find the slant height. This is the volume, and this is the total surface area. This is the volume. The volume will be 1 upon 3 multiplied by pi r square multiplied by h. It's a similar thing like having a cylinder. First of all, we try to take the area of a circle, which is pi r square, and then we try to take the height, which is h. But we are multiplying with 1 upon 3, since it's like, it's small, it's like this. This is the cone, this is the cylinder. Okay, so it's 1 upon 3 of the original cylinder. The area of the cone is 1 upon 3 of the is 1 upon 3 of the original cylinder. So which is why the volume is this 1 upon 3 multiplied by square multiplied by h. And as for the total surface area, pi r square, which is the circle, and plus pi r l. Okay. For the cylinder, it's actually it's actually 2 pi r h for the curved surface area. It's curved, but as for the cylinder, it's actually pi r square, which is the area of a circle. Okay, as for the total surface area, what we have here, pi r square plus pi r l. Pi r square is the area of a circle, and pi r l is the curved surface area. Curved surface area. This whole rotate part, curved surface area. Okay, let's begin. Okay, what will happen if we have only a part of a circle? Then it's quite similar to the cone. If we try to let's suppose that this is a piece of paper, and you just want to make a hat. So a hat would look definitely like a cone. So let's see here. This area of this area will be equal to the curved surface area of the cone. This area will be equal to curved surface area of the cone. This radius will be equal to the slant height of the cone, and as for the circumference, it will be equal to the circumference of this circle. Of the base, you're looking at the base, right? This is the base, the circumference of the base circle. Very important, because these are tricky. There are tricky questions in the A-level math circular measure that you need to understand each and everything. You need to prepare for each and everything. So bear in mind with it. So that's that. Now we will start with questions. Now let's start solving the questions. In the diagram, OPQ is a sector of the circle, center O and radius r centimeter. Angle QOP is equal to this radian, and the tangent to the circle at Q meets OP extended at R. Show that the area A of the shaded region, this is a shaded region, you can see this is a shaded region, is given by A is equal to 1 upon 2 r square tan radian minus radian. So okay, so we need to prove that this is the equation. We need to show that. We need to show it. So we need to find the area of this shaded region. All right. So let's start with removing this draw. Okay. Let's start with finding this side. Okay, so PB, so tan theta is equals to P upon R. So it's going to be P is equals to R multiplied by tan theta. So this part is R tan theta. Okay, and now let's take the area of this whole triangle. So 1 upon 2 R tan theta multiplied by R. So it's going to be it's going to be 1 upon 2 R square tan theta. Okay, this is the area of a triangle. Now as for the sector, we know how to find the area of the sector. It's like this: 1 upon 2 r square and theta is the area of the sector. Okay, now we're going to minus it. We're going to do subtraction with triangle minus the area of a triangle minus area of a sector in order to find the shaded region. So after doing the subtraction, it's like this: 1 upon 2 r square tan theta minus 1 upon 2 r square theta. Now we're going to take the common. So 1 upon 2 r square tan theta minus theta. Okay, and we can see that it has been proved. Part 1 is done. Part 2. In this case, where theta is equal to 0.8 and r is equal to 15. Evaluate the length of the perimeter of the shaded region. Okay, in the case where theta is equal to 0.8 and r is equal to 15. Alright. Now we need to find... Okay, we can just put in here to find the side. This is you can see that this is a triangle. Alright. This side is 15. This side is 15 multiplied by 10 multiplied by 0, and 0.8, then 0.8, and so it's going to be, I'm using a calculator, then 0.8, and so it's going to be 0. Okay, you know what, you need to put, okay, remember one thing, that you need to change the setting from, degree to radian in a calculator. Always remember it, or else you're going to do some mistakes. Okay, so 15 multiplied by 10 and 0.8, which is the radian, so it's 15.44. So it's actually 15.4. Okay, now what should I do? You need to find this side as well. We need to find this side as well. So we are going to use the Pythagoras theorem. So 15.4 square plus 15 square is equals to x square, and then we're going to do it directly. We're going to find the value of x. So plus 15 square, then under root square, and it's 21.5. This one is 21.5. All right. And you can see this, 21 minus 21.5 minus 15. This whole side is 21.5 6.5. So now if I try to minus with 15, what will I get? I will get 6.53. So it's going to be 6.53. Okay, so this side is 6.53. This side is 15.4, and now we need to find the arc length of this sector. Okay, in order to find the arc length, we will use the formula S is equals to R theta. So in order to find the arc length, okay, 15 multiplied by 0.8, and what is the arc length? So 15 multiplied by 0.8, 12. So it's 12. Okay, so this part is 12, and now we're going to add all things up, all of it. So 12 plus 6.53 plus 15.4. We try to add to the addition. 6.53 plus 15.4, then it's 33.97, 33.93, and this is the answer. Good. Question 1 is done. Question 2. The diagram shows the sector OPQ of a circle with center O and radius r centimeter. The angle POQ is this theta radian, and the perimeter of the sector is 20 centimeter. The sector, we all know what this sector is. This is a sector. This is a sector, and this is the arc length, and this is the radius. You know, so the perimeter of the sector is 20 centimeter, which means the whole perimeter of the sector is 20 centimeter. The 20, so 20 is equals to, okay, wait. Okay, so 20 is equals to radius plus s. Okay, so 20 is equals to 2r plus, as we all know that s is equals to theta multiplied by radius, so theta and r, and so forth. It's going to be r is, we take the r common, and 2 plus theta, and then on r minus 2 is equals to theta, and there you go. Part 1 is that part 1 is done. We need to show that this is this. So part 1 is done. Okay, part 2, express the area of the sector in terms of r. So we need to find the area of a sector. In order to do that, we will use the formula multiplied by r square multiplied by theta. So we put the theta as we have as it has been shown in part 1. 1 upon 2 r square multiplied by 20 upon r minus 2. Okay, we go to multiplication, and then it's going to be 1 upon 2 r square multiplied by 20 upon r minus 1 upon 2 r square multiplied by 2. Then 2 will divide by this, and r will divide by this, leaving only 10 r minus 2 will divide by this, so r square. Okay, this is the area. And then we're going to do part 3, in this case where r is equals to 8. Find the length of the chord PQ. Okay, it's a little bit tricky. Find the length of the chord PQ. So this, which means this forms a triangle where we have a radius, and the value of the radius is 8. So it's going to be 8, and if you put the value of 8 in here, then it's going to be, if you put the value of 8, then theta value will be, let me use a calculator, 20 upon 8 minus 2. So it's going to be 0.5. So 0.5. Okay. So how on earth are we going to find the length of the chord? We're going to use the cosine rule, as we have understood in O-level math course. If you didn't watch it, and you can just watch it right now, O-level math course in my YouTube channel. You can check that out. So L square is equals to 8 square multiplied by 8 square minus 2. Okay, I've done wrong. 8 square plus 8 square minus 2 multiplied by 8 multiplied by 8 multiplied by cos 0.5. Okay, and I'm going to use a calculator directly. Answer is 3.96. Okay, part 2 is, question 2 is done. Okay, question 3, in the diagram the circle has center 0, radius 5 centimeter, and PQ is 9 centimeter. The tangent to the circle at P and Q meet at the point T. Calculate the angle POQ in radians, the angle of the length of PT, and the radius of the shaded region. So POQ. But how to find the angle? So S is equals to theta multiplied by r. We know what is the value of S. It is 9. The arc length is 9. The radius is 5, and so we are going to use a calculator to find the radian. 9 upon 5, and 1.8 is the radian. Okay, so this is 1.8. Okay, the length of PT. So this is we need to find the length of PT. So we're going to divide this. We're going to make it half. Since we know that this is a tangent, so it's going to be 90 degree. Okay, and 1.8 will be divided into 0.9. So 0.9 in here, 0.9 in here. The angle. I'm talking about the angle. Okay, let me zoom it out. Okay, so we need to find this value, the length of PT. So let's put this here, x and x. Okay, so P and B. So 10 theta. We know what the theta is. 0.9 is equals to P, which is x, and B, which is 5. So x is, we're going to use a calculator, and then 0.9 multiplied by 5, so 6.3 is the answer, is the length. So it's 6.3. Okay, now part 3, the area of the shaded region. What is the area of the shaded region? All right, so what we're going to do is we're going to take the area of each side. So take the area of the triangle 2 times. So 1 upon 2 multiply by 5 multiply by 6.3. Okay, we find the area of the triangle and multiply by 2. All right, good. And then we're going to subtract by putting the area of the sector. So area of the sector is 1 upon 2 r square means 5 square. 5 square multiply by theta, which means 1.8. There you go. And now I'm going to use a calculator. So 1 upon 2 multiply by 5 multiply by 6.3 multiply by 2. Then minus 1 upon 2 multiply by 5 square and multiply by 1.8. So the area is 9. Okay, part 3 is done. Part 1 is done, part 2 is done, part 3 is done. Question 3 is done. Now let's move to question 4. Question 4. The diagram shows a sector of a circle with center O and radius 20 cm. A circle with a center C and radius x cm lies with the sector and touches it at P, Q, R. Angle P or R is equals to 1.2 radians. Show that x is equals to 7.218 correct to 3 decimal places. Okay, so let's see. So you can see this and you can see this. We know that this line will act as a tangent to the circle, so that's why it's going to be 90 degree. It's going to be 90 degree. Let's split this into half. Just assume this is a circle. This is a straight line. All right, and we all know that this is a circle, and outside of the circle is a sector with a radius of 20 cm. So right now we can assume that in here, obviously, it's going to be 20 cm. All right, which is why 20 cm is equals to x plus OC. Okay, so 20 minus x is equals to OC. Okay. OC. Right now this is x, this is OC. We have the radian 0.6 and 0.6. So P and H. So sine 0.6 is equals to P, which is H, and P which is x, and H hypotenuse, which is OC, and OC is 20 minus x. Okay. So now what is the value of sine 0.6? Bear in mind that 0.6 is a radian. Okay. Okay, sine, you know what, I could just write it down like this. Sine 0.6 multiplied by 20 minus sine 0.6 multiplied by x and x. Okay, let me use a calculator now. 0.6. Okay, multiply by 20, so it's 11.30. It's 11.30, and since we know that it's going to get addition excess with plus, so 1 plus sine 0.6. So it's going to be 1.56. 0.56x 11.30 and x is equals to, now I'm going to make a division. So sine 0.60 multiplied by 20 upon, so 7.2178. This is what I got. Yes, it has been shown. Corrected 3 decimal places. Part 1 is done. Part 2, find the total area of the 3 parts of the sector lying outside of the circle with center C, which means these are the 3 parts. 3 part. Okay, so what we're going to do, we're going to take the area of a sector minus area of a circle. So area of a sector is 1 upon 2 multiplied by r square, which means 20 square multiplied by angle, which is 1.2. Okay, minus, and the area of a sector will be pi r square. Pi r square means r is 7.2178 square. Okay, I'm going to use a calculator. 6.3 is the answer. Okay, part 2 is done. Part 3, find the perimeter of the region OPSR bounded by the arc PSR and the line OP and OR, which means this part PSR, OR, PR. This whole part we need to find the perimeter. Alright, so we can easily find the perimeter of OR and PR. This is actually going to be 10. So 10, 0.6, P which is x 7.2178, and B, which is we need to find. So what is the value of P? So I'm going to use a calculator now. 7.2178 and 0.6, and so 10.55. Okay, so OR and OP is 10.55, 10.55. As for the arc length of PSR, we are going to, okay, right now you can see this, that it's like this, right here, then it's right here, and then it's right here, and then here, and then here. Okay, it's a 90 degree. This is split up. Okay, Now this is 0.6 and this is 90 degree, which means this is pi upon 2. So pi which is 180 degree, pi minus pi upon 2 and minus 0.6 is equals to, I'm going to use a calculator again, pi upon 2 minus 0.6, so it's going to be 0.97, and if I try to multiply by 2, then it's going to be 1.94. So this whole radian is 1.94. Okay, now I'm going to find the arc length. So S is equals to R, which is 7.218 multiplied by 1.94, which is a radian. And if I'm going to find it using a calculator, multiply by 7.218, so it's 14. Okay, so the arc length is 14. So the perimeter is 14 plus 10.55 plus 10.55. Now I'm going to use a calculator. Okay, so 10.55 plus 10.55, so it's going to be 35.1 centimeter, and yes, this is the right answer. Okay, well done. Question 4 is done. Okay, so that's that. This is question 3. Question 3 is done, and this is the end of topic 6. And now we're going to move forward to topic 7, which is trigonometry. Okay, goodbye. Hello and welcome back. And today our topic is topic 7, trigonometry. Okay, and in this video we are going to understand about the unit circle, and we're going to go deeper. We're going to understand some graphs of the sine, cos, and tan, and we are going to understand about the identities as well. Okay, so let's begin. Okay, so as you can see, first of all, this is the right angle, and we have already understood about we have already learned in O-level maths about the Pythagoras theorem, hypotenuse, the opposite, and the base. And then after that we also learned that how to find the angle using sine, cos, and tan. Okay, as you can see that whenever there is a theta, then the opposite p, then we can find the angle using sine, which is by the opposite p and the hypotenuse. If there's a theta and we have been given the opposite sine and the hypotenuse, then we can use the sine in order to find the angle. And whenever we have been given a base and hypotenuse, then we can use cos, and whenever we have been given both the opposite p and base, then we can use tan. Okay, and it doesn't matter if the theta is in here. If it is here, then this is the opposite p and this is the base, and if the theta is in here, then this is the opposite p and this is the base. Okay, similar, it's the same thing. Okay, so right now you guys can see this animation. Yeah, it's the same thing, the opposite p. Now let's say that we have a circle with radius 1, the unit circle. We are going to understand this, and it's really important for you guys. Right now you can see that this is a circle, the unit circle, and as you can see in front of you that the way that the angle starts from the anti-clockwise direction. It starts from the anti-clockwise direction. First it becomes 90 degree, then becomes 180 degree, and then it becomes 270, and then it becomes 360 degree. Okay, so it starts from the anti-clockwise, and we have a radius 1. Okay, it's the same thing as x-axis and y-axis. This is the x-axis, this is the y-axis, 1, 1, minus 1, minus 1, okay, etc. And suppose that we have a triangle with this, with radius 1, hypotenuse is 1, or hypotenuse is 1, as obviously because the radius of a circle is 1, and as you can see that this is the angle theta, and in front of you is p. But since we can use this formula that p upon 1 is equals to sine theta is equals to p, so we can also write it down as sine theta and cos theta, as you can see right in here. Okay, so this is the first step for you guys to understand that since we have 1 as a hypotenuse, we can replace p as sine theta and cos and b and cos theta. Since there is a theta, and this is the sine theta, this is the cos theta. Okay, and as the angle goes from the anti-clockwise, the triangle will it goes like this, and then this. Okay, so it's going toward here, and you can see that the sine theta is increasing and cos theta is decreasing. Okay, when it reaches 90 degree, so sine 90 degree is equals to 1. Okay, since this vertical height is a sine theta, since this vertical height is a sine theta, so sine 90 is equals to 1, and cos 90, since this cos is a base and the base is decreasing as this triangle going toward going toward anti-clockwise, so it's decreasing and it's decreasing, and then it will become a vertical line at 90 degree. So sine 90 degree is equals to 1 and sine 90 degree is equals to 0, and then after that it again start from anti-clockwise, and it you can see this, that in here the sine theta is decreasing, the vertical height is decreasing, and cos theta is increasing. So if I say sine 80, then obviously it's going to be 0 since the vertical height is gone, and cos 80 will be minus 1. Okay, the cos 80 will be -1 since we have it becomes a line like this, okay, and so forth. Okay, now we're going to see some animation. I have tried my best to make this animation for you guys to understand. Okay, so here we go. This is a unit circle with radius 1. All right, all the angles theta are in the anti-clockwise sense, and the values of theta are said to be positive. Okay, so if we go from the anti-clockwise, it going like this, so it's going to be positive. But if it is going from the clockwise direction, then it will be negative. Okay, so going from anti-clockwise, the angle will be positive, and if it is going from the clockwise direction, then it's going to be negative. Okay, so right now, as you can see this animation. Okay, since we have this, this triangle, and this is the theta, this is the sine theta, this is the cos theta, and in order to find the tan, you can obviously there is an identity that I want you guys to know, that tan theta is equals to sine theta upon cos theta. Since we know that the tan theta is equals to p upon b. Okay, so in this sector of the circle, we can see that the sine theta is positive since there is 1. The x-axis 1 is positive, and the y-axis 1 is also positive. So sine theta is positive since vertical height is positive, and cos theta is also positive since the horizontal line is positive. And since sine upon cos is theta, and since tan theta is equals to plus sine theta upon cos theta, so tan theta is also positive. So we have this. Okay, so you guys need to understand this. You guys need to memorize this. Okay, and as the triangle go from the anti-clockwise, it will become a complete straight line, and 90 degree, and in 90 degree the sine will be 1 and cos will be 0, and tan 90 degree will be undefined. Actually, the tan is basically a tangent to the circle. So it's actually like this, that for example, that we have the circle, the unit circle, and it starts from here, and then it becomes a tangent to the circle. This is actually what tan is, and in here it becomes a straight horizontal line tangent, and it's actually infinite, so it's undefined. You can see this animation. Okay, right now you can see that this is the triangle. Okay, this is the sine theta, this is the cos theta, and right now you need to observe one thing, that the cos theta is minus. It's actually negative, since the horizontal line, as we have already understood in coordinate geometry, that this part of the x-axis is positive x-axis, this is the negative x-axis, this is the positive y-axis, and this is the positive, and this is the negative y-axis. So similarly, it's the same thing. So in here, the cos theta will be negative, and sine theta will be positive. It will still be positive because the y-axis is positive. It's positive, and the x-axis of this one is negative. Okay, sine theta is positive, and so you can see this, and tan theta is also negative. You can also find that you can also find whether tan theta is positive or negative by using the identity tan theta is equal to sine theta upon cos theta. Since this is minus cos theta, so tan theta will also be minus. Moving on. Okay, as I told you, sine theta will be positive, since sine theta is since sine theta is known as the vertical height of the triangle sine theta, and right here is the y-axis is positive 1, which means sine theta is positive, minus cos theta minus tan theta. Okay, you need to understand, remember this. Okay, right in here we can see that the y-axis is negative, and the x-axis is also negative. Sine theta is negative, and cos theta is also negative. And if you want to know what is the sign of tan theta, so minus sine theta upon minus cos theta, minus cancel out, so tan theta is positive. Okay, like I told you. Okay, in this side, the x-axis is positive, so which means the cos theta is positive. The y-axis is negative, which means sine theta is negative, and tan theta will also be negative. So in this sector, positive in this sector only cos theta is positive. Okay, in this sector all of them are positive. In this sector only sine theta is positive. In this sector only tan theta is positive. Okay, this is how you're going to remember it. I just showed you guys this animation, so I hope that you guys have understood. You need to understand if you try to understand this thing with concept, it will be easy for you guys to memorize it. Okay, let's begin. And there you go, the end of it. Okay, now there's another thing for you guys to understand. The most important thing, the base angle. So this sign is known as the base angle because it's starting from the base. Okay, it's starting from this line. This is known as base angle or associated acute angle. So whenever we want to know the angle from this sector, we will always try to find the base angle, and the base angle is equals to theta. Let's say that okay. Let me just make a triangle. Let me just make a triangle, and let's say that in here the value of sine theta is 0.8. Okay, which means if this is 0.8, then in here it can also be 0.8 as well. It can also be 0.8 as well, and it can also be 0.8 as well. Right here. This point. So Sin theta is positive in here, negative in here, and negative in here. Okay, if I wanted to know the angle from this sector, then I will try to find the base angle, you know. So sin theta, inverse sin theta 0.8, and I will try my best to find the angle. Let's say that, okay, I'm using a calculator. So it's 53. 53 is the angle right here, but it can also be right from here as well. Okay, we don't know which one is it. So obviously there's all there for the theta there will always be two possible values for the theta. Okay, so 0.8 is in here as well, and it is in here as well. Okay, which means that there are two possible values for the theta. First, it's this one, either it's 53 degrees or it's going to be, okay, if I try to see this, then 180 minus theta minus 53 is equals to 180 minus 53 is equals to 126.9 theta. It can also be this one as well. So let's say that, so we have 0.8. We have the sin theta is we know that the value of the sin theta is 0.8. So it can be from here as well, and it can be from here as well, since both in both sector the sin theta is positive. Okay, so either it's 53 degrees by finding the angle, or either it's going to be 126.9 degree. Okay, so let's start the animation. Okay, so I want you guys to understand this. On this sector, it's going to be 180 minus base angle is equals to theta. On this side, it's going to be 180 plus base angle is equals to theta. Or in this side, it's going to be 360 minus base angle is equals to theta. Okay. Now let's do the example 1. Solve and find the value of theta in the range. This is you have been given the range, and sin theta is equal to 4. Okay, so this is the unit circle. This is 0.8, 53.1 degree. Okay, so there are two possible values. So the second one is 126.87. Just like I was doing before, it's the same thing, you know. So you will always get the two possible values of theta. Example 2. What happens if we get in negative ratio, you know? Which means it could be in the second sector, or it could be in the third sector as well. Since in the second and third, both of them are minus cos theta. Okay, and you will always find the two possible values of the theta. So like I told you guys, you guys need to remember this, you know. You guys really need to remember these four relations. Now we are going for the graphs. So this is the graph, this is the y-intercept. Just like in coordinate geometry, this b tells us the number of waves for a complete 360 degrees. If it is written 2, then it means that two waves are formed within a 360 degree. If it is written 0.5, which means only half of the wave is formed in a complete 360 degree. And this one is the amplitude, you know, the amplitude. This is the amplitude. Okay, so we need to, this is the graphs are really important. This is the sine graph in 360 degree. This is the cos graph in 360 degree, and this is the tan graph. And this vertical line is the infinity point, is the infinity line. Okay, it can only go near it, but it cannot, you know. So there are different conditions. Okay, sine 2x. Right now you can see this, that if we look at this one, that y is equals to 1 sine 1x plus 0, which means y-intercept at 0, 1 is the amplitude, so it's 1 and minus 1, and 1x, which means one wave per in a complete 360 degree. So this is a complete one wave. Okay, in sine 2x is, you know, 1, so 1 amplitude, 2, which means it's going to be 2 waves. This is the 1, and then this is 2 in a complete 360 degree. 1 upon 2, which means it's only half of a one wave, so it's going to be half in 360 degree, and minus, so it's going to be a reflection, or you can say it's going to be opposite one, starting from the opposite, and it's like this. Okay, so these two are the opposite, minus sign and positive sign. Okay, let's start. And yeah, this is it. These are all the graphs. These are the conditions that you guys need to understand it. And now let's go for the questions. Okay, question 1. Solve the equation 2 sin theta plus 3 sin theta minus 2 is equal to 0. Okay, 2 sin square theta and sin theta. You can replace this as, you know, x is equals to sin theta. So it's going to be like 2x square plus 3x minus 2 is equals to 0. And then you're going to, I'm going to use a calculator directly. You're going to do, you know, either do factorization, or you can just directly use a calculator like I'm doing right now. So 2, 3 minus 2, so it's going to be x is equals to 1 upon 2, and the other one is x is equals to minus 2. And if I try to replace with sine, so sine theta is equals to 1 upon 2 and sine theta is equals to minus 2. This will give an error. Obviously minus 2, the radius of a circle is 1, okay, so it's minus 2, it's too much, so it will give an error. And as for 1 upon 2, let me just use a calculator. So inverse sine 1 upon 2, so it's 30. Okay, so the base angle is 30. Okay, right now you can just see this. Okay, let me just draw the circle. Let me just explain this to you guys. 0.5, so this is 0.5. Okay, this is the triangle, and this is 0.5. Now I found the theta. So the base angle as well. The base angle is 30. So the theta is 30. Okay, since sine is positive, since the sine theta is positive, so it can be in here and it can be in here as well. It can be in both sides. Okay, it can be in here as well. 0.5. In order to find the angle of this side, we will use 180 minus base angle is equal to theta. So 180. So 180 minus 30 is equal to 150. And so 150. So both are correct, both are the answer, the two possible values of the theta. And we have to also see the range, it fits in the range as well. So this is the answer for question 1. Question 2. Solve the equation 4x squared plus 7x minus 2 is equal to 0, x equals sine square. Okay, so first of all, let me just solve this. I'm going to do it directly. I'm using a calculator, since calculator is allowed in A-level math B1. 4, 7, minus 2. And the first one I got is x is equals to 1 upon 4. And the other one I got is x is equals to minus 2. And if I put as sine square, since we have been given this, sine square is equals to 1 upon 4 and sine square is equals to minus 2. This will obviously give an error. Okay, this one is right. So if we put a square in it, so then it's going to be 1 upon 2, positive and negative as well. Okay, so sine theta is equals to 1 upon 2 as positive and sine theta is equals to minus 1 upon 2. So let me draw the circle. 1 upon 2, 1 upon 2, it could be in here and it could be in here for the positive side. 0.5, 0.5. Okay, and it could be in here and in here as well, minus 0.5 and minus 0.5. I'm talking about the sine theta. Okay, so in both sides, let's start with the positive one. Let me use a calculator first. So the inverse sine 0.5, so it's going to be 30. The base angle is 30, and then if okay, we have got this. And for the second, in the second sector of the circle, it's going to be 180 minus 30, so it's going to be 150. Okay, so in the first it got 30 degree, and the second it got 150. Now I need to see the third and the fourth, because it can be in both sides as well, in the negative sine theta. Okay, so in the third it's obviously 180 plus base angle, and the fourth it's 360 minus base angle. So 180 plus 180 plus 30 is 210. So this one is 210, and 360 minus 30 is 330. Okay, and if I see the range, then yes, these four are the answers. This is the answer. Question 3. Solve the equation 3 tan 2 theta plus 15 is equals to 14 for this range. Okay, so we have been given the range as well. Let's start. Then I'm going to 14 upon 3. So it's going to be upon 3. Okay, so I'm going to do, what am I going to do? I'm going to go to like this, that inverse tan 14 upon 3. Okay, so since tan is positive, which sector is going to be in? It's going to be in the first one, since tan is positive, and it's going to be in the third since tan is positive. Okay, so inverse tan. So 14 upon 3 is 77.9. Let's put this at 78. So the base angle is 78. The base angle is 78. So 2 theta plus 15 is equals to 78, and 2 theta plus 15. Since in the third quadrant, okay, you know what is the first coordinate, second coordinate, third coordinate, fourth coordinate. In the third sector, you can call it the third coordinate. You can find this angle using plus base angle to theta. Okay, so plus 180 is going to be 258. Okay, and now let's simplify this. So it's going to be 78 minus 15 upon 2, and here it's also going to be 258 minus 15 upon 2. So I'm going to use a calculator. 31.5 is 121.5. And if I try to see the range, then it fits in the range, so which means these both answers are correct. This is the answer. Question 4. Solve the equation sine this cos this equals to sine this for this range. Okay. So sine cube plus cos cube is equals to 9 sine cube. So cos cube is equals to 9 sine cube minus 1 sine cube is 8 sine cube. Okay. And then I'm going to put 1 upon 8 is equals to sine cube x cos cube x, and then just guess it what it's going to happen. This is going to be converted into tan 3x, tan cube x, and 1 upon 8, and then if I put an under root, then it's going to be 1 upon 2 tan x. Okay, and if I try to find this, then obviously this is going to be in the first quadrant and it's going to be in the third quadrant. So yeah, I'm going to use a calculator now. So tan inverse 1 upon 2 27. The base angle is 27 actually, and in the third quadrant, 180 plus base angle, so 180 plus is 207. Answer. Question 5. Solve the equation 3 cos square theta minus 2 cos theta minus 1 is equal to 0. We're going to replace the cos theta with x. Okay, so 3x square minus 2x minus 1 is equal to 0. Now I'm going to use a calculator now. X is equals to 1, and the second one is x is equals to minus 1 upon 3. So cos x is equals to 1 and cos x is equals to minus 1 upon 3. Okay, so if I try to find out cos 1, okay, so this one is 0. It will give 0. This one. Let's focus on this one. Okay, so minus 1 upon 3, which means this one is minus 0.333. So it's actually minus 0.33. So if we have the unit circle, then on this side it's going to be minus 0.3, and on this side it's going to be wait, it's going to be like this, right? Okay, it's not going to be like this. It's actually going to be from here. This is minus 0.3 since this is cos, and in here as well. Okay, so in the second and third quadrant the cos theta will be negative, so it's going to be minus cos in both of these cases. So first of all, I'm going to find the base angle. Okay, and then you're finding the base angle, I will minus subtract it from 180 in order to find the theta from this sector, and for this sector I'm going to 180 plus base angle is equals to theta. Okay, but since we have been given this range that it must be less than 180, so yeah, you cannot do this since it is out of the range. But you can go from the opposite side, and by means opposite side, which means in negative angle, and through the negative angle, you can also get minus 0.3. So going from the negative side, negative theta. Okay, since the range is range is greater than minus 180, greater than minus 180, which means in here it's going to be minus tan 180 theta minus base angle is equals to theta. Okay, now let's find out the base angle. Then what is the base angle? Okay, one thing for you guys to understand, that whenever you try to find the base angle, and I've already shown you guys in the animation as well, first you take this as positive, so inverse 1 upon 3 positive in order to find the base angle. So it's going to be cos 1 upon 3. We have found it, so it's 71. Okay, now we are going to find the second one, 180 minus theta is equals to, the second one. This is the first one. The second one is 180 minus theta is equals to 109, 109.5. Okay, and as for the second negative, going from this side, it's actually like this, 180 theta minus 71. So 180 minus this 109.5. So it's minus 109.5. Okay, that's the answer. Since okay, let me just make you guys understand again about the positive and negative. So when going from anti-clockwise, it will be positive theta. When going from negative clockwise, it's going to be negative theta. And since we know that since this is minus 1 upon 3, which means the cos theta will be minus, so it can be in here and it can be in here as well. And also we need to put in mind about the range. We have been given the range as well. So less than 180 degree, which means it can be found in here. So we're going to do with 180 minus base angle is equal to theta, and it can also be found in here as well, but we cannot go from anti-clockwise since we have been given the range that it is less than 180 degree, positive 180 degree. Okay, so which means we're going to go to the other side of the road. We're going to go to this side in order to find this. Okay, this is minus 0.3, and in here it's also going to be minus 0.3. All right, and if we try to go there, we need to find this angle. Okay, we need to find this angle, and first since we already know the base angle is 71, and it's going to the opposite side, so 180 minus 71, but the angle is in negative since it's going to the other side of the road, and so which is why it's going to be minus 0.9.5. okay, in this side we can find the angle using 180 minus base angle. In here we can find 180 plus base angle. In here we can find using 360 minus base angle. But if we try to go to the other side, if we try to go clockwise, then in here it's going to be minus base angle. In here it's going to be 180 minus base angle. It's going to be negative. In here it's going to be 180 plus base angle, but it's going to be negative. And in here it's going to be 360 minus base angle, but it's going to be negative. This is what I want you guys to understand. Okay, so let's move on. So tan 2x is equals to 3. First of all, let me just make it right, the range. Yeah, since we have we have 2x and it's going to showing only 1x, so we can try to multiply both sides by 2. So it's going to be 180 degree 2x 180 degree. Okay, so 2x and then tan inverse 3, and the base angle is let me use a triangle. Let me use a calculator. So it's 71.6. So it's 71.6 as the base angle. 71.56 as the base angle, and so 71.6, and since tan is positive, so it's going to be in here, and it's going to be in here. 2x is equals to 71.56, and 2x is equals to 180 plus base angle, so 180 plus base angle, so it's actually 251.6. But wait, since we know that we need to check the range. Yeah, since when going from the anti-clockwise, the range is less than equal to positive 180 degree. Okay, less than equal to 1. Okay, and we cannot go more than that since this is the range, but we can go to the other side of the road, which is less the x must be greater than minus 180 degree. Okay, when going from this side, then so we can find the angle using 180 minus base angle and in negative. Okay, so this is how it is: 180 minus 71.56. So the x is 71.56 upon 2, so 35.78. Okay, and so 180 minus 71.56, so it's 108, and it's negative 108, and divided by 2, so it's going to be minus 54.22, minus 54.22. Okay, this is in the range, so this is the answer. Question 7: solve the equation 2 sine squared theta minus 1 is equal to 1 upon 4, and we have been given the range. Okay, so 1 upon 4 plus 1, yeah, so 1 upon 4 plus 1, so 5 upon 4, 5 upon 4, 5 upon 4, 2 is going down, so 5 upon 8, 4 to the 8, sine square theta. We remove the square sign, it's going to be positive under root 5 upon 8, okay, is equal to sine theta, and negative under root 5 upon 8. Okay, now since we have been given the range, which is the 0 degree must be, the theta must be less than the 0 degree. Okay, if we check the the sign is positive, so it's going to be in here and it's going to be in here, but since it is not in the range, so we're going to eliminate this one, since it is not in the range, not in range. But this one is, so negative sine theta, which means it is negative in here. Okay, and since we have been given the range, right, minus 90 degree. Okay, so which means we need to find the base angle, and that's it. So under root, okay, what is the base angle? You can just call this the base angle, and it is in negative, so under root sine. Always remember that whenever we try to find the base angle, we'll always try to find positive. Okay, which means it's written minus under root 5.8. We'll take it as positive 5.8 in order to find the base angle. Okay, so we have found the base angle, and the base angle is 552.24, but we're going to take this as minus 52.24, and this is the answer. Starting with question 8, show that the equation 3 tan theta is equals to 2 cos theta can be expressed as this. This is 0. But before we start, we need to know the identities first. So I'm going to write it down, the identities that we really need to use it, which is included in the syllabus. So there are only two identities that are included in the syllabus in A11 Math P1. But the rest of the identities are in A11 Math P3. So it's going to be difficult in A11 Math P3. But for now, you need to relax, chill out, and remember these identities. Number 1 is sine square theta plus cos square theta is equals to 1. And we got this identity because through this, since we know that in the unit circle, the radius, the hypotenuse is 1, and sine, this is sine theta, this is the cos theta, and that's how we use the Pythagoras theorem to find this identity. And the second one is tan theta is equals to sine theta upon cos theta, and you guys know this. Where did it come from? This is the theta, and this is acting as p, this is acting as b, so p upon b is tan theta. You guys know that. So these are the identities, and I want you guys to remember this beautifully. Now let's begin. So 3 tan theta is equals to 2 cos theta. Tan theta can be converted to 3 sine theta upon cos theta. Since we are using the number 2 identity, 2 cos theta. Cos theta will go up, so it's going to be square. 3 sine theta, 2 cos square theta. Okay, right now you guys need to see this, that these are sine theta. Okay, there is no cos theta, and this one is square. Okay, so cos theta can be converted into by using the number 1 identity, sine square plus cos square is equal to 1, which means cos square theta is equals to 1 minus sine square theta. Okay, you can apply this. So 3 sine theta is equals to 2 multiplied by 1 minus sine square theta, and 3 sine theta is equals to 2 minus 2 sine square theta. So 2 sine square theta plus 3 sine theta minus 2 is equals to 0, and yes, this has been proved, since this is what we need to find it out. So question 8 is done. Now let's move on to question 9. 3 tan square x minus sine square is equal to tan square multiplied by sine square. So let's start. We can break down, we can convert tan square into sine square x using the identity, obviously, and cos square x minus sine square x. Okay, we can take the LCM, and sine square x multiply by cos square x and cos square x. Okay, then we're going to take the common of sine square x, so sine square x is going to be right here, and minus cos square x on cos square x, and sine square x upon cos square x is tan square x. Okay, and 1 minus cos square x is equals to sine square, using the identity number 2, that sine square x plus cos square x is equals to 1. Okay, so it's going to be sine square x, and hence proof. This is the identity that we wanted to prove. Okay, question 10. Sketch and label on the same diagram the graph of y is equals to 2 sine x and y is equals to cos 2x for the interval this. Okay, this is in radian, and it literally means that it's 180. Okay, and hence say the number of solution of the equation 2 sine x is cos 2x in the interval of this. So let me just draw the graph, and since we have the straight line, and y is equals to 2 sine x, 2, which means the amplitude, let me just put this 1 and then 2. Okay, minus 1 minus 2, so 2 sine x, which means it's going to go like this. Okay, this is 180, right? Okay, so this is 0, this is 90, and then this is 180. Okay, now cos 2x, so the cos 2x will be, okay, so it's starting from here, cos 2x, which means okay, so cos 2x, which means 1 is going to be, okay, since we know that this is cos 2x, not cos 1x. If it had been cos 1x, then it could have been like this, in 360. But since it is cos 2x, which means it's going to be double this and then this to 360 degree, and here it's going to be 180. Okay, so hence the number of solution, there are 2 solutions intersecting. So the number of solution in the part 2 is 2. This is the answer. Cos 2x, the equation of a line is x plus 2y is equals to pi, which means pi 180. On the diagram, sketch the curve and the line for 0, x, and pi. Okay, let's draw the graph. Okay, this is 1, 2, 3, and this is minus 1, minus 2, and minus 3. Okay, and then it's saying 2x, which means this is 180 degree. Okay, and since it's saying 2x, so it's going to be like this. That's it. So it's starting from here, since this is the amplitude, and there you go, is pi, or 180, you can call that. Okay, now x plus 2y is equals to pi, or you can just write it down as, okay, so the equation is going to be like this: y is equals to minus x plus theta and then upon 2. Okay, so minus 1 upon 2, which means 0.5, and it's minus, so, and pi upon 2, pi upon 2 is 1.57, which means 1.57, which means it's right here, and since it's going negative, the line is negative, so it's like this. And wait, if I put 0, if I put the y value as 0, what will I get? So x plus pi on 2, it will go this side, and x will be pi, which means I will get pi, which means it will cross right here. So it's a straight line, and it's crossing like that. Okay, the line. Okay, so I've sketched it. This is the line, and this is the curve, and this is the answer. Okay. Question 12. Sketch on the same diagram the graph of y is equal to sine x and y is equal to cos 2x for 0 to 180. Verify that x is equal to 30 is the root of the equation, sine x is cos 2x, and say the other root of the equation for which x, which we have this range, and say the set of values of this for which sine x, blah 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 blah. Let's draw the graph. Sketch on the same diagram the graph of y is equal to sine x and y is equal to cos 2x on the range of 180 degree. Y to sine x. Okay. So it's going to be, okay, let me just, yes. So 1 and minus 1. Okay, so like that. There you go, 180 degree. And as for cos 2x, so it's going to be starting from here, and cos 2x. There you go. Verify that x is equal to 30 degrees, the root of the equation. Sine x is equals to cos 2x. If I want to verify, then I will put the root 30 in these x. Okay, so sine 30 is equals to cos 2 multiplied by 30, and I will get the same answer. Hopefully, let's use a calculator. Sine 30 is, once it has been confirmed, verified, we have been verified that x 30 is the root of the equation, and state the other root of the equation for which x is this and this. Okay, since we know that sine is positive, so I'm going to use the unit circle. Sine is positive in here and here, and since we know that sine 30, okay, so right here 0.5 and sine 30. Okay, but we can also get from here as well 0.5. So what will be the angle? So 180 minus the base angle, and the base angle is 30, so minus 150. So 180 minus 30 is equals to 150 degree. Okay, so this right here is 150, and this right here is 30. Okay. Hence state the set of values of x for which sin x is less than cos 2x. Okay, cos 2x is greater than sin x, which means it's greater than from here and it's greater than from here, which means x is greater than 150 and x is less than 30. These are the set of values of x, and this is it. Okay, so we have totally we have done all the questions. We have done at least 12 questions of trigonometry, and I hope that you guys have understood. So this is the end of trigonometry topic 7, and if geometry is done, topic 7 is done. Now we are moving to topic 8 and topic 9, differentiation and integration. We are going to cover these two topics at the same time in the same back, and in this video we are going to learn what is derivative, or you can call it what is differentiation, and what is integration. You can call it differentiation as finding the derivative of any equation, and you can call integration as finding the integral of an equation. Whenever we try to find the derivative, we always find the gradient, and whenever we try to find the integral, we always try to find the area under the curve, area under the equation. Okay, so let's get started. It is a way of finding the instantaneous rate of change. It just means finding the gradient in any point of the x-axis. Suppose we have this equation and we have these 2 points, and what is the gradient of this line? You can call it secant line. What is the gradient of this line? Gradient is y2 minus y1 upon x2 minus x1. So y2 is fx plus h minus, and y1 is fx upon x2 is x plus h minus, and x1 is x. Okay, right now you can see this the distance between these 2 points. You can see this triangle. So the change in between these 2 points of the x is h. So h is a change between these 2 points, and the change in y is fx plus h minus fx. Okay, so x is cancelled out, leaving only fx plus h minus fx upon h. Okay, and what happens if we put a limit that h comes closer to 0? If we put h closer to 0, then these 2 points will come closer to one another. Or you can say that this point will come closer to this point, and whenever it becomes so close, then we can say the difference is negligible, and so we can say that we can so in this way we can find the instantaneous rate of change. We can find the gradient of the tangent touching to that point of the curve. Okay, let's begin. Okay, finding the gradient. If h comes closer to 0, the formula for the instantaneous rate of change. If h approaches near to 0, then the 2 points will come closer and the distance between them is negligible. So we can find the tangent to the curve of any point. Now let's imagine we need to find the derivative of this equation. Okay, so y is equals to x square, which means fx is equals to x square. So if fx plus h, if we put fx plus h, then it will be x plus h square. Okay, so x plus x square minus x square upon h. Okay, now we need to expand the brackets. So x square plus 2xh plus h square minus x square upon h. X square cancel out. 2xh plus h. Now we're going to take the common. 2x plus h upon h. H is cancel out. Now we have what we have here is 2x plus h. Now if we put a limit that h comes closer to 0, then it's going to be 0, and so 2x is the derivative of y is equals to x square. Y is equals to x square, then the derivative is 2x. Okay, now if we put the value of any x-axis of any x value, we can find the gradient of the tangent at that point. Let's say I want to put the value of 1. So putting the value of 1, I will find the gradient of the tangent touching at that point. If I put in the value of this, then I will find the gradient of the tangent touching at that point. If I try to put the value of this, then I will find the gradient of the tangent touching at that point. Okay, so basically whenever we're putting any value of x, and we will find the gradient of the tangent at that point. Okay, find the derivative of this equation. Now we're going to differentiate it. We're going to cancel out, and then we're going to cancel out h, and then we push h closer to 0. We're going to put the limit, and so we have found the derivative. Now put any value of x, and you can find the gradient at that point. You can see this tangent at that point. Now we're going to start with the basic rule of differentiation. First, the number 1 is the power rule. Okay, then we have the chain rule. Chain rule, or you can call it differentiation of composite function. Then what we have here is the product rule, which we use. The product rule is for those when two functions are multiplied to one another. And the quotient rule. This is when the two functions are divisible to one another. Power rule the chain rule, the product rule, and the quotient rule. Let's start with the power rule. So this is the power rule, and it said that if fx is equals to x to the power n, then if you want to find the derivative, then what will happen is that n will come down, will be multiplied, and then n minus 1. N will be subtracted by 1. Okay, so n come down, be multiplied to x, and then n minus 1. This is the power rule. Okay, we can call it, we can say dy upon dx, or we can just make a symbol as in this way. This also mean the derivative. Okay, example 1, you can see this in front of you. We have made a differentiation that the power of 4 is multiplied and 4 minus 3, power 3 is multiplied and 3 minus 2, power of 2 is multiplied by 4, 4 2 is 8, and 2 minus 1, power of 1, x of power 1, so 6x 1. So 1 will be multiplied, 1 multiplied by 6, x, and 1 minus 1 is equals to 0, which means x0 is 1. So we have 6. Okay, 6. And 7 is a constant, and constant will vanish. You can see this, constant vanishes when differentiate. Example 2, 1 upon x square. What happens if we get this and we want to differentiate, we want to find the derivative of this equation? So what we're going to do, we're going to write like this, x minus 2, which obviously means that 1 upon x square. Okay, so we're going to write it like this, and after writing it like this, we're going to differentiate. So minus 2 will come down, get multiplied by x, and then minus 2 minus 1, which means the derivative is minus 2x and minus 3 is the derivative, dy upon dx, or you can call it f dash x. Okay, this is the derivative. Yeah. Example 3, here this is the under root square of x. So instead of writing like this, we could write it like this. 1 upon 2 is the power of the under root. Okay, 1 upon 2 is the under root, and then obviously the same thing, 1 upon 2 is multiplied by this, and 1 upon 2 minus 1, so it's going to be minus 1 upon 2. So 1 upon 2 x minus 1 upon 2 is the derivative, dy upon dx. Okay, so example 3 is done. This is the power rule. Now what is the chain rule? So chain rule is basically a composite, differentiating a composite function. So this is a composite function. Yeah, fx is equals to ax plus bn. Okay, and how to differentiate this? First we're going to use a power rule. The power rule is n will multiply by and with n will first be multiplied and then n minus 1, and then we're going to differentiate on the inside as well, and then we're going to differentiate and then put it outside. Yeah. So that after differentiating, we got a, b is a constant, b vanishes, x 1 minus 1 0, and a is left, so multiplied by a, and this is the derivative. This is how you differentiate the composite function. Okay, example 1. Okay, so we have example 1, y is equal to 4x plus 5, so 5 multiplied by 4x plus 5, 5 minus 1, and then we're going to differentiate it on the inside as well, so it's going to be 4, so 5 4s are 20. This is the derivative. Differentiate outside of the function, use the power rule. Now differentiate inside of the function and take it outside, but inside the function must be unchanged. Differentiate and take it outside, and you got the derivative. This is example 1. This is actually differentiating a composite function, dy upon dx, fgx. Okay, so these two are the same thing. Okay, fgx. So what we have done here, let's say that we want to differentiate this composite function. So we're going to differentiate f, which means we're going to use the power rule, and after that we're going to differentiate on the inside function as well, and it will come out multiply by this. Okay, so fgx equals to f, the outside function is differentiated, then we're going to differentiate on the inside function as well, and it will come out. Okay, these two are the same thing. Okay, this is the chain rule. Okay, after differentiating it, we have just differentiated it, and look closely. U is equals to gx and y is equals to fu. Y is equals to fu and u is equals to gx, which means u will come here, and then it's going to be like y is equals to f gx. Okay, fg dy upon dx. Since this is y, changing y is changing x. Okay, y is equals to f gx. dy upon dx means change in y upon change in x. So change in y upon change in x. When y changes, x also changes. Is equals to change in y upon changing u, which means change in y upon changing u, and then changing u upon changing x. So indirectly, it is change in y upon changing x. This is what a chain rule is. This is known as a chain rule for differentiating a composite function. We have this chain rule. So rate at which y changes with respect to x, rate at which y changes with respect to u, rate at which u changes with respect to x. Now in this expansion, when y is a function of u, where u is a function of x, then as x changes, u changes and y changes. As x changes, u changes, and as y changes. Okay, when y changes, u changes, and when u changes, x changes. So indirectly, when as y changes, then u changes. As y changes, x changes. Okay. Example 2, find derivative. So we have these two functions. The first one is y is equals to, you can just call it fz is equal to z5 and z3. And then the other one is z is equals to gx is equals to 2x3 minus 9. Okay, if we try to differentiate it, then it's 5z4 plus 3z2. If we try to differentiate the other one as well, there's going to be 3 to the 6, 6x square minus, 0. Now, we can use a chain rule if we want. So the chain rule is dy upon dx. And what is dy upon dx? Obviously putting... we need to find the dy upon dx. So dy upon dz. Dy upon dz. And it's this one. Okay? Multiply by dz upon dx. dz upon dx. Okay, so it's this one. The differentiated one. Okay, so dy upon dx is equals to 5z4 plus 3z2 multiplied by 6x squared. This is the answer. We have differentiated, we put the values, and then we got this answer. Now you can see this. After making a multiplication, we just simplify it, and then if you could just see in front of you that we're putting the value of c using this one. We're putting here and here, and we got this. We can do this the other way. We can make a composite function, use the values. We can do this the other way as well. We can just do it directly, putting, we know that this is z, so we can put the value of z in here and in here. Okay, since we got it, we have made the composite function. We can use the formula. To differentiate it. After differentiate, it would look something like this, and it looks the same thing. It's the same thing. The reason I am trying to show you guys is it doesn't matter if you use a chain rule, or if you use this equation, it's the same thing. It's the same thing. Example 3. The equation of the curve is y is equal to 6 upon 5 minus 2x. Calculate the gradient of the curve at the point where x is equals to 1. So first of all, we need to make a differentiate. We need to differentiate it. We can write it like this: 6, 5 minus 2x minus 1. Now we're going to differentiate on the outside function, so minus 6. And then we're going to differentiate on the inside as well, so multiply by minus 2. 6 to the 12, so 12, 5 minus 2x minus 2. This is the differentiation, this is the derivative. Now, calculate the gradient of the curve at the point where x is equals to 1. Now, if I put the value of x is equals to 1, what will I get? Putting the value of x, and I'm going to use a calculator now. 5 minus 2. So it's going to be 4 upon 3. 4 upon 3 is the gradient. Okay, then part 1 is done. Part 2 is a point with the coordinate xy, move along the curve in such a way. Okay, this is where we use the chain rule. Okay, so doing the part 1, I've just done the animation. It's coming. This is the one. Okay, now putting the x value on your 1, and we got 4 upon 3. Part 2 is a point with coordinate xy moves along the curve in such a way that the rate of increase of y has a constant value of 0.02 unit per second. Okay, it says y value has a constant value of 0.02 unit per second, which means change in y upon change in time. Okay, is equals to 0.02. It says the rate of increase of y has a constant value of 0.02 unit per second. Change in y upon change in t. Find the rate of x when x is equals to y. Now we need to find the change in x upon change in t. What is the change in y upon t? When x is equals to 1, which we already found that dy upon dx is 4 upon 3. So now we're going to use the chain rule. So dy upon dx is equals to dy upon dt multiplied by dt upon dx. This is the chain rule. Okay, so 4 upon 3 is equal to dy upon dt is 0.02 multiplied by dt upon dx. Now we make a reciprocal, so it's going to be dx upon dt 0.02 multiplied by 3 upon 4. Using a calculator, so it's 0.015 unit per second. So this is the value. This is the answer. Change in y with respect to time. As time goes, x also changes. Calculate the rate at which one quantity varies with another. This is the chain rule. Now putting the values, making a reciprocal, and finding the value 0.015 unit per second. This is the answer. Example 3 is done. Product rule. Now the thing is about product rule is you can apply it in A-level Maths P1. You can if you want to, but you don't need to. It's just it's a bonus, it's an extra, but it's going to be easy for you guys to understand how to do differentiation if you learn these two methods, the quadrant rule and the quotient rule, even though you can learn it in A-level Math P3 as well. But it's fun to learn something new, right? So let's learn it. We use the product rule when there's something complex when there's something complex, two functions being multiplied. So what will happen? Gx multiplied by derivative of x multiplied by derivative of fx, then plus, and then derivative of gx, and then normal fx. You can simply put this as u multiplied by v is equals to u multiplied by v dash plus u dash multiplied by v. You can just easily remember this way. Okay. Example. This is the example. Two functions being multiplied. So this is u, this is u dash, this is v dash. U first start with u comes to v, and then u dash comes to v. Okay, and this is the answer. This is the derivative. Now the quotient rule. Quotient rule is when two functions are being divided. So gx will be squared, and then gx, then derivative of fx, and then again gx derivative and normal fx. So it's the same thing as above. The only difference is the minus sign and gx squared. You can remember this as, so it's going to be v upon u. This is v, this is u. This equals to u multiplied by v slash minus u slash multiplied by v upon u squared. Okay. So we have this example. This is u dash, this is v dash. It starts from here, u to v, and then it starts from here, u dash to v dash. That's how it is. Okay, this is the answer. So these are the 4 basic rules of differentiation. Now what is increasing function and decreasing function? Suppose we have this curve. Increasing function is increasing gradient. When increasing function means a positive gradient, and decreasing function means a negative gradient. If the line is going like this, it is positive. If the line is going like this, it is negative. Okay. If the line is like this, then the gradient is 0. But if the line is going like this, the gradient is positive. Or you can say 1 to positive 1. If it's going steeper, then positive 2. If it is going more steeper, then m is equal to positive 3, and so on. If the line is going like this, then it's going to be m is equal to negative 1. If it is going like this, then it is negative 2 or negative 3, negative 4. You can see in front of it, this is a positive gradient since the line is going like this. This is a negative gradient, line is going like this. This is a positive gradient, line is going like this. Positive gradient, this is increasing function. Negative gradient, this is decreasing function. Positive gradient, this is increasing function. The stationary point is where the gradient is 0. If you take the tangent at that point, then the gradient will be 0. If you take the tangent will be like this, and it will be like this. Okay. And you can find the stationary point by differentiation. If t, okay, you put 0, the gradient is 0, then 2x plus 3 minus 3 upon 2x. So this is the x coordinate of the stationary point. The stationary point means the coordinates of the vertex, which you have learned in chapter functions. So it's the same thing. Either you can find the coordinates of the vertex or the coordinates of the stationary point through completing the square, or you can find it by differentiation. You can do any one of them. This is the stationary point. We can find the coordinate of the stationary point through differentiation by putting dy upon dx is equal to 0. The nature of the stationary point, either maximum or minimum. The stationary point can be maximum. In here, minimum. This is minimum. Okay, smiling curve, or the maximum curve. This is a side curve. Okay. And you can find the nature of the stationary point by knowing that in the minimum curve, in the smiling curve, on the left side is negative gradient, and on the right side is positive gradient. But in the sad curve, in the maximum curve, the left side is positive gradient and the right side is negative gradient. Okay, so let's suppose that I found the x coordinate of h. Okay, hk is the coordinates. So let's say if I have found the x coordinates of the stationary points, and I wanted to know whether it's a maximum curve or a minimum curve. So there are two ways. Either I will use differentiation. I will try to make an experiment. I will take the x greater than h, on this side, and then after taking the value of x, I will try to put on the equation, to find whether it is a positive gradient or negative gradient. If it is a positive gradient, then it's a minimum curve. If it is a negative gradient, then it's a sad curve. You can use this range, or you can use the range less than h. on left side as well, in order to find out whether on the left side it's a negative gradient or it's a positive gradient. In that manner, you can easily find the whether it's a maximum curve or a minimum curve. Okay, you can do in this way, or you can use the second derivative. You can use that second derivative. Okay, we will understand this right now. Okay, this is a smiling curve minimum, this is a sad curve maximum. The second derivative, we can find the nature of the stationary point by two ways. The first one, like I have told you just right now, after finding the coordinates of h of the stationary point, use the range h greater than h and x less than h and x less than h and x greater than h, and putting on the differential equation to find the gradient and to see whether if it is positive or negative on the either side, using the range to find out whether on either side where it is positive gradient or negative gradient, and this way we can find whether it is a maximum or minimum. Second one is the second derivative. Number 2 is second derivative. And what is the second derivative? You differentiate it and then you again differentiate it, and this is the second derivative. Okay, you put the value upon dx is equal to 0 in order to find the x coordinate of the stationary points, and then you can just use that stationary point on dy on the second derivative. If the second derivative is positive, if it is greater than 0, then it's a smiling curve, which means it's a minimum curve. It's a smiling curve because it is positive. The guy is smiling because he's full of positivity. You can remember it in this way. If it is less than 0, if d2y upon dx square is less than 0, then you can say it's a sad curve, which means maximum curve. The guy is crying because it is full of negativity, depression, anxiety, full of hatred. Okay, he's thinking negative thoughts. That's why, because the dy upon dx square is less than 0, it's in negative, it's in positive. This is how you can remember it. Okay, the smiling curve because it's positive, the sad curve because it's negative, and voila, this is differentiation. Now moving on to integration. What is integration? Integration, is the inverse of differentiation. It's a mirror of differentiation. Just like water versus fire, differentiation is integration. Speed versus friction, whatever. So differentiation is the inverse of integration. Just like y is equals to x square, you can just differentiate it. 2x. Now I want to go back. Now to go back, I will use integration. Now we're going to learn what is integration, how to use it, and also there are two applications, I guess, of differentiation. The first application is you can easily after finding the derivative of the equation, you can use integration to go back that what was the equation from which you have taken the derivative. This is the first application, and the second application is that you can find the area under the curve between any 2 points. This is integration. Integration is the reverse of differentiation. Fx is equals to x square plus 3. Okay, just like differentiation has some basic rule of some 4 basic rule, it's the same thing as integration has some basic rule. The first basic rule is the power rule, and the power rule is actually the inverse of the basic rule of power rule of differentiation. Okay, so the power rule is that whenever you try to integrate it, this sign, you can call this sign integral. Okay, whenever you try to take a integration of anything, first of all you're going to plus. Okay, you're going to reverse. So n plus 1, and then comes n plus 1, n plus c is the constant. Whenever we try to integrate something, we always without having any limits, we always get the constant. Okay, so now right now in front of you, we will use the power rule. Okay, n plus 1 upon n plus 1 plus c. The one thing to remember about the power when using the power rule in integration is that the value of n must not be equal to -1. Why? Because if you try to integrate something which has a power of -1, then x minus 1 plus 1, okay, minus 1 plus 1, going further, x of power 0 is 1, and 1 upon 0 leads to infinity. We want to avoid that. That's why, whatever the case, n must not have the value of -1. Okay, 2x 1 plus 1 upon 1 plus 1. Now we have found the constant. And in order to find the constant, whenever we integrate, we get the constant. In order to find the constant, we need to be given the coordinates of any one point. So let's say the graph y is equal to fx pass through the point 1, 4. Find the equation. Okay, so we have been given the points. So we're going to use that point. So y is equals to x square plus c. Using the points 4 and 1, leave 3. And voila, we have found the equation. X square plus 3. We have found the equation. This is the first application of integration, and this is what we call indefinite integral. we call this indefinite integral. Try to integrate it and we get the power of it, and we get a constant. This is whenever we try to integrate something and we get a constant, we can call this indefinite integral. Okay, this is the equation. The indefinite integral, since it always gives a constant after integration. Now moving further, used to find the area under the curve. What is the area under this curve? We have been given the limit between a and b about the x-axis, and we need to find the area under the curve in those limits. We can use a number of rectangles to find the approximate area under the curve. Okay, so what is the area under this curve? This is the curve. Okay, this is the curve, and I want to know what is the area under this curve. What is the area? So we have been given the limit between a and b about the x-axis, and we need to find the area under the curve in those limits. We have been given the limit. This is the limit b, and this is the limit a. A and b. We can write this as b and a. This is the limit, and this is what we call definite integral. And whenever we try to find the area under the curve and we have been given these limits, then always remember that in definite integral the c will cancel out. C, the constant, cancel out. This is the beauty of definite integral. Okay. Okay, so how to know the area under the curve? We always use rectangles. We always use rectangles. We try to use rectangles in order to find the area under the curve. Right here you can see that these rectangles are not enough to find the approximate area. How many rectangles? 1, 2, 3. Let's say we have 14 rectangles. But it is not enough to find the approximate area under the curve. So what we're going to do, we're going to use the infinite number of rectangles. We're going to use as much as a rectangle as possible to fill this whole thing. And in this way, we can find the best approximate area under the curve. Like this way, but it's not enough. Since it is not enough because we have these gaps which are not filled. So we need to use more number of rectangles. Okay. This is fx because this is the y-axis. This is the x-axis, and y-axis means fx, and y-axis means fx. So fx, 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 fx. Okay, fx depend on the value of x, and dx is let's say that I have this. Let's say I want to know the dx between these two. Yeah. So this is 2 and this is 1.5. So the dx means different. The difference in x values. So the dx is 2 minus 1.5. Dx is 2 minus 1.5. So this is xg, and this is xg minus 1, which means this is x2 and this is x1. Okay, and after finding fx and dx, we can multiply it to find the area of this rectangle. Okay, but we need to do this every single time for each rectangle under the curve. So fx multiplied by dx, and we're going to put the limit, all that. Let's see. Right now you can see this sum. What does it represent? It represents that, let's say that we have the symbol and it starts with number 1. And it ends with 3. So it basically means that is equals to, it's actually known as the sum of 3 rectangles. So let's start with the first. Let's say it's 1 multiplied by x1 minus x0, which is obviously this is dx. Okay, then plus f2 multiplied by x2 minus x1 plus f3 multiplied by x3 minus x2. Okay, and then we try to sum it all up to find the area, the total area of 3 rectangles. Okay, so what this really represents is the sum of all the infinite number of rectangles under the curve. So n is the total number of rectangles formed under the curve in a given limit. The total number of rectangles and the sum of the area of n number of rectangles is Sn. Okay, so what happens if we put a limit that n come closer to infinite number of rectangles? It comes closer to infinity. It's not actually infinity, but infinite number of rectangles means this rectangle, right, number of rectangles. It fills the whole rectangle, and then we try to use a formula that it start with 1 and it come closer to infinity. N is closer to infinity, and then we try to find the area of each one of rectangles, each one of infinite number of rectangles. We try to find the area, and then we try to sum it all up. This is integration. Okay, and we can write this. It's written like this, right? So it's written like this: j is equals to 1 fx multiplied by dx. We can write it like this. Okay, another thing to understand that we are putting infinite number of rectangles between any 2 points. Okay, so we have been given between any 2 limits. This is b, this is the limit b right here, and this is the limit a right here, and now we are putting infinite number of rectangles between these 2 points, okay. So b upon a, and which this literally means this one, okay. This literally means that we are putting infinite number of rectangles between any 2 limits, okay. And then we are multiplying fx multiplied by dx, and then we are finding the total area, the sum of the area of n number of rectangles. This is what integration really means, and this is known as the area under the curve between any 2 points. The smaller value of dx closer to 0 means larger number of rectangles and better the approximation of the area under the curve. So we have this equation. It's telling us that having the limit between a and b, what is the value of dx if we put n closer to infinity. If we put the infinite number of rectangles between these 2 points, then what will be the value of dx? What will be the width of these tiny small rectangles? What will be the width of these tiny small rectangles? So we can use this formula dx. Okay. Putting to infinity. If n is closer to infinity, then there will be infinitely large number of rectangles to give the best approximate area under the curve between the given limit a and b. Putting the limit, and then it all changes, and this is the definite integral, finding the area between any 2 points. Now it depends which way. Say that if we try to finding the integral between these 2 points, then as you can see that the curve is upward. So we will try to making the infinite number of rectangles, and then we find the area. So the area must be positive. It will be positive. But if the curve is below the x-axis, and we try to we put the limit between these two, 3 and 1.185, and we try to make infinite number of rectangles, and we find the area, but the area will be negative. This is a sign that the curve is below the x-axis, and positive area means that the curve is above the x-axis. Area between 2 graphs. So we have been given 2 graphs, and we need to find the area between these 2 graphs. So what we're going to do, first of all, we're going to take the area of y is equals to fx. So it's going to be like this. So b in between these 2 limit. So fx multiplied by dx, and then we try to integrate it. We put the limits, and we find the area. Okay, minus again fba gx multiplied by dx, and then we can find the area, the area between these 2 graphs. Okay. This is how you find the area between 2 graphs. Basic rule of integration. First of all, what is the power rule? I've already discussed with it. This is how you find the power rule. And n must not be equal to -1. Now multiplication by constant. Okay, this is another stuff. Whenever you get the constant, let's say 2x square, you can put this 2 outside if you want, just for the sake of simplicity. This is what multiplication by constant means. This is the rule. Now addition and subtraction will be coming to that. Addition and subtraction between 2 functions. Then integration of the composite function. Whenever we try to integrate the composite function, just like we differentiate the differentiation, so it's going to be reverse in integration. Okay. So what happens if we try to integrate the composite function? Let's say that we have this ax plus bn dx. So it's going to be ax plus b n plus 1, then upon n plus 1. Okay. And then we're going to differentiate this. Instead of integrate, we're going to differentiate it as well, but the differentiate part will be down. It will be divisible. Okay. So multiply this by, so the differentiator is a. This is how you integrate the composite function. Measure of fx will come down. Let's say if you want to integrate the composite function without having any derivative of fx, then it will be in this way. And let's say if we want to integrate the composite function, and we also have been given the multiplication of derivative of fx, then it will be in this way. Just think of it as that fx multiplied by fx power n dx is equals to and these two are cancel out, leaving only this. You can remember this in this way. Okay. Both four basic rule of integration. Now what is the volume of revolution? Volume of revolution, rotating the region about the x-axis or y-axis through 360 degree. Okay, the volume of revolution is, let's say that I have this graph. Okay, this is a curve and I just put the limit b a, now just finding the area under the curve. Now what happens if I try to rotate this thing about the x-axis, which means rotating through the x-axis, about the x-axis, rotating this shaded region, this area about the x-axis, rotate the area about the x-axis through 360 degree. Okay, and then you will get the volume. This is the volume of revolution. Or you can just you can also rotate this to y-axis as well. Let's say that I have this this curve, and I just found, and I want to know whether that what will be the volume of revolution if I try to rotate this shaded region about the y-axis. And I've been given the limit, obviously, but the limit must be in parallel to the y-axis, since we are we are rotating about the y-axis. So it's going to be like this. Okay, rotated about the y-axis 360 degree. Whenever we rotate about the x-axis, the limits must be parallel to the x-axis, and whenever we try to rotate about the y-axis, then the limit must be parallel to the y-axis. Running a 2D plane across a 3D volume, that's volume of revolution. Let's say we have this curve and we have the limits. Now rotate the region to 360 degree, and voila, this is how it is. This is known as volume of revolution. There are infinite number of area of circles to make a complete volume, just like in in 2D rectangles, but in here 3D volume. Okay, so this is the area. The area of this is the circle. The area of the circle is pi r square, and here is fx. Okay, and you know that the radius is r. The radius is r. So instead of r square, you can put it fx square. So these circles, infinite number of circles, and moving along these circles, we got dx. Just like in we got dx, and we got pi fx square, and then if we try to multiply dx, we get the volume. This is dx, and this is how you get the volume. Let's say if we rotate this thing about the y-axis, now let's find the volume when the shaded region is rotated through the 360 degree about the y-axis. We put the limit instead of y. Yes, and another thing to understand that whenever you try to rotate the region about the y-axis, first of all, instead of we're going to make x the subject in here. Whenever we try to take the volume by rotating the shaded region about the y-axis, we always try to make x the subject, making x the subject. Okay, and whenever we try to rotate the region about the x-axis, we make the y the subject. We know that we are familiar with this one, but now we need to get familiar with this one, x the subject. How to make x the subject? Let's say that we have this equation, y is equals to x plus 1, so y is equals to minus 1 is equals to x. We make x the subject. This is how you find the volume when you try to rotate the region about the y-axis. So it is x square. Whenever we try to rotate the region about the x-axis, then it's like this. It's y square, or you can call it fx square. But whenever we try to rotate the region about the y-axis, then it's going to be x square. Dx, this is dy, because we are because infinite number of circles going in this way, so it's dy. If we are rotating about the x-axis, then we have this region, and so infinite number of circles on the x-axis, so dx. Okay, and the limit must be given from a to b, starting from here a to b, and the limit must be given from the x-axis whenever we try to rotate about the x-axis a to b. Okay, this is how it is. Okay, so we have these two equations, the curve and the line. So what we're going to do, first of all, we're going to rotate each one of them through 360 degree about the y-axis, and after finding the volume, we are going to make subtraction in order to find the volume between these two, to find the volume of the shaded region rotated about the y-axis. Okay, now we're going to subtract it, and this is the volume of revolution. Integration is okay. Subtract 1 upon 5 pi, and voila. First we just try to rotate the line y about 360 degree about the y-axis. We find the volume, finding the volume, and then we also rotated the curve about the y-axis. We find the volume. Now we subtract this volume to find the shaded region rotated about the y-axis. So this is the volume of revolution, and this is the end of the chapter integration and differentiation. Now we are going to do the exam question of integration and differentiation. So let's begin. Okay, so let's start with the differentiation exam questions. Question 1. A curve has an equation. This is the equation. K is a constant. Write down the expansion for dy upon dx. Okay.
So we need to write the expression. So y is equals to x cube 3x square minus 9x plus k. Now we need to differentiate it. So it's going to be 3x square plus e to the 6x minus 9. This is dy upon dx. Okay, this is part 1. Now part 2, find the x coordinates of the two stationary points on the curve. Now it says stationary point, which means when finding the stationary point, then m is equals to 0. The gradient is 0, So putting dy upon dx is equals to 0. 3x square plus 6x minus 9. Now I'm going to use a calculator because this is quadratic to find the value of x. 3, 6, minus 9, 1, and minus 3. Okay, so x is equals to 1 and x is equals to minus 3. We have find the x coordinates. Okay, part is done. Hence find the two values of k for which curve has a stationary point on the x-axis. Okay, it certainly means that, let's say that I'm just drawing the graph. Since this is power of q, which means it's going to be like the stationary point on the x-axis, so x-axis. So this is minus 3, this is minus 1, and it must be minus 3 and 1. And find the two value of k for which the curve has a stationary point on the x-axis, which means the y. Which means the value of that y will be 0. Okay, and now we're going to put these in equation 1. So part 3, 0, 1 plus 3, 1 square minus 9, 1 plus k, and it's going to be 5 since 1 plus 3 minus 9. Wait. So 0 is equals to minus 5 plus k. So it's going to be 5. Okay. When you put the value of 1. Now what happens if we put minus 3 plus 3 plus 3. Okay. Minus 9 minus 3 plus k. And we will get, this is a 27. So this is 27. This is a 9 and this is a 27. So 27 cancelled out. Plus 27 plus k. So it's 27 is equals to k. Okay, part 3 is done. So question 1 is done. Question 2. A curve is such that dy upon dx is equal to 3x squared minus 4x plus 1. The curve passes through the point 1, 5. Find the equation of the curve. Okay, so we need to find the equation of the curve. Okay. Clearly integration. So I'm going to integrate it. So 1, integrate 2 plus 1. So 3x squared minus 4x plus 1. So 3x 2 plus 1 upon 2 plus 1 minus 4x. 1 plus 1 upon 1 plus 1 plus 1x plus c will be there, and so 3 upon 3 cube minus 4 upon 2 square plus 1x plus c. 3 cancel out, 1 is 2, 2 is 4, x cube minus 2x square plus x plus c is equals to y. We have been given the points 1, 5, so we're going to put in here 1 is the 5 is equals to 1 minus 2 plus 1 plus c. Now we're going to find the value of c. 5 is the value of c. So we have found the equation. The equation is x cube minus 2x square plus x plus 5 is the equation. Okay, find the set of value of x for which the gradient of the curve is positive, or for which the function is increasing function. Find the set of values of x. Okay, so what we're going to do is we are going to put dy upon dx is equal to 0 because it says for which the gradient of the curve is positive, which means the curve would look something like this. Okay, these are the stationary points. Now we need to find the stationary point first. Find the set of value of x. So 0 is equals to 3x square minus 4x plus 1. So I'm going to use a calculator now. X is equals to 1 and x is equals to 1 upon 3. If we put the value of 1 in the equation, then what will we get? If we put the value of 1 in the equation, that we will get 5, y is equal to 5, and if we put the value of 1 upon 3 in the equation, we will get, and x is equals to 1 upon 3, so y is equals to 5.148. So we have been given the coordinates. So 1 upon 3 is 0.33. So this is 1 upon 3 and this is 5.148. The coordinates of the stationary points. This is 1 and this is 5. The coordinates of the stationary points. Okay. So find the set of value of x for which the gradient of the curve is positive. In here it is positive and in here it is positive. So x less than 1 upon 3 and x greater than 1. These are the set of values. This is the answer.
a solid rectangular block has a base which measures 2x centimeter by x centimeter. The height of the block is y centimeter, and the volume of the block is 72 centimeter cube. Part 1 is express y in terms of x and show that the total surface area a centimeter square of the block is given by a is equals to 4x square plus 216 upon x. So we need to prove that this is the equation. So let's start with part 1. Part 1 is, okay, so it's a rectangular block. This is the rectangular block, 2x by x and y. Finding the total surface area is 2 times 2x and x, okay, plus 2 times y multiplied by x plus 2 times 2x multiplied by y. Okay, so let's make it simplified. A is equals to 4x square plus 2yx plus 2xy, so 2yx plus 4yx, so 6yx. Also, we need to take the volume of the block into account. The volume of the block is 2x multiplied by x multiplied by y is equals to 72. And if we take y as a subject, then it's actually like this: 72 upon 2 x square. 1 the 2 the 72, so 36. So y is equals to 36 upon x square. We put the value in here, and we get plus 6 multiplied by 36 upon x square multiplied by x. X and cancel out, and we got the equation, which is 216 upon x. So it has been confirmed. Part 2 is find the value of x for which the a has a stationary value, which means we need to differentiate this and put the gradient 0. So let's differentiate it: dy upon dx. Let's write it like this: plus 21x minus 1. And if we differentiate it, then it's going to be look like this: 8x minus 216 x of power minus 2. This differentiation. Now if we put the value of 0 is equals to 8x minus 216 x minus 2. 216 x minus 2 is equals to 8x. 216 upon x square is equals to 8x. Now 216 upon 8 is equals to 8 cube. So 27 is equals to 8 cube, and x is equals to 3. Okay, part 2 is done. And then find the stationary value and determine whether it is a maximum or a minimum. We can use the second derivative. Since dy upon dx is 8x minus 216 x power minus 2, we can differentiate even further. It's going to be look like this: is equals to 8 minus 216 multiplied by minus 2 x of power minus 3. So it's going to be minus 2 multiplied by minus 216, so it's going to be plus 432. This dy square upon dx square. Now if we put the value of x, in here, the value of x is the x coordinate of the stationary point. If you put it right here, and then let me see, then we're going to see what it comes. So 8 plus 432 multiplied by 3 of power minus 3, so it's going to be 24. And since it is greater than 0, which means it's going to be positive, happy smile, minimum curve. Okay, this is part 3. We can use the second derivative, or we can just use the range where h either less than x or x greater than h. We can use either of the range. Let's say I want to know what is the gradient if x is equals to 2. So I'm going to use this equation: 8x minus 216 upon x square. If I put the value of 2, what will I get? Then I will get minus 38, which means the gradient is minus 38, which means, let's say that we have, so if x is equals to 3, this point, and if x is equals to 2, then the gradient will be negative. So it's going to be like this. Since this is gradient, if x is equal to 2, and it's going to be like this, positive gradient. So which means it is a minimum curve. So you can use this one or you can use this one. It's the same thing. Question 3 is done. Question 4, a function is defined by fx equal to x cube minus 2x plus minus 8x plus 5x less than 8. It is given that f is an increasing function. Find the largest possible value of the constant a. So what we really need to do is we are going to differentiate it. So dy upon dx is, so this is differentiation. It is given that f is an increasing function. Find the largest possible value of the constant a. Now we are going to put 0 in order to find the stationary point. Okay, we have these 2 points. We have found the point of this, stationary points, which means now it says it is given that f is an increasing function. Find the largest possible value of the constant a. Now what is the value of y when x is equals to 2? So I'm going to use a calculator now. So power 3 minus power 2 minus 8 of power 2 and plus 5. So it's minus 7. When x is equals to 2, y is equals to minus 7. And what happens if x is equals to minus 4 upon 3? Again, using a calculator. Minus 4 upon 3. Minus 4 upon 3. So it's 11.52. It's 11.52. Which means, okay, so minus 4 upon 3 is actually minus 1.33. Minus 1.33. So literally means that minus and 11.52, it's right here. Minus 1.33. 11.52. Okay, and minus 7. So it's like this. Okay, now it is given that f is an increasing function. Find the largest possible value of the constant a. This is the increasing function, and here it's the increasing function. So x must be less than a, which means x must be less than 1.33. So this is the answer. The function f is such that fx equals to 2x minus 1, this minus 6, and we have this, where k is a constant. Find the largest value of k for which f is a decreasing function. So the function f is such that fx equals to 2x minus 1 minus 6x, k is a constant. Find the largest value of k for which f is a decreasing function. Okay, which means what we're going to do, we're going to find the stationary point, and then we'll see which was the value of k, and decreasing function and all that. So dy upon dx, 3 upon 2, and then differentiate on the inside, so multiply by 2, 2x minus 1, 3 upon 2 minus 1 is 1 upon 2, and minus 6. Okay, put 0, and then 3 upon, okay, 3 multiplied by 2x minus 1, 1 upon 2 minus 6, put 6, put 3, 2x minus 1, 1 upon 2, 3 1 is 3, 3 2 is 6, and 2 2 is 4, 2x minus 1, 5 upon 2. It's a stationary point. And what is the value of y? Let's see that. Okay, which means, so also I need to find out whether it's an increasing function or a decreasing function. I need to find the nature of the stationary point. Let me use the second derivative, where it's going to be 1 upon 2 multiplied by 3 multiplied by 2, 2x minus 1, and minus 1 upon 2. So it's going to be again 3. Now I'm going to put 5 upon 2 in the equation in order to see what is the nature of the stationary point. So in the stationary, which means it is a smiling curve, it is minimum. Okay, so 5 upon 2 and minus 7. Okay, the decreasing function, this is a decreasing function, which means x must be less than 5 upon 2. So this is the answer. The value of k is 5 upon 2. This is the answer. 6. The length x meters of a green Anukata snake which is 10 years old is given approximately by the formula this, where this is this, and find dx upon dt. Okay, so this is x, this is t, and if you differentiate, there's going to be dx, change in x, upon dt, change in t. Okay, so we have x is equals to 0.7 to t minus 1, 1 upon 2. Now differentiate it, dx, change in x upon changing t. Okay, so 1 upon 2 multiply by 0.7 multiply by 2, because we need to differentiate on the inside as well, multiply by 2t minus 1, and so minus 1 upon 2. Okay, now simplify this. 1 upon 2, 1 upon 2 to cancel, 0.7 is left. Dx upon dt is 0.72t minus 1 upon 2. So this is dx upon dt. Now find the rate of growth of a green snake which is 5 years old, which means if we put the value of 5, so we're going to put the value of 5 in here in order to find out what is the rate of growth. Okay, so dx upon dt is equals to 0.72 multiplied by 5 minus 1 minus 1 upon 2. Now I'm going to use a calculator and I'm going to find the rate of change. Is the answer 0.23. This is the end of exam question of differentiation. Now we are going to move to integration. Hey, integration exam question. Question 8. The diagram shows a point A, point B on the curve this. The line BC is normal to the curve at B. The line BC, this is BC, is normal to the curve at B, and C lies on the x-axis. Line AD and B are perpendicular to the x-axis. Find the equation of the normal BC. Okay, so what we really need to do is, first of all, we're going to write this to x 1 upon 2. Okay, writing this. And now what we're going to do, we're going to differentiate it. So 2 multiplied by 1 upon 2, x minus 1 upon 2. 2 cancel out, leaving only x minus 1 upon 2. Okay, dy upon dx. Okay, now what we're going to do, we're going to put the value 4 in order to find the gradient. Okay, finding the gradient. So 4 is the power of minus 1 upon 2. So it's going to be 1 upon 2 dy upon x. So dy upon dx is equals to 1 upon 2. This is the gradient. Now we're going to find the perpendicular gradient. Okay, we're going to find the normal, we're going to find the gradient of the normal to the curve at point B. So 1 upon 2 multiplied by m minus 1. So m is equals to minus 2. Okay. X plus c. Now we're going to put the coordinates 4, 4. So 4 equals to c. So the equation is minus 2x plus 12 is the equation of BC. This is the equation of BC. So what we really did that first of all we find that we just found the tangent. Okay, and the tangent, then the gradient of the tangent was 1 upon 2. Now we need to find the normal. So in order to find the normal, this is the tangent, and the normal to the tangent is this. This is the normal. It is 90 degree. So we have learned in coordinate geometry that m multiplied by m is equals to minus 1. So since we have found the gradient of the tangent, and now we need to find the normal, we need to find the perpendicular line of this tangent, the normal BC. So we're going to use the formula. After finding that the perpendicular line or the normal BC, the gradient of the normal BC is minus 2, then we decide to put the coordinates as well, since it's also in the line BC, normal BC, and so we have found the equation of the line of normal BC. Find the equation of the normal BC. Done. Part 2. Find the area of the shaded region. Okay. So now we need to find the area of the shaded region. First of all, we're going to see the limit. The limit is 4 and 1. Okay, so it's 4 and it's 1. And then we're going to see the equation, this dx. Okay. And so find the coordinates of the shaded region. Now we're going to integrate it. So in order to integrate, 1 upon 2 plus 1 is 3 upon 2, and 3 upon 2 must be divisible. So okay, we have integrated 4, 1, and now we're going to put the limit. Let's put the limit 4 minus, put the limit 1. Now using a calculator to find the area of the shaded region. First one was 32 upon 3 minus, and so the area is the area of the shaded region. Okay, so question 8 is done. 9. The diagram shows the point A and B. Okay, on the curve this, the tangent to the curve at B crosses the x-axis at C. The point D has coordinates 2, 0. Find the equation of the tangent to the curve at B. Find the equation of the tangent to the curve at B, and hence show that the area of the triangle BDC is 4 upon 3. Okay. Okay, so what we have here is y is equals to 8, 3x plus 2 minus 1. Now dy upon dx, so 8 multiplied by minus 1 and multiplied by 3 because we need to differentiate on the inside as well. So 3x plus 2 and minus 2. Okay. Then 8 multiplied by, okay, so it's minus 24. 3x plus 2 minus 2. Okay. Now we need to find the equation of the tangent to the curve at B. And the coordinate of B is 2. So I'm going to put x is equals to 2 to find the gradient of the tangent at B. And so it's going to be, minus, okay, I'm going to use a calculator now. So 3 multiplied by 2 plus 2. Okay. And then, so it's minus 3 upon 8. This is the gradient. Now we need to find the equation. So y is equals to minus 3 upon 8x plus c. Now we need to put the coordinates. We need to use the coordinate. The coordinates of b is equals to 2 and 1. So we put the coordinates. 1 is equals to 3 upon 8 multiplied by 2 plus c, and the value of c is 4. The value of c is 7 upon 4, which means the equation is minus 3 upon 8x plus 7 upon 4. This is the equation. And now it says, hence show that the area of the triangle BDC. Okay, BDC. So this is BDC. The area of the triangle BDC is 4 upon 3. Okay, so what is the coordinates at C? Okay, if I put the coordinates of C is x and 0. If I put the value of y to 0, what will I get in of x? So minus 3 8x plus 7 upon 4. Then what will I get? Minus 7 upon 4 minus 3 upon 8. Cancel. Then 7 multiplied by 8 and 4 multiplied by 3 is equals to x. And what will I get? Okay. And 14 upon 3 is 4.66, 4.67. So this is 14
upon 3 and 0. Okay, now I'm going to use the area of the triangle. We're going to use the formula 1 upon 2 multiplied by, what is the height? The height is 1. The height is 1. What is the base? The base is 14 upon 3 minus 2. Now we're going to find the area. Is the answer. And so it has been proved in part 1. Now going for part 2. The part 2, okay, question, part 2, show that the volume of the solid form in the shaded region ODPA is rotated completely about the x-axis. It is 8 pi. So let's do that. Okay, so what we have here. So we have the limit 2 and 0 pi fx square and dx. This is how you get the volume. Okay, so pi and then 8 3x plus 2 minus 1 square dx. Okay, then putting the constant outside, 8 to 64 to 0, and then 3x plus 2 is minus 2 dx. Okay, yes. So now we're going to expand the brackets, or now we are going to integrate it. We are going to integrate. Since right now you can see that this is the composite function. So pi 64. Okay, so it's going to be minus 1, and then we're going to differentiate this, so it's going to be multiplied by 3x plus 2 minus 1. We have differentiated. Now putting the limits. Let's start with 2. What is the limit? I'm using a calculator. It's minus 1 upon 24. And the second one is minus 1 upon 6. Okay, now what we're going to do is 1 upon 6 minus 1 upon 24. So it's 1 upon 8. So pi 64 multiplied by 1 upon 8. 8 ones are 8, 8 is 64. So 8 pi is the answer. Alright, which means it has been done. And question 9 is done. Question 10, the diagram shows part of the curve y is equal to 1 upon 3x plus 1 of power 1 upon 4. The curve cuts the y-axis at A and the line x is equal to 5 at B. Show that the equation of the line AB is this. We need to prove it, okay? So what is the coordinates of A and B? The coordinates of A is x is 0 and y. We need to find the coordinates of y. And the coordinates of B is 5 and y. Okay, so we need to find the coordinates of both. We need to find the coordinates of y of both A and B. We can write this equation like this: 3x plus 1 upon 4 minus 1 upon 4. Okay, now if I put the value of x to 0, what will I get? If I put 0, and if I use a calculator, what will I get for the value of y for A? So I'm using a calculator, and what will I get? Get 1. I will get 1 for A, which means this is 0 and 1. Okay, and what will happen if I put 5? 3, 5 plus 1 minus 1 upon 4. So the value of y is 15 plus 1 power plus 1 upon 4. So I will get 1 upon 2. So 5 and 0.5. So coordinates of both of these. Now I can easily find the equation of the line AB. Since I got these two coordinates, so I'm going to take a gradient. And what is the gradient? Let me see. y2 minus y1, x2 minus x1. So 0.5 upon minus 5. And what will I get? I will get minus 0.1. Okay, this is the gradient. Or you can say minus 1 upon 10. Okay, so y is equal to minus 1 upon 10 x plus c. Now you find the value of c. I can choose any one of the coordinates. Let's say I choose a. So 0 and 1. So 1 and minus 1 upon 10, 0 plus c. So c is 1. So I have proved that this is the equation. Okay, part 1 is done. Find the volume obtained when the shaded region is rotated 360 degree about the x-axis. Okay, this is the shaded region and we need to rotate this. So what am I going to do? Take the limit. So what is the limit between these two? The limit is 5 and 0 is the limit. So 5 and 0 pi. Okay, first of all I'm going to take the line, the equation of the line.
But it's on the upper side. This is the line, you know, the line is on the upper side and curve is on the under. Curve is on the under. Okay, so minus 0.1x plus 1 square. Okay, minus after getting the volume of the under the line, when the line is rotated about the 360 degree about the x-axis. So the volume of the line minus volume of the curve, and in this way I will get the shaded region, volume of the shaded region. Okay, so now 0 pi, and now I'm going to put the equation of the curve, and the equation of the curve is 3x plus 1 minus 1 upon 4 put this square dx. Okay, let's begin. Now I need to integrate it. Let me just integrate it. Okay, integrate it. So minus 0.1 upon 2 x square plus 1x. Oh wait. So I'll start with the line, taking the constant outside, 5, 0. So what I'm going to do here is, okay, I need to integrate this. So it's going to be 3 multiplied by, and inside must be differentiated. So it's going to be minus 0.1. Okay, so this is the answer. X plus 1, and it's going to be 3. There you go. Now putting the limits, 12, and if I put the limit 0, then it's going to be minus 10 upon 3. Okay, so 10 upon 3 minus 5 upon 12. So I will get 5 upon 12 pi. Okay, so this is the volume of the line, which is this is the volume of the shaded of the area under the line, which is rotated about the 360 degree. Okay, now it's time for the curve. Again, taking the constant outside and differentiating it. Okay, so minus 1 upon 4 multiplied by 2. So minus 1 upon 2. Let's put it this way. It's going to be 3x plus 1 minus 1 upon 2. Minus 1 upon 2. Okay, now we differentiate it. So what it's going to be? Minus 1 upon 2 plus 1. So it's going to be 1 upon 2, which is going to be upon 1 upon 2. It's going to be upon, and we're going to differentiate on the inside as well. So multiply by 3. So 3x plus 1 minus, okay, minus 1 upon 2. Okay, 1 upon 2. So we have integrated. Now putting the limits using the calculator, of course. So 3x plus 1 upon 2 and 0.5 multiplied by 3. If I put 5, I will get 8 upon 3. So 8 upon 3 minus, and if I put 0, I will get 2 upon 3. Okay, and so 8 upon 3 minus 2 upon 3, so it's going to be 2. Now I need to find the total. I need to find the resultant volume, where V2 minus V1. So this is V2, this is V1. So 35 upon 12 pi minus 2 pi. Okay, now let's see. 12 pi minus 2 pi. So it's going to be 11 upon 12 pi, and this is the answer. 11. The diagram shows the curve y is equal to under root square plus 1 plus 2x, meeting the x-axis at A and the y-axis at B. The y-coordinates of the point C on the curve is 3. Find the volume obtained when the shaded region is rotated through 360 about the y-axis instead of x-axis. We are now doing with y-axis, and yeah. So since we now doing with y-axis, first of all we need to know the coordinates of B. What is the coordinates of B? And we know that this is 0, but we need to know the coordinates of B. So y is equals to, I want to know the coordinates of B. So x-axis is 0, and what is the y? So 1 plus 2x under root 1 upon 2. Okay, now I need to put the value. Now I need to put value of x. Okay, so y is equals to plus 1 upon 2. 1 plus 1, y is equals to 1 plus 2, 0, 1 upon 2, and it's going to be 1. Okay, so the coordinates of B is 1 and 0. So we have 1, so we have 1, and we have 0 as the limit. Good. Okay, so if I put the limit, it's going to look something like this. 1 and 0, and then as we all know that pi and x squared dy. Okay, x squared, we need to make x the subject. So y is equals to 1 plus 2x upon 2. Now make x a subject, so y square minus 1 upon 2. Okay, and y minus 1 upon 2x. Okay, now make x a subject. We have made x a subject. Now putting in here y square minus 1 upon 2 square dy. Now putting the constant out, and you can see just 1 upon 2, so 2 to the 4, 1 upon 4 out. Now we're going to do integration, since we have made it simple as much as possible. Y square minus 1 square dy. So we're going to expand the bracket first, before integrating. It's much simpler. So y4 minus 2 y square plus 1. This is 1, right? Yeah, this is 1. And there you go. Now we are going to integrate it. So 1 0. So it's going to look something like, so it's going to be 5 y upon 5 minus 2 upon 3 y 3 and 1 y. Now time to put the limit using my beautiful calculator. Okay, so what is the limit? So 8 upon 15 minus, if we take, 0. This is definitely going to be 0. So 8 upon 15 multiply by 1 upon 4 multiply by 5. What will I get? I. This is the answer. Question 11 is done. 3 minus 2x of power 3 in the tangent of the curve at the point 1 upon 2 and 8 on the point. This is the point. Alright. Find the equation of this tangent, giving you answer in the form of this. Now we need to find the equation of the tangent of the curve at the point. At the point, you can just call it A, the point A. This is point A. Okay. Now we need to find the equation. So what I'm going to do, I'm going to differentiate the curve. Okay. So let's differentiate it. So we just differentiate the curve. Dy upon dx is equals to, 3 multiply by minus 2, because we need to differentiate on the inside as well. 3 minus 2x and 2 is the differentiation. So 3 to the 6 minus 6, 3 minus 2x, 2. Now we need the point, and the point is 1 upon 2. 1 upon 2 is the point. X is equals to 1 upon 2. Alright. So if I put 6, 3 minus 2 multiply by 1 upon 2 square. So what will I get? I'm using a calculator now. Minus 24. Minus 24 is the gradient. Okay. So minus 24 is the gradient. Y is equals to minus 24x. See, we will use up coordinates. So 8 is equals to minus 24 multiply by 1 upon 2 plus c. And what will I get? So what will I get? Minus 24 upon 2 minus 12, 8 plus 12, 20. So the constant c is 20. The constant c is 20. So y is equals to minus 24x plus 20 is the equation. Okay, now find the area of the shaded region. First we need to know the limits. So this is the shaded region and this must be the limit. So the limit is 1 upon 2 and 0. This is the limit. First of all, we're going to take the area under the curve, and then we're going to subtract by area under the line. This is how we're going to do it. Okay, so let's take it. First of all, let's see that what is the equation of the curve is. The equation of the curve is, 1 upon 2 is the limit. The equation of the curve is 3 minus 2x about 3 dx minus limit 1 upon 2, 0. And the equation of the line is minus 24x plus 20 dx. Now let's do the work. Okay, so 3 minus 2x of our 3 minus 24x plus 20. Let's start. So let's integrate. So it's going to be upon 4, and then we're going to differentiate on the inside, so multiply by minus 2. So 3 minus 2x 4. We got this 1 upon 2, 0. Now we're going to, I'm going to use a calculator now. It's 2. Okay, minus 2 and 21 on 8. Now what is the area under the curve is 65 upon 8. Now finding the area under the line, just like we have seen this, that, yep. Now let's find the area under the line. So it's going to be 2 minus 24 x squared plus 20 x. We have integrated. Now putting the limit minus 0. Okay, and now finding the resultant shaded region. 65 upon 8 minus 7. What is the shaded region? So 65 upon 8 minus 7. and I will get 9 upon 8 as the answer. Okay. Question 13. The diagram shows part of the curve y is equal to this and a point P, this lying on the curve. The line PQ intersects the x-axis at 8, 0 coordinates. Show that PQ is normal to the curve. Let's do that. PQ is normal to the curve, but additionally I will just try to find the equation as well. So let's start with part 1. The equation of the curve is, so I'm going to differentiate this, 1 plus 4x, 1 upon 2. Okay. Now dy upon dx. So, okay, dy upon dx. So 1 upon 2, and then differentiate on the inside as well, so multiply by 4. So 1 plus 4x minus 1 upon 2 is the differentiated. So do 1 plus 4x minus 1 upon 2. Now we need to put the value. What is the value? So we need to find the gradient tangent to the point, and then we will find the normal. 6 must be the value of x that we need to put in order to find the gradient of the tangent at that point P. So x is equals to 6. So putting the value to 1 plus 4 multiplied by 6 minus 1 upon 2, and what will I get? To 1 plus as the gradient of the tangent to the curve at that point. Okay, and if I do reciprocal, if I use m multiplied by m is equals to minus 1, then 2 upon 5 multiplied by m to minus 5 upon 2. This is the gradient of the normal this is the gradient of the normal PQ. And if I want to prove that this is the normal of the PQ, now okay, so I will use these coordinates and let's see if I get it right. So y2 is 5 minus y1 is 0 upon x2 is 6 minus x1 is 8. If I do it right, then it is indeed proved that PQ is the normal to the curve. But I want to go even further, and I'm going to find the equation of this. So what is the equation? Y is equals to minus 5 upon 2 x plus c. I put the equation, this one, then 0 is equals to minus 5 upon 2 multiplied by 8 plus c, and c is equals to, okay, so the equation is y is equals to minus 5 upon 2x plus 20. This is the equation of the line PQ. Now part 2, showing all necessary working the exact volume of revolution obtained when the shared region is rotated about the x-axis. First of all, let me just find the limit. What is the limit of the curve? The limit of the curve, if I take the horizontal, if I take the horizontal line, then the limit of the curve will be 6 and 0. Okay. And also I need to add up 8. This would be the triangle, since it's 90 degree. Okay. And the left side will be the curve. So I need to add them. I need to add them all up. So the exact value of volume, the exact volume of revolution obtained when the shared region is rotated about 360 degree about the x-axis. Limit is 60 pi 1 plus 4x 1 upon 2 square dx plus, as for the line, 86 pi, the equation is minus 5 upon 2 plus 20 minus 5 upon 2 x plus 20 square dx. Okay, now let's do it. Taking the constant outside, then 1 plus 4x 1 dx. Now if I do it correctly, then it's going to be like this: 1x plus 4 upon 2x squared. Okay, and if I put 6, then it's going to be 78. Okay, now for the line, plus 6, constant must be out. Now let's expand this bracket. So 25 upon 4x squared minus 100 x plus 400. We have expanded it. Now I need to integrate. So it's going to be 25 upon 8, or maybe not 8, 25 upon 12 minus 100 upon 2 square plus 400 x 8 6. Now let's put the limit using my beautiful calculator. 8200 upon 3. Okay, and what is the other one? 50. Okay, so what is the total? 3 minus, so it is 50 upon 3. Now adding them up, and I will get 284 upon 3 pi as the answer. 14, the diagram shows part of the curve y is equals to x minus 2 of power 4 and the point A on the curve. The tangent at the A cuts the x-axis at B and the normal at E cuts the y-axis at C. Find the coordinates of B and C. Okay. The tangent of the curve, this is the tangent. And this is the normal. So it's going to take me a lot of time, but let's do it. First of all, I need to differentiate this curve. So let's differentiate it. Y is equals to x minus 2, 4. Differentiate this and dy upon dx, 4 x minus 2 of power 4, 6. If you try to differentiate, it will leave only 1. So multiply by 1, but it doesn't make a difference. So 1 multiplied by 4 is 4, you know. So it's actually 4x minus 2, and sorry, this is also 1. So 3, yeah. This is the derivative of the curve. Now, we are going to put the value, okay, we're going to put, we have this coordinate, so 1, take this, which is at here, okay. X is equal to 1, and you put the value, then for 1 minus 2, 3, and m is equals to, let me use a calculator, it's minus 4. Okay, this is the gradient of the tangent at the point, the curve. So y is equals to minus 4x. See? And now if I put the value 1, 1, putting the value 1, 1, 4, 1 plus c, and it's going to be 5 is equals to c. Okay, so the equation at the tangent of the curve is minus 4x plus 5. This is the equation of the tangent to the curve. This is the equation of the tangent. Now I need to find the coordinates b. So, x, we need to find the coordinate, we need to find the value of x and 0. If we put y is equals to 0, so let's put 0 is equals to minus x plus 5, minus 5, minus 4x, cancel, 5 upon 4x is the value. Okay, so the value of x is 5 upon 4 of the coordinates b. Now I need to find the coordinates of c. Before that, I need to make sure, okay, so the coordinates of the tangent is, you know, if m is equals to minus 4, then m multiplied by m minus 1, so minus 4m plus 1, and minus 4, cancel. So m is equals to 1 upon 4. Okay, this is the gradient of the normal. So y is equals to 1 upon 4x plus c, putting the coordinates. So 1 is equals to 1 upon 4 multiplied by 1 plus c, and the value of c is, okay, minus 1 upon 4. So it's actually 3 upon 4. So this is the equation of the normal. Now I want to know the coordinates of c. So it must be like 0 and y. So I need to put x is equals to 0. If I put it, then it's going to be 3 upon 4, which means 0 and 3 upon 4 are the coordinates. Okay. Part 1 is done. Part 2, find the area of the shaded region. Fine. As you can see, first of all, I need to find, okay, let's put this as D, the point B, and I want to know the coordinates. What is the value of x when it is 0? So I'm going to put y is equal to 0 on the equation. So 0 is equals to x minus 2, 4, it's gone, and the x is 2. So it's 2 actually. Okay, so 2 and 0. So now let me just clean this up and let me draw a line. This is a line, and you know, the limit will be between 2. The limit is going to be between 2 and 1 and 1. This is the limit. Okay, this is the limit of the curve, and also we need, okay, this is the limit of the curve, and the limit of the line will be 5 upon 4 and 1. Okay, this is the limit of the line, and this is the limit of the curve. So finding the area under the curve minus finding the area under the line of the tangent. Okay, let's begin. So 2, 1, yeah. Let's start from here. 2, 1. Since we need to find the area of the shaded region, so we're going to put the equation x minus 2 of power 4 dx. Okay, again 2. No, it's going to be, yeah, it's going to be, wait. So this is 2 and 1, and so it's going to be 5 upon 4, and it's going to be 1. 5 upon 4 is actually 1.25. Okay, and the equation of the tangent is y is equals to minus 4x plus 5. So minus 4x plus 5 is the equation. Now let's begin. Okay, let's do the integral. So it's going to be 5, and differentiating it, it's going to be multiplied by 1. Doesn't make a difference. X minus 2 and 5. There you go. We make the integral. 2 and 1. Okay. Now minus integral this one. So 2 minus 4x squared plus 5x. It's the integral of this one. 5 upon 4 and 1. Now let's start the curve again. And I'm going to use my calculator, my beautiful, lovely calculator. Okay. And it's going to be 0. Okay. So it's going to be 0 minus. And if I put 1, then it's going to be minus 1 upon 5. So it's going to be 1 upon 5. Good. And as for the line, using a calculator, of course, 8 And if I put 1, then it's going to be 3. Now let's see what would be the area. 25 upon 8 minus 3, 1 upon 8. So this is the area of the line. So 1 upon 5 minus 1 upon 8. What's going to be? So it's going to be 3 upon 40, which is the answer. Okay. So the diagram shows part of the curve, this defined by x greater than 0. Okay. Find showing all necessary working the area of the shaded region. Okay, so we need to find the area of the shaded region. It's simple as piece of cake. So the limit is 1 and 0. Okay, the limit is 1 and 0. So this is 1 and this is 0. So 1 and 0. Okay, and 1 upon 2 x power 4 minus 1 dx. Take the constant out. Okay, taking the constant out, make it more simpler. Now x power 4 minus 1 dx. Now let me just integrate it. Okay, 1 and 0. So after integrated, it's going to look something like this and something like this. We have integrated. Now we're going to use the limit. We are going to apply the limit. So the limit is, let me use the calculator once again. So minus 4 upon 5. Okay, minus 4 upon 5. And if I put 0, then it's going to be 0. Okay, 0. 1 upon 2. So minus 4 upon 5 multiplied by 1 upon 2, it's going to be minus 2 upon 5 is the area. This is the shaded area of the shaded region. Part 1 is done. This was part 1. Now you can see in front of you, you can just notice that this is in minus. Do you know why? Because this curve is below the x-axis. This is below the x-axis. That's why the area that we just calculated is in negative. If it was above the x-axis, then it would be positive. If it is below the x-axis, then it would be negative. Okay. Part 2. Let's do part 2 now. Right now. Part 1 is done. Part 2. Find showing all necessary working the volume obtained when the shaded region is rotated about the x-axis. Okay. The same limit applies 1 and 0. Let me do it right on the left side. Okay. So the limit is 1 and 0 pi multiplied by 1 upon 2. This is 1 upon 2, right? 1 upon 2 x of power 4 minus 1 and square dx. Forgot to put dx. Okay, let's begin. First thing first, putting the constant out. Pi is out and 1 upon 2 square, so 1 upon 4 is out as well. Now what we got left is x of power 4 and it is 1, right? Yes sir, it is 1. It is 1 square. Now let's integrate it. But first let's expand it. We can expand it or we can integrate it just like that. It's up to us. But let me just expand it. Because if I expand it, then it will be much more simpler than before. So I'm going to expand this. And so it's going to look like this. Minus 1x. Oh, sorry. So let me expand this. X of power 8 minus 2x of power 4 plus 1. Now we're going to do the integral. Okay, and doing the integral, we are doing 9 x of power 9 minus 2 and 5 x of power 5 plus 1x. Okay, pi upon 1 upon 4. Now we will use the limit. So let's use the limit. Let me use my calculator, my beautiful calculator first. So it's going to be 32 upon 45. And if I put, okay, if we put 0, then it's going to be 0. And what we have here is 1 upon 4 pi. Now multiply this upon 1 upon 4, and it's going to be 8 upon 45, which is, yes, this is the answer. This is the volume. Okay, part 2 is done. This was part 2. Now part 3. Find showing all necessary working the volume obtained when the shaded region is rotated about the y-axis instead of x-axis. Now we're going to do with y-axis. Okay. So before going, first of all, let me see what is the limit. The limit will start from here to here. Okay. So minus 1 upon 2 to 0. So 0 and minus 1 upon 2 is going to be the limit. Okay. So let's do this. So let me just do in here. First of all, let me see. Okay. So limit is, so limit 0 and minus 1 upon 2. Okay, then there comes pi. And oh yeah, another thing for you guys to understand, we need to make x the subject. So we're going to make x the subject. Let me write it down in here. So y is equals to 1 upon 2 x of power 4 minus 1. If we put, now we need to make x the subject. So 2y plus 1
so power 4. And now 2y plus 1 is 1 upon 4. 6 to x. This is what we really needed. Okay, let me just do it right here. Let me do it right here instead of there. So the limit is 0 and minus 1 upon 2. Then we got pi. We got pi, and then what we got here is 2y plus 1, 1 upon 4. Then you can just, square it and dy. There you go. Now let's begin. Let's start first of all putting the constant outside. 0 minus 1 upon 2. So it's going to be 2y plus 1 upon 2 and dy. Now we are going to do integration. So let's do this. Okay, 2y plus 1. So 1 upon 2 plus 1 is going to be 3 upon 2. Okay, 3 upon 2. Now we need to integrate this, so it's going to be multiplied by 2, and then 2y plus 1 is 3 upon 2. We have done the integration. Now we're going to do the limit. So the limit is going to be okay, this anyway, 2 cancel out, leaving only 3. So if the limit is 0, what's going to be? It's going to be 1 upon 3. Okay, and if it was minus 1 upon 2, what would it be? Minus 1 upon 2. Then it's going to be 0, which means, my dear audience, the answer is 1 upon 3 pi as the volume. So this is the answer, and my dear fellows, we have done all the beautiful questions. We have found the volume, and congratulations for completing A-Level Math P1 course. And I hope really that I will see you guys on the next course, which could be SAT 1 Math, SAT 1 2, A-Level Math 2, or A-Level Math P3, or A-Level Math S1, or A-Level Math M1, or starting with A-Level Physics, or A-Level Computer, or Chemistry, or anything like that. Leave me, you can drop down you can give me the comment down below for the next course, and I hope I'll see you guys in the next course.